आता बरोबर आहे. मग हाच राहू द्या. ह्याचा माईक हे डिॲक्टिव्ह करा.
एक काम करा, मी व्हिडिओ बंद करतो आता परत आवाज येतो का बघ ना, मायक्रोफोनचा घेऊन नसतो ना ऑडिओ, हे व्हिडिओ बंद असताना. आता बोलतो तेव्हा चालू करा.
हॅलो
हॅलो प्रथम,
माझा
माझा आवाज येतोय?
हो.
आय एम ऑडिबल? ओके.
ठीक आहे, झालं आता हे.
CTiS conference was held in Pune in April 2019. The second and the third editions of the conference were held as virtual events in October 2020 and September 2021 respectively. Both were greatly successful and were well received by the teachers and educators. This year's conference is being held in a hybrid model for both convenience and safety of the delegates, considering we are still not completely out of the pandemic scare. The CTiS conference has brought together teachers, educators, and researchers from the national and the international arena to discuss, share, and learn about the innovations in curriculum, pedagogy, policy, and the implementation of computational thinking in schools. It is a proud moment for Kaveri Group of Institutes, Dr. Kalmari Shamra High Schools, to be invited to co-host the CTiS Conference 2020 along with SLTR, PICT, and ACM Student Chapter. Our long association with CSpathshala started in the year 2016 when we had an agreement with CSpathshala to be the pilot school for the implementation of the CSpathshala curriculum, and since then we have not looked back and have experienced significant transformation in the pedagogy of computer education in all our schools. CSpathshala facilitated a number of professional development workshops that helped our teachers understand how implementation of CT or computational thinking leads to students developing 21st century skills of problem solving connected to the real world. It helped the teachers make a major shift from teaching computer theory to enabling the students to think, explore, and create using computational thinking skills. Our collaboration with CSpathshala has given opportunities to teachers to facilitate teacher training sessions as master trainers, not only in urban, but also in the rural schools. A workbook with worksheets and assignments for students was designed by KHS team, which was highly appreciated by the CSpathshala team members. CSpathshala curriculum over a period has encouraged our students to use algorithm, decomposition, pattern recognition strategies, thus developing their logical and reasoning thinking skills. The introduction to these innovative learning strategies has also contributed immensely in the success of our tinkering program in all our schools, as it paved the way for solution finding through critical and creative thinking in the early years among our students. As a result, our Utter Tinkering Lab, in collaboration with the computer department, has been able to handhold our students through the journey of prototype to product, which has brought laurels and recognition at the city, state, and national level. Our teachers have had the fortune of presenting their papers in the CTiS conference since its inception in 2019. And this year, it's a very special year for Kalmari schools because we are celebrating the Golden Jubilee year. Our teachers have made us proud as 7 teachers from Kalmari schools have been selected to present their ideas ranging from CT in math to language to CT and NEP and the TAC challenge on this enriching platform of CTiS. In conclusion, I would like to congratulate all the conference delegates for joining us both in person and remotely, and wish good luck to all the presenters as each one of you has embarked on a journey of self-motivated learning, of which is going to help bring change in big or small way with your innovative and meaningful presentations during the conference. All the best. Thank you. Thank you, Mrs. Pallavi. Now request Professor Pooja to address the gathering.
Hello. Good morning, everyone. It's my great pleasure to welcome you, all the delegates who are present in this room and also who are joining online. So, we are primarily research and teaching organization, the ISER Pune, but we recognize at a very deep level the contributions that educators in various schools and colleges make to the education in the country. And we think that we are partners with a very deep connection. So we cannot develop a environment of or a scientific and temperament and a mathematical temperament within the next generation alone. We need to work together in promoting this. And as a result, the Institute takes these activities very seriously, and the Institute itself is deeply involved in various outreach programs. Every week almost, we have one popular talk or on science topics that is broadcast live on YouTube, meant for school children. And besides that, a lot of our professors deliver popular talks, interact with schools, and we also host many teacher training programs at ISER Pune. So it's again, a great pleasure to be able to address you, and I thank the organizers for giving me this opportunity. And I'm also very impressed by the main theme of your conference. This is, computational thinking. My children, for instance, they are going to school, and this idea that computation doesn't just mean computers or calculators, but a lot of it is about thinking in your mind and your analytical skills. I think the focus on this is a very brilliant idea and a very necessary and timely one. And I do hope that you'll have a very, very successful program, and also that you will enjoy our campus, and that we'll be able to form more connections with you. For your information, the Institute is in the process of actually establishing a new department of science education. And when it comes to fruition, I think our activities and collaborations will increase further. So again, welcome, and thank you.
Thank you, Professor Pooja, for your wonderful words. I will request Mr. Vipul Shah, the Principal Secretary of TCS and the Head of CSpathshala, to address the gathering.
Yeah, good morning, everyone. It's so wonderful to see all of you. I think it's been so long, and to meet in person. And I think some of you are meeting after many, many years. So I think it's, I hope we can catch up over these 2 days. I'd love to hear and share with you what we have been doing, what you have been doing, and I look forward to connecting with each one of you. So since it's been so long, I didn't know what I should be talking about. I said maybe I can just reiterate what we have been doing, and it will just bring everybody together, everybody on the same page. And so that let me start with that. All right. So, as you all know, we started this in 2016. There are a few people here in this room who kind of, I should say the word conned me or into starting this thing. And there are two of them here. And that's how this thing started. And I think the shape it has taken in these few years is far beyond what we could have imagined at the time when we started this initiative. And all of it is thanks to your support, thanks to what you have been doing in the classroom. And I think thanks to you, we have been able to do what we can. The numbers are there. So one of the things I think while we're getting this, this is always the case. We always have a struggle with technology, and whatever we do, how many number of times we do this, will always the next time around we will still be struggling, right? So while we do this, I think one of the things I would like to acknowledge is all the efforts that not just all of you, all the volunteers in this initiative have put in. I think it's all because of the volunteers that we are able to do what we have done. And you know what makes me so happy is that we started with a group of people, it grew, and now all of you are part of that, right? Each and every one of you, so many of you going and training other teachers, going and taking this conference itself is run by all of you, right? So I think this is something that is what makes this sustainable, and I think this is something which we can continue with. Okay, yeah. So we have some numbers. I think all of you know this. I think we, frankly speaking, have lost track of the number of students we have reached. I think at some point in time we stopped counting and we left the number as is because there are so many people involved, so many schools involved. But what I really like is these are real numbers that you have given us. These are not some computations that we have done. The volunteer count also keeps on increasing every time. I think what Jam did with Tamil Nadu, I think that is something that we hope we can do at more places, especially with the new curricular framework, the NEP 2020, laying emphasis on computational thinking, on design thinking, on coding and other areas. We are hoping that more and more of schools, more and more of governments can incorporate it. Just for the information of all of you, I think what Tamil Nadu has done is they have integrated computational thinking into their math curriculum, right? So I think this since 2018, over the years, they have been increasingly now adopting this across all the SCRT schools, which are pretty large in number, right? So I think this is one approach. I think we're also working on suggesting various models in which this could be implemented, but I think this is something which makes it sustainable. One of the important things for us has been connecting with all of you, right? Creating a community which could be self-supporting, creating this, and there are different ways we have been doing this. CTiS is one, this conference is the fourth year, and the whole idea is to provide a platform where you can connect, you can share, you can network, you can learn from others. All of that this makes it possible, right? This is the stage for you to shine. This is for you to tell your story of what you have done in your classroom. And this is something which not just we would like to hear. I'm sure a lot of people out there would like to hear. They'll be inspired by what you are doing, and believe me, they would go back to their classrooms and try to do what you are also doing. So I think in that sense, this as a platform has been serving very well. I think during the pandemic, we tried to do different things. We did webinars. We did connections. We try to connect with people who have been working in this field, international speakers, people who have done, people who have, people who in fact coined the term computational thinking itself. We have Janet Ling also as a speaker, and many others, Tim Bell and others have done some pioneering work in this area. So I think that's what we are trying to bring to all of you through this initiative. I think that's about it. I have a few slides, but I don't think that is. It just shows that there's one more thing that I wanted to touch upon. I wanted to thank all the people, apart from the volunteers and also the organizers. I want to thank Iser for giving it, working with us for this to make this possible. Sonia, I wanted to put up a couple of pictures. The last time we did this, it was just before the pandemic. We had a training program in the auditorium then, and we were planning to do the workshop in 2020. Unfortunately, that couldn't happen due to pandemic, and I'm glad that we've come back and we're doing it here. Thank you so much. And I would like to thank all the other people who have worked with us over the years on this. Great. So thank you very much, and I'm looking forward to, as I said, a very fruitful discussions, hearing about what you have done, and I think, wish everybody a wonderful day. Thank you.
Thank you very much, Vipul. Can we have Meenakshi on behalf of the PC to address the question?
Yeah, very good morning. Sorry for the slight delay. This is a small report of the summary of the abstracts that were selected for this conference on behalf of Pradeksha and I. Pradeksha is out there, my PC project. I took the liberty to present on both our behalf. Yeah, I think by now this has been beaten to death. You all know what CTiS is. It's the annual conference of CSpathshala. And the goal is to provide a forum for teachers, educators, and other advocates of computational thinking to meet, exchange, and have a healthy interaction of all their ideas and thought processes. And we are now in the 4th edition of the conference. The first one was held in Pune, second and third virtually, as it's been told already. And glad to meet you all as a part of the 4th edition. Hearty welcome. Yeah, so this is a tale of numbers as far as CTiS history is concerned. So you can see that we're slowly and steadily growing in terms of the number of accepted abstracts. So when we began, there were 55 submissions and 9 accepted. And the pandemic indeed was helpful. There were a lot of submissions, but very few acceptance, maybe because it was difficult and the quality was not good. Everybody was adjusting to the pandemic and so on. Then we began picking up our strings in 2021, second edition, which was also held virtually. And in the final edition, we did have more than 185 submissions, but 185 were reviewed. And you can see that the quality is distinctly gone up. And the number of quality submissions that are going to be presented today, which have probably the best kind of implementations of CT across the things, is 37 in number. So as it has been stressed upon, the highlight of this meetup, this conference, is the presentation by the teachers. It's for the teachers, by the teachers, and their interactions. So along with the teachers' presentations, we also have 4 invited talks, again, all on computational thinking at schools, colleges, at different levels of education. We have eminent speakers talking to you about computational thinking and how they have worked to promote it in schools. In the past, we've also had panel discussions when we were online, and we've had breakout rooms in the past editions, but we're not doing that this time. Last year, we also had one workshop on computational thinking for children with special needs. So that workshop is expanded into a full session this time on tactile tools for spreading computational thinking for children with special needs. So we do have one exclusive session later today on the TACT challenge presentations. So please do stay back, and it constitutes a very important part of this today event that we are here for. Yeah, so we actually received 232 submissions, totally overwhelmed. Thank you very much for all of that. So we did some initial screening to ensure that they were indeed talking about computational thinking and nothing else. And after that initial screening, 185 were reviewed by members of the program committee and other reviewers. And I'm glad to say that 37 submissions will be presented today, out of which 31 are the teacher abstracts, which represent implementation of computational thinking across schools. We've also segregated other kind of presentations, which involves organizations, other groups, and networks that are trying to promote and propagate computational thinking amongst the teachers. So that's a separate category. So in all, we have 37 presentations, as I told you, 4 invited talks and the grand challenge demos. Yeah, so heartfelt thanks to the members of the program committee. You see that we are lots of them. We need so many of us to review all your work, and we come from quite a spectrum. I'm probably the most outlier here because I'm not involved in teaching, but a lot of the program committee members are actively involved in school teaching, in teaching of computational thinking. A big thanks to the PC members. Yeah, big thanks to organizing committee also, headed by Pallavi and Gitanjali, for all the work that they've put so that we could be together today after 2 years of pandemic. Thanks so much to the organizing committee members. Yeah, and as I say, it takes a village to raise a child. So apart from the PC, we needed a whole band of reviewers to review the number of abstracts that we have. So big thanks to all the reviewers who helped us out, who were not in the PC, but did a lot of reviews to ensure that The abstracts that are presented today are indeed the best amongst the ones that were submitted. Thanks to all of them. Yeah, so there are a whole set of other vital teams. There's publicity committee, ably headed by Sonia. It's very difficult to keep pace with the amount of energy that Sonia has, and it's needed for an organization like CTiS. And we also had Chai Pe Charcha, which, if I know it right, was started last year, and this time it was very, very successful. So many sessions, I attended a couple of them. I think we had 700 plus teachers attending these sessions, and they were indeed helpful for them to come forward and submit the abstracts. There are so many WhatsApp groups, which I wasn't a part of because I can't keep pace with WhatsApp, and mailing lists, and PICT students as webmasters, managing the virtual conference events, thanks to all of them. And of course, the special team that managed the TAG Grand Challenge end-to-end. A big thanks to all of you. Yeah, so this is just a brief on the 4 invited talks, 2 today and 2 tomorrow. We begin with Professor Paul Curzon from Queen Mary University of Technology at 2 o'clock. He'll be virtually present, and he's going to talk about his work on CTE in schools. And from 6 to 7, we have Sriram Krishnamurthy from Brown University, who's also been working a lot with teaching computer science in schools. So he's going to be talking about his kind of work. Tomorrow we have Madhavan and Venkatesh talking about their work on, and their book basically, which is an excellent read on what they did to implement computational thinking amongst growing data scientists. And finally, we have Janaki from Delhi, who's going to talk about Janaki's talk. She said is going to be very interactive, and she's going to make the teachers do a lot of work as a part of her talk. So let's see what she's going to do. Yeah, so there's also TAG Grand Challenge, which will be displayed today. It's a special thing for CTiS2022 edition. It basically talks about tactile tools to teach computational thinking to children with special needs, because a lot of CT concepts are visual, which a visually impaired child cannot go through. So this talks about touch-based tools to teach computational thinking to children. And thanks to Supriya, Sonia, Jam, and Swami Manohar to have put this together. They received 30 submissions, again, totally overwhelming number. Thanks a lot. And they decided to accept 11. And please do stay back and look at all the interesting demos. Yeah, a grateful thanks to all our supporters and sponsors. I think sponsors have already been shown, so many of them. TAG Grand Challenge partners, then organizers, and our hosts, ISA Pune. Thanks so much on behalf of the PC chairs. Yeah, finally, I'd like to end with one of my favorite verses. I'm sorry, I'm not familiar with Marathi, which I put a verse in Marathi, but that's not familiar with the language. So I'll end with one of my favorite verses on education, which is from Tirukural. So it says, whatever you learn it thoroughly, and for the rest of your life, let your conduct be worthy of your learning. If you have to read it out in Tamil, it says, Karta Kasada, Katravai Katrapin, Nilta Adakataha. So let's all get together for 2 days, learn a lot, and go back and implement CTE in the schools. Thank you.
Thank you, Meenakshi. We now start the session. Handing over to Peter.
Thank you, Savita. Good morning. A warm welcome to each one of you in the first session of CTiS 2022. Mathematics and computational thinking are closely related, and I think that's why many schools have adopted computational thinking, which is integrated with ICT and mathematics. So the first session is on the theme CTE in mathematics education, and the first presenter is Manasi Nimbargi. She's from Kalmadi Shamrao High School, Ganesh Nagar, Pune. Her topic is integrating sports actively into maths to overcome the challenges students face in understanding elements of a graph. So this is under CT and math education. Over to Manasi. Come. Tilmadi Shamrao High School, Ganesh Nagar. I teach mathematics for the grades 7 to 10 in my school. And the topic of my today's presentation is integrating sports activity with math to understand the elements of graph under the category of computational thinking and the math education. During the pandemic period, we had conducted one subject integration project, and we understood that the topic for the subject integration project that we had given to our students was the relationship of statistics with day-to-day life. The submission of project was done on the Google Classroom. During the assessment of this project, we understood that there are some shortcomings, there are some loopholes, there are some learning gaps. And when we teachers observe what are these learning gaps exactly? Actually, in the lesson designed by NCERT textbook, that is data handling, the same course was explained to the students during the online mode. And then we observed that there are little shortcomings in that. For example, we can see here. As we can see here, the electricity bill for the month of January to May was collected. And we can observe here that for the month of May, the electricity bill is 0. Real-time data collection was asked to the students. And we observed that for the month of May, electricity bill was collected as 0 rupees, which is not actually possible. We can go to the second one as well. In this, we can clearly see that the spacing on x-axis, actually when we teachers talk about the presentation of bar graph, we specially emphasize that the spacing on x-axis should be uniform. And here we can see that the spacing on x-axis was not at all uniform. Even the scale taken on y-axis was varying. It was changing continuously. And these two things made all the parent teachers to think again what we have exactly explained to them and what our children have actually taken from this. So that is the reason we thought that there should be something which is to be incorporated now. And that was nothing but the sports activity. And that is the reason sport activity was integrated with mathematics to explain the elements of graph once again. And that's how the activity actually channelized or it was started. And if we see the activity now, for conducting this activity, a simple program was designed. We had divided our classroom into 5 groups. Approximately there are 45 students in every class, and we had taken approximately 9 to 10 students in every group. First of all, the first part, the very first stage was dividing the class into small chunks so that we will come to know that each and every one, whether they are getting these concepts or not. We were going to do the hands-on activity with them. So the first part was dividing the classroom. Now, the next thing is that a simple sport activity was designed with the help of sports teacher to complete the number of skips in 1 minute, and that is to count, that is to record. That was the thing. So, while doing this activity, students themselves enrolled into different groups, and we observed that. Here in the first picture, we can see that while one student was performing the skipping activity, the other friends were actually with the help of, they were keeping the time. Some of them were actually noting down the count. And like this, for the first group, the 9 observations were collected. And this was nothing but the collection of real-time data. As we observed in the month of May, the electricity bill was 0. And here we observed that what is exactly the real-time collection of data. So the data was not collected. The second step was now to present the data. So initially children presented it in the form of tabulation. The number of students were names of the students and their count, whatever it was, that was presented in the form of tabulation. Now here we explain students that the same thing can be presented in the form of group of 5. That is, tally marks were introduced for the first time, which is required while making frequency distribution table that was introduced at this moment. So tally marks, or suppose the count was 76 or it is 91, any odd number suppose it is, then how it can be presented with a group of 5. That was first of all told to them. And it was did by all those 9 students in the form of frequency distribution table. The half job was done here. Every single child was involved in this process. The next was now taking them on the ground to perform the activity. For this purpose, an area of 10 by 10 square feet or 100 square feet was actually allotted. Every child was going to show or present his individual score over there. On the y-axis, we had, that is the dependent variable, the number of counts, the number of scores completed in 1 minute were presented. On the x-axis, that is the independent variable, where they had taken their names. In short, students have named themselves as S1, S2, S3, and so on. So for the first group, for the first 9 children, the data was collected and it was shown. By showing it, now we can observe here that how the children had taken on y-axis, 1 foot is equal to 10 counts. The score of 10 was showing here. Now, after showing all these things, we can see here in the very first picture that with the help of chalk piece, all the 9 scores were shown by them. And it was observed that they themselves understood that. For example, a count of 76 I am taking, then 76 is between 70 and 80, that they were knowing. But 76 is not only between 70 and 80, rather it is closer to 80. 93 is not only between 90 and 100, it is closer to 90. And that is what approximate presentation of graph was done. And that is what we observed there, that they were able to do this very confidently, very carefully. The next part and the last part of this project was to take them for the accurate presentation on the graph paper. We asked them that 76 you are presenting near to 80 or 91 close to 90, that is very much well. But how to present the same data accurately now? And here the graph paper was introduced. They were asked that to present such odd numbers which are not multiples of 10. What list count you should know or how the scale can be selected. As it was an activity where a simple natural numbers were counted, that's the reason the scale selected was 1 centimeter is equal to 10 counts. So when 10 counts were taken, everyone was able to tell that 76 means, ma'am, after 70, the 6th line. 91 means above 90, first line. Whereas in our initial submissions, we observed that 91 was by mistake taken as even 81. 76 was by mistake taken as 77. So this time they understood that what is going to exactly count. And with the help of all these things, the data was presented in the form of simple bar graph that we can see in the next picture for the group 1. And this is what we did with our group of students. This is what the activity which we performed. Recently, after 1 month, I actually checked that the same group of students had presented their attendance for a week in the form of bar graph. And it was a wonderful job that our students did. So through all these things, we, myself or my team of teachers, we understood that certain concepts are there in mathematics. Instead of just taking them in the 4 walls, okay, or with the help of chalk and duster, better to take our students outside, let them explore, let them experience that. And this experiential learning makes a remarkable change. Whatever they learn through this, we can just see to the next slide. These were some of the feedbacks that our children registered, what they felt during this process. And these feedbacks or these things made us to realize that what is the role of experiential learning exactly. So this is what from my side. Thank you so much for giving this opportunity. Any questions?
They know that how to compare between the groups. And so divided into 9 groups, right?
Yeah, 5 groups. The class was divided. 9 students were there.
So any comparison, like, alphabet-wise, which movies?
Yeah, correct. When they presented in the form of bar graph, they could compare their performances now. They could come to know that within 1 minute, what is my score and what is my classmate's score. They could easily compare that. So this helped us not only to present, rather to compare your performances as well. And in future, you can just extend this for double bar graph or in the form of percentage bar graph, the same thing can be extended. Rather, I can say that percentage bar graph can give more clarity about the same performance. Any more questions? Any comments?
It's really very nice experiment, and really, I think students must have enjoyed it a lot.
Yeah.
And basically, when we are doing subject like statistics, and because I am myself a statistician, so I can very much relate to it. That especially when in school level, at least mathematics text as the last topic of statistics.
Yes.
So according to me, it is always the thing and only the topics for scoring full marks. So rather than when it comes on the playground, it becomes the most important topic for children. And I think you have done, this is a very good thing you have done for all of them.
Thank you so much. Excuse me, ma'am.
Experiment was really fun. And what I liked the most was drawing graph on the ground. That was, I mean, very novelty, and kids must have enjoyed it and all.
Yes. Because taking the pencil and helping them to draw it on the graph paper was earlier done in the online mode. I thought that instead of that, let us give the chalk piece, let them show their scores, what they have exactly done. And as Sir said, we can easily compare that as well. And that comparison was not only for the 5 groups, it was amongst individuals as well, which they observed. So what I believe that instead of doing all the things in the classroom, we can do certain things outside the class as well, and which marks a remarkable change in the learning things, which I observed actually just now while plotting it for the school attendance, for the class attendance rather, for this June month. The same activity was done. Thank you so much. Thank you, Nancy. That was really a wonderful experience. I think the teachers sitting here are able to correlate with their classroom. Thank you so much, Nancy. Next presentation we have by Vrinda Ingole and Vaishnavi Thakre from School of Scholars, Yavatmal. The topic is CTE in Mathematical Practices. Vrinda and Vaishnavi.
Good morning, one and all, and nice to meet you. Myself, Vrinda Ingole from School of Scholars, Yavatmal, and along with my colleague Vaishnavi Thakre. And today's our topic is CTE in Mathematical Practices. We have 2,000 students from grade 1 to 12, and 9 teachers are involved in CTE, and we are getting 1 period per week for CTE. The term computational thinking has gained considerable global awareness in the past decade. Most of the developed countries already included CTE in their curriculum to develop students' thinking ability. As we know that our mega group of schools takes such an initiative to help students develop their thinking ability, has integrated CTE in our curriculum from 2018. The paper states about the activity standard for the grade applied knowledge which they had gained from CT model 04 IPP 01 to create a different pattern. Now our first activity, using pattern to make code. In the online class, the teacher has conducted the activity under the topic shapes and pattern to by taking odd numbers series to code and decode the message. In this activity, student has decoded the decoded the message with the help of a pattern in which is mentioned in the given image. Now, each and every student is unique. So, we have got a lot of variations in this activity. Student has a use of mathematical symbols, Devanagari lipi, multimedia tool, Roman numerals to create a different patterns. And student also created the different patterns by using different codes, and also they decode the messages. Some slogans are decoded by the student. They just save water, save life, I love math, like this.
Good morning, everyone. So let's continue the second activity which was conducted on the occasion of the party. Here we can see in the first image that student has converted the Bebra's challenge question in the form of the model to make the problem interesting. They created the model to make it more interesting. And if you see the second image, the student from the grade 4, they had converted the SBN question into the form of the game. Now, what is SBN? SBN is the standard book number, which is a unique numerical and commercial book identifier. Okay, and SBN is the 13 digit where the last digit is said to be the check digit. Now, in this game, the other students were given the algorithm. Okay, other students were given the algorithm to find the check digit within a given period of time. But our observation was that when they were performing this game, some of the students were finding it difficult to find the check digit within a given period of time. So to solve this problem, and to develop the algorithmic thinking in the students, the SBN number was introduced to them by visiting the library. If you see the given video, here in the library, we have introduced the SBN number in detail. We have given them the detailed information about the algorithm to find the check digit of the SBN number. After that, the student collected the different books from the library having the different SBN number. After that, but on the given book, the SBN on the given book, the check digit was already given. The student just verified whether the given check digit is correct or not. They perform the activity by following the given algorithm. After that, we have given some of the students the SBN number where the check digit was missing, and we allow students to follow the algorithm which was already explained to them. Now here, if we see, to find the check digit, there are some certain steps we need to calculate the A first, where A is sum of the digits in odd position, and after that we need to calculate the B, where B is sum of the digits in the even position. By using A and B, we have calculated the C, where C is equals to A plus into the bracket 3 multiplied by B. So finally, students calculated the B. After the calculations of students calculated the C. After the calculations of the C, the last digit, that is the rightmost digit, was used as a check digit by the students. We have seen some of the variations in the SBN activity. They have already gone through the algorithm of the algorithm to find the check digit of the SBN number. Now, what teacher asked students to find, that is the flow chart, to draw the flow chart. So students drawn the flow chart step by step, and they found whether the given SBN number is divisible by 11 or not. Okay, now on the basis on the variation, on the basis of the variations which was performed in the SBN activity. In that activity, student has used the city skill abstraction because they have used their previous knowledge of finding the sum of the digits in the even position and sum of the digits in the odd position, so they can relate it. They have used their previous knowledge to find whether it is divisible or not. Now here is the data of the students, where some students collected the book from the library having the different SBN number, and they find out whether the given SBN is divisible by 11 or not. Now the impact on the student is seen through the given video. If you see the video, students are really enjoying finding the SBN, finding the check digit of the given SBN number, or to verify the check digit of the SBN number. Also, along with that, while performing this activity, we can see that the students are applying the city skill, like we can see algorithmic thinking, evaluation, abstraction, and the information processing. Even the concept of even and odd number, because as they are the grade 4 students, the concept of even and odd numbers and their positions were very clear to them. Along with this, we can see that the students have enhanced the ability of solving the mental arithmetic problem very efficiently. As ma'am has explained the first activity, the impact of that activity was students created different patterns and they were really very delighted to code and decode the messages. So from this, we can conclude that coding plays a key part in this technological evaluation. This activity using patterns to make the code has helped students to develop the logical thinking and problem solving skills. Again, with the help of the SBN activity, the students has used the city skill, that is the decomposition, to find the check digit of the SBN number. After that, finally, students were really very amused to verify the given check digit and to find whether the given check digit is divisible by 11 or not. Thank you so much. Any questions?
Well, congratulations, such a nice painting is putting it in the classroom.
Thank you so much.
You're doing that.
No question.
Okay. Yeah, it's a beautiful painting because when it was flowing, I already was like, when you're doing odd numbers and even numbers, the usable test was already reading in my head, and then when you said you did connect to it, it was an absolutely beautiful thing. I hope the students knew that, after deciding the check digits, they can still use the odd numbers and even numbers before and then flow it. They just sat there.
This was the observation that we have. Yeah.
That was really beautiful. Congratulations.
Thank you so much, ma'am. Thank you.
I just wanted to add to that and say that was absolutely brilliant. Really exciting to see how the progression went, because you very, very structured with that. So I really like that. And I thought with the SBN numbers, there's lots of applicability in that. And to go back and check and let them do the flow chart was absolutely brilliant. So great job.
Thank you so much, ma'am. Thank you.
Thank you. We'll take questions after all presentations. Okay. Thank you, Vrinda and Vaishnavi. Next presenter, Jayashree Mahakarkar and Nilal Patskade. They are from School of Scholars, Belatrudi, Nagpur. The topic is impact of systematic counting and listing on learning math concepts.
Teachers and my dear friends, I am Jayashree Mahakarkar. Along with my colleague, Mrs. Nilal Patskade, we are extremely honored to stand in front of you to present a paper on the topic Impact of Systematic Counting and Listing on Learning Maths Concepts. CT, computational thinking, was implemented in primary and upper primary grade in the year 2017 as a pilot project. Since then, CT activities encompassing CT skills like systematic listing and counting, pattern recognition, decomposition, algorithm, and problem-solving skills are implemented in the math curriculum. In this paper, we are going to share maths activities related to systematic listing and counting, which is based on the CS module 03 LCR 0. So these activities are based on the CS module 03 LCR 02. The activity was conducted for standard 4 students in online mode. 115 students were participated in the activity. The objective of this activity is to make students aware about counting and listing with systematic approach. The activity was conducted in 2 parts using a set of different groups and a set of blocks of 2 different colors. So, as you can see in the slide, students tried a different combination using their choice along with their clothes. They tried to make different combination of clothes.
It's
Here
clear,
in the slide, a girl has shown a combination of 5 t-shirts with her shirt and a combination
It's my connectivity issue because I'm not on my
of jeans, amounting
No,
total
no.
combinations. This also reinforces the concept of multiplication with different daily life examples. It was a fun and creative activity for one and all. Next activity was conducted by using a set of 2 blocks of set of 4 blocks with 2 different groups. Here, students try to make a tower of 4 blocks with 2 different colors. 10% students explain the different combination, but they observe that some of the combinations are repeated and also they couldn't able to find all possible combinations. So, students in standard 1, students learn the counting of objects, like counting objects by touch and count method, counting in group method. So they applied this concept to make the different combination. But some of the combinations were repeated and they also not able to find the all combination. So here they applied the systematic approach to find all possible combination. They used a line method to make all the possible combination. They have drawn it on a square grid using crayons and made all 16 possible combinations. So once students explored the concept of counting combination, they applied this concept in solving arithmetic and different maths concepts. Now, my colleague is going to explain the impact of this activity on maths concepts.
So, learning of systematic counting and listing enables students to list the factors systematically. So, here we will see systematic approach to list all the factors. So, earlier students of standard 4 missed writing some factors as they listed the factors randomly. Here we can observe that students have found out the factors of 42 randomly by trial and error method and missed the factors like 21. So on an average, 12 students out of 115 students miss some factors, mostly because they do not remember the multiplication tables for higher number. After practicing systematic listing and counting of factors of any number starting from 1, 50% of students were able to list all the factors. They were confident as fear of missing a factor was reduced. While practicing systematic listing of factors, the question arises where to stop. So teacher kept this question unanswered and asked students to observe or solve problems and then discuss observations with students. Students shared their observation. For example, 1 and a number itself is appearing as a factor for all numbers. After some numbers, the factors start repeating. This is observed for all numbers. Hence, whenever repetition starts, we can stop, and this was based on observation of patterns and generalization. While selecting appropriate factors, they have used abstraction. Now, the second approach of systematic counting and combinations with money. So, while counting money using different denominations, students of Standard 4 were asked to discuss in a group how to make rupees 10 using rupees 1 and 2 coins. Solutions and present them in the form of table. So, here we can observe that students applied a systematic approach and list and count to get the solution. When the teacher asked them to observe the table and discuss why some combinations were not possible, 25% of students explained about the concept of sum of odd and even numbers. They concluded that the sum of even and odd numbers is always odd and the sum of two even numbers is always even. This concept was extended to make rupees 100 and using two different denominations, that is simple to complex. So students made different combinations to get the total of 100 rupees and presented it in a systematic way. They made the different combinations using 5 and 10 rupees, 10 and 20 rupees, 20 and 50 rupees, etc. Then the teacher asked them to write the sum of numbers as 100 in different ways. So they have shown it creatively. Using 10 rupee coins, and this activity helps students to do mental calculations quickly and apply addition subtraction facts in daily life applications. So here we can conclude that learning mathematical concepts like finding factors, counting money with different denominations becomes easy by applying the computational skills. Counting combinations activity reinforces the concept of multiplication with different daily life applications. After practicing systematic listing and counting of factors of any number starting from 1, students were able to list all the factors and it helps them to reduce the fear of missing factors. So CT skills are very important to play a key role to develop the mathematical concepts. Thank you very much.
Very well presented, Jayashree and Meenal. Next presentation is by Smita Ingole and Shweta Tiwari from School of Scholars, Shukeshwar, Nagpur. The topic is City Skills in Basic Mathematical Operations. Smita and Shweta.
A very good morning to respected dignitaries, respected principals, respected teachers, and all my respected friends. We are extremely honored to stand before you and to share our classroom practices. Let me introduce myself. I'm Smita Ingole. And I'm Shweta Tiwari. We are from School of Scholars, Shukeshwar, Nagpur. Our school is a developing school. Establishment year is 2010. In our school, there are 849 students. Grade standard 1st to standard 10. Number of teachers involved in CT, those are 5. And of course, CT is integrated in our curriculum. I introduced the topic of algorithm to the student of grade 4 by asking them their daily routine activities starting from morning to night. And yes, the 4th standard student, they came up with different various activities starting from brushing the teeth and taking the bath and getting ready for school, putting on shoes, and many more activities. And when I asked them, can you please tell me the step-by-step process of this activity? Yes, they were able to tell me that process also. So then I divided the student into the pair. I used think, share, pair strategy and allotted a task to them. Can you please write the steps how to make jam sandwich? You can please see here the result right from going to the shop to asking the bread packet, opening the packet, all these things they all have written. Then after discussion, after brainstorming, they came up with this algorithm. And the students, it was clear to the fourth grade student, algorithm is a step-by-step process to accomplish any task. And how pervasive algorithm are in our daily life. So it was now time for me to extend the concept of algorithm to mathematics. So I discuss a word problem with the student by using cube strategy. Cube, that is, so please next. That is CUBES, cube strategy. It is a step-by-step process of solving the word problem in systematic way. Actually, cube strategy itself is a step-by-step process of solving a word problem in systematic way. In that step-by-step process, we divide the problem into a manageable part. That is what we call it as decomposition. I took this very simple word problem in fourth grade student. You must have seen the word problem which I took, and it was expected. All the steps were discussed with them, and what was my expectation from them that I would like to tell. So please next slide. C stands for circle the key number. It was expected that they should circle the key number. U stand for underline the question. Question was how many cans of paints do they need in all? Then B stand for box the keyword. It is keyword. That first was key number. So keyword here, keyword is in all. So please next slide. Then eliminate. Here we are going to use abstraction. The information which is not relevant, we are not going to use to solve the problem. And last step, S stand for solve. We are going to reach to the solution of the problem. It was expected, if possible, they could use different models. Their visualization can be used. This was my expectation, but yes, result was not up to the mark. I'll show you the result. But it is not like that. Some students solve it very nicely, but some students that I would like to show their work. So please next slide. You can see here it was expected they should circle the key numbers. You must have seen they have circled all the numbers. And then it was expected that they should add all. That is correct. The keyword it is properly boxed in all, but in all means they have added all the numbers. They haven't used abstraction and all. Yes, so it was literally challenge to me. Then after drilling of same kind of problem by using cube strategy, yes, many students were there. I think more than 70% students. This next slide. They were able to solve word problem by using cube strategy. So 70% students applied CT skill like abstraction, algorithm, decomposition in the given word problem using cube strategy. Challenges, of course, challenges were there, and the first challenge was 20% students were not able to break the problem in manageable part. They were not able to write the algorithm. So, of course, you also know challenges cannot be overcome overnight. It cannot be overcome within a day or within a month. Still, we are in process. But yes, I start with that at least they should be able to write algorithm of simple sum. Like I took here addition problem, subtraction problem, and some students, still some are there that we are trying on them. Some students were able to write algorithm for simple problems. Next challenge, my friend Shweta ma'am will explain. Next challenge was 10% students had a very casual attitude towards study. So to develop the interest of their in maths, we have used some variations like crisscross puzzle. Here is the crisscross puzzle. As
They are the in 4th standard, so they need some help in this one. So first, I explained them how to solve. I asked them to first solve all the sums given over there, and then they have to see the first they have to see the length of the sum, and according to the length of the sum, they have to find the grid of that much boxes given there and fit the sums there. Some students have solved it by their own, but some students needed help of the teacher. So first I helped them in solving, and again I gave them some more puzzles as a practice at home. They have solved it very nicely, and here you can see one activity solved by the students with the help of teacher. This was our uh, this was our try to get the interest in those 10% students who were not interested in at all. So next one. This impact of cube strategy. With all proud, I would like to say, in the evaluation 3, 4th grade student here, so I have only shown one answer sheet, but more than 80% students were able to solve word problem using cube strategy belongs to concept of fraction. So that is one of the achievement I would say. Next, sir, please. This is the impact of algorithm. This is the mini miracle activity of liquid jar in science subject. As students have already learned about algorithm, they were able to perform the activity with the help of teacher's instruction. Next activity is of Shabda Kode of Marathi subject. It was there in their textbook. And this is the impact of course, crisscross puzzle. As they have solved crisscross puzzle, students were able to solve Shabda Kode nicely. Now, this is the conclusion. Students applied CTiS skills like abstraction, algorithm, decomposition in the given word problems using cube strategy and reached the solution with systematic approach. Activities like crisscross puzzles are interesting ways to allow a child to think creatively, logically, and develop their own ways of resolving problems. And this is known as developing computational thinking. Please last slide. I would like to end with every problem has a solution, and in impossible word itself says that I'm possible. So everything is possible with the hard work, dedication, and continuous efforts. Thank you very much.
Thank you so much. Yeah, next presenters quickly. Please stick to time. Swati Patti and Mamata Verulkar, School of Scholars, Atharya of Nagpur. And the topic is computational thinking in mathematics lab activities. To share an experience about computational thinking in math lab activity. We are from School of Scholars, Nagpur. We have been implementing CS curriculum since 2017-18 in math and computer. Total 15 plus teachers are involved in teaching computational thinking. Computational thinking allows us to deal with a complex problem, understand what the problem is, and develops possible solutions. Decomposition, abstraction, pattern recognition, and algorithms are the pillars of computational thinking.
Our Mickey group of schools believes in innovation. We have integrated CT in our maths lab, in our puzzle solving, subject enrichment activity, projects, and maths club activities too. Maths lab is the place where the students are visualizing the concept, drilling of concept, and getting the mastery on that. Maths lab, students are able to solve the problem. Hence, we can develop the problem solving skill, critical thinking, creative thinking. These are the some activities. These are some activities of Maths Club or Maths Lab. These are some glimpses of that we can see. One of the most famous mathematical puzzle, Tower of Hanoi, was conducted for Standard 7 as a mathematics lab activity. The Tower of Hanoi has 3 poles. So these are the versions of that. And this is big one and this is the smaller one. So it has 3 poles: source pole, auxiliary pole, and destination. And discs of different sizes are arranged in source pole in order. The objective of this puzzle is to move all the discs from the source pole to the destination pole in minimum number of moves. And the rules are: only one disc can move at a time, only the uppermost disc can be moved, and no larger disc should be placed on smaller disc. Here, the actual task is to move all 6 discs from source pole to destination. It was quite challenging, so teacher applied simple to complex approach, and she break down this puzzle in smaller manageable tasks. That is nothing but decomposition. The task of 2 discs was given to the student, and they have to move the two discs from source to the destination. Student applied the trial and error method. Next, please. Student applied the trial and error method. They successfully completed the task moving 2 discs from source to the destination. These are some number of moves we have shown for the group number 1, 1, 2, 3, 4. And we can see that group number 1 and group number 3, they have shifted all the discs from source to the destination in 5 moves. Group number 2 and group number 4, they are able to complete the task in 3 moves. When the student discussed their result, there was a confusion, and they asked, "Ma'am, if we are having the same number of discs, why we were receiving the different number of moves?" Teacher asked the student to demonstrate and share the observations with all. Student observation for 2 discs were group number 1 and group number 3, those who have completed the task in 5 moves to move the disc from source to destination. They have shown they have demonstrated their activity. Group number 2 and group number 4, they have shifted the moves or shifted all the discs from source to the destination in 3 moves, and we can observe they have given their observations that both the groups completed the task in odd number of moves. And even we can see that from group number 1 to group number 1 and 5, they have shifted their disc from source to the auxiliary, and group number 3 and 2 and 4, they have shifted from source to the auxiliary, and group number 1 and 3, they have shifted from source to the destination directly. And that's why the result whatsoever they are having the number of moves were different. Teachers discuss with them and make them understand every problem has multiple ways of solving solution. But here in this puzzle, the best solution is one in which we are moving this in the minimum number of moves. Means we are having the condition to move all the discs in the minimum moves. So here we face the challenge. Here we face the challenge by the student was to complete the task in the minimum number of moves. Second task of moving 3 discs from source to destination was allotted to students. Students enthusiastically completed the task. Group number 1 with 9 moves, group number 2 and 4, 11 moves, and group number 3 completed the task with 7 moves. This triggered the mind of students, and they spontaneously answered that solution given by group number 3 is best solution, as already they were knowing the condition of minimum number of moves. Then, for more clarity, task of 4 discs were allotted to students where group number 1, 2 and 3,
completed the task in 15 moves and group number 4 completed in 17 moves. Here, teacher observed that here students were more confident in 4 discs as compared to 2 and 3 discs. Systematic listing counting approach helps students to complete the task efficiently. But still, the question from student side was how to decide every time minimum number of moves. So, teacher instructed to discuss best solution among themselves and come with your observations. So, next. These are the students' observations. Minimum number of moves are always odd. If the number of discs are even, first move is to auxiliary, and if the number of moves are odd, number of discs are odd, then first move is to destination. To get the minimum number of moves, one needs to follow a certain pattern and to repeat a certain set of steps. This task with 4 discs seems to be difficult for students, but CT skills like decomposition, then strategies of minimum moves, pattern recognition, algorithm, and systematic approach make the students confident to complete the task. And these CT skills triggered their mind to generalize the pattern and to find minimum number of moves. So this is the generalization done by students where you can observe that number of discs are 2, where 2 is the even number and minimum number of moves are 3. So 3 can be written as 2 into 2 minus 1, which is nothing but 2 raised to the power 2 minus 1, where power 2 or exponent 2 denotes the number of discs. Similarly, for 3, it is 2 raised to the power 3 minus 1, where again the exponent 3 denotes number of discs. So they generalize by using pattern recognition. They generalize it as for n discs, for minimum number of moves, the pattern is 2 raised to the power n minus 1, where n denotes number of discs. Here while conducting the puzzle, we face some challenges to move the disk from the source to the destination in the minimum number of moves, to complete the task with the higher number of disks. Even to generalize the pattern, it was difficult to express in the exponential form, as it is the iterative process. The impact of this, next please, the impact of this activity is enhances the CT skill among the students, that is decomposition, abstraction, pattern recognition, and algorithm. Students share their activity with their friends as well as with their parents. And when the carnival was organized in the school, they exhibited this activity in the carnival. Parent as well as the student, they enjoyed this activity a lot. As we are using the CT approach in our regular maths curriculum, we can observe that CT skill one can develop problem solving skill or persistent in working. Even it enhance the ability to deal with open-ended problem, ability to communicate, and we work with others, which leads to the success. Thank you so much. And even as we have arranged the carnival in our school, we can see the video where the student as well as parent enjoyed a lot. Thank you.
Thank you, Swati. The next we have online presenter, Prachiti Dharmadikari, Satish Guravar, Prakash Kumar. They are from School of Scholars, Amravati. The topic is systematic approach to solving linear equations in 2 variables. Prachiti, can you hear me, Prachiti? Please on your camera.
Yes, madam. Yes, thank you, ma'am.
Yeah,
Good
and
morning
we have
to
one of the presenter present here.
Hello everyone, this is Prachiti Dharmadhikari from School of Scholars Amravati. With me Satish Dhuravar sir and Prakash Umag sir, we are going to present a presentation. Hello everyone, this is Prachiti Dharmadhikari. Hello everyone, this is Prachiti Dharmadhikari from School of Scholars Amravati. With me Satish Dhuravar sir and Prakash Umag sir, we are going to present a presentation on systematic approach to solving pair of linear equations in two variables. So our school was established in 2003 and we are facilitating around 3094 students, and out of 86, 21 teachers involving math and computers are involved in computational thinking and CSpathshala curriculum implementation. So in grade 10, we observed that the students were finding it difficult to understand the concept of consistency of pair of linear equations in two variables. So they were able to understand the unique solutions, but no solution and infinitely many solutions was a difficult concept for them. So instead of approaching the traditional method of sharing the conditions and followed by problem solving, we switched to the another method, step-by-step approach. In that, we adopted three methods. First was visualization, second was observation and framing equations. So I would like to request Satish sir to explain visualizing pair of linear equations by using GeoGebra, the first step. Yes, Satish sir.
Thank you, madam. In visualization, students of standard 10th are aware of the GeoGebra. They can use GeoGebra and explore the graph of the linear equation. With this as a prerequisite, GeoGebra used to visualize the linear equation of two variables. We divide a class into three groups and ask them to plot a graph of equations provided to them and write observations. These equations provided to group A, group B and group C, and student observed. Group A observed that the lines are intersecting. Group B observed that lines are not intersecting and parallel. Group C observed that lines are overlapping. Now I request Prakash sir to explain step 2.
Thank you, Satish sir. Now, after visualization of the graph, we ask student to observe the coefficient of variable and find the relationship by using this table. We provided equation to the group A, group B and group C. Student write the coefficient of x, coefficient of y, constant and ratio of the coefficients, and then they write the observation here. The coefficient, here the coefficient of x are same, rest all are different, no pattern is followed. In this way, we provided the equation to the group B. They also write their observation, and similarly, same way we provided the equation to the group C also. Okay, after that, they observe that this is the equation of the group C, and they write the coefficient of x, coefficient of y and constant. After that, each group presented their observation to the other group and were able to state the rules observed by themselves. First group A observed that the ratio of A1 by A2 is not equal to B1 by B2 for intersecting lines. That means their conclusion was lines are consistent with unique solution. Group B observed that for the parallel lines, A1 by A2 is equal to B1 by B2 is not equal to C1 by C2, and the conclusion is not consistent. For group C observed that For coincident line, the ratio of the coefficient is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Line are consistent with infinitely many solutions. Here, the students observe the pattern of the ratio of coefficient in each case, and teacher works as a facilitator. Here, the learning outcome by using the pattern recognition and systematic reasoning. Out of 40 students, 33 students were able to draw the following conclusion by pattern recognition. Now I am requesting Prachiti Madam to continue the further steps.
Yes, thank you, Prakash sir. Kindly mute yourself. Yes. So the third step was framing linear equations, and here we took care that students should use abstraction. Now, how we adopted this? So we provided one equation to the student, x plus y is equal to 6. So every group was supposed to frame the equation, another pair. So for group A, the equation was given and we asked them to write another linear equation in two variables such that the pair so formed is intersecting. Now, as the students have already observed the pattern A1 by A2 is equal to B1 by B2 in intersecting lines, so they tried to frame the equations by eliminating one specific value for B2. Like if A1 by A2 is equal to 1 by 1, then for B1 by B2, if B1 is 1, here B1 is 1, so B2 cannot be 1 because we don't want the ratios to be equal. So likewise, students frame different equation, x plus 2y is equal to 6, x plus 3y is equal to 6, x minus y is equal to 1, and etc. So similarly, for different ratios, students use the same elimination for B2 value. And here, they adopted the method of abstraction. Again, for group B, we had provided them we asked them to frame the equation, which will make the pair as parallel lines. So here again, students already have observed the pattern for parallel lines that they want it to be A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. So students fix some ratio like for A1 by A2, B1 by B2, if they want it as 1 by 2, then for C1 by C2. So if C1 is 1, C2 cannot be 2 because they want not equal, isn't it? So this was again the abstraction. So they eliminated 2 and all the remaining values they can keep for C2. So this is how they frame the equations for parallel lines. Again, they observed that we can frame infinitely many such equations. Third group, they have to frame the equation for coincident lines. So again, the equation was provided to them. Now here, the students fixed different ratios, various ratios, and accordingly, they were able to frame the possible equations. If the ratio is 1 by 3, okay, then all ratios they need as 1 by 3, and then they can frame the equation. So again, students were able to create infinitely many equations by fixing variable ratios. So this was the systematic approach, step-by-step problem solving by integrating pattern recognition and abstraction of computational thinking skills in our 10th standard grade students. So these are some challenges. Few of the students were not able to plot graph on GeoGebra. So we allowed them to plot the graph on the graph paper. Then one more challenge was framing systematic task sheet was a challenging task for teachers for creating linear equations. And the impact was really wonderful. Students were able to visualize and plot the graph. Their confidence level was increased and they were able to create questions as well. So here we stop our presentation. I would like to thank all the CSpathshala team for giving this wonderful opportunity to us for presenting our topic. Thank you everyone. And now we are open to questions. Thank you once again.
Thank you.
The next session is thematic area is CT for students with special needs. Here we have two presentations. The first group is Amrita DK and Afrin Usmani from City Pride Degree. The topic is an innovative approach to teach computational thinking to specially able children. The next presentation is by Devdatta Ghosh and Jyoti Bish. Are they present here? Yeah, please.
So very good morning to all of you. Good morning. Louder. Good morning. Yes, that's a nice good morning. Okay. So a very good morning to the directors, principals, teachers, and all the dignitaries present over here. When we hear the words specially able child, we end up thinking about restrictions. We start getting a feeling of sympathy and we start showing pity. But why? Whereas in reality, these are extraordinary people. They are very brave and carry a never say die attitude in their heart. We have heard of big names like Albert Einstein, Stephen Hawking, and the world mocked them at one time because of the dyslexia or the rare motor disease. But that did not stop them from achieving their goals. I am Mrs. Amrita DK.
I am Mrs. Afrin Usmani. We are from City Pride STEM, and today we are going to present a paper on computational thinking for special able children. Okay, so our school is associated with an organization called ZIP, where we work collectively for specially able children on inclusive education with the aim of creating something impactful and sustainable. So these children visit our school twice a week, and we decided to give them a hands-on activity to check the space of learning and their learning style. So can anyone tell me when we teach algorithm normally in class? So what examples we give and how we start teaching algorithm in the class? Any example from teachers? Correct, that's right. Getting ready for the school and making a cup of tea and making a sandwich. Okay, and then slowly we come to the writing algorithm to solve a problem or a computer problem. But this kind of problems or this kind of tasks are also very difficult for the students. So what we have decided to give, to start algorithm with a craft activity. So we started, making a dog face. So we asked we explain the students the steps to create or to make a dog face with the craft paper. So we have explained each and everything, all the steps, like right from holding a paper, folding a paper, folding the corners, and making or drawing the eyes and face, etc. And these steps we repeated many times. And after that also we found like few students were not able to do that. But repeating again and again, finally they were able to do it. So this is what we taught algorithm for this children.
After the algorithm, after the step-by-step execution of things, we decided to move a step forward. And we decided to teach them the if construct, the decision making.
So, can anybody tell me how will you start teaching decision making in your class?
We give a simple problem to the students and we ask them to solve it. Yes, anybody else? We start with a simple yes/no question. Is a particular child present in the class? The answer to this question can either be only yes or no. Or is a number even or odd? Is a number positive or negative? And we take up all such examples. However, with these children, we cannot actually make use of alphabets and numbers. That is why we had to come up with a different thing as to how to teach them making decisions. And we came up with using maze to solve the problem. So I'm just showing you a simple maze. Usually, when you give it in the class, any child would solve it immediately. It's hardly a matter of 2 minutes. But with these children, for every turn that was there, we had to ask them, can you go left? Can you go right? Can you go down? And so on. Till the time they reach their destination or till the time the dog got its goal.
So just like Afrin Miss said, we have to continuously repeat the instructions that are given to them, and the instructions have to be very, very precise. The end goal of maze is to increase the focus and to teach children how to make decisions.
As we all know that sorting develops reasoning and thinking skills in children. For teaching this technique, we made 5 different groups of the students, and we gave them a bag of blocks of all the colors. Then the next task was, what we asked them to do was search a block of one particular color. So they searched blocks of one particular color, and then we asked them to arrange. So initially, the children were arranging the blocks like anyhow, and naturally it was falling down. Then we taught them, again repeatedly we told and explained them like which is the smallest one, which is the bigger one, and they arranged the block properly, and finally this is how we taught them sorting. And later on, we also told them, now arrange the block like the smallest one first, then arrange the bigger one. And this is how, finally they learn searching and sorting from this activity.
There are a few glimpses. The execution of these activities isn't as simple as it looks like or feels like. Every instruction has to be repeated in a very simplified and in a precise manner. For example, when we first made the dog face, we had to start from the basic about what are animals, what are domestic animals, and then slowly we took the class to making a dog face. Or even when we made ear of the dog, we could have easily said just repeat the process, whatever we have done on left hand side, repeat it on the right hand side. But then that does not happen. So again, the instruction have to be given to fold, to create or make that ear that is there. These children need more repetition, and we also realize that if we give multiple instructions at a time, then these children tend to lose their focus, and it is very difficult for them to comprehend these instructions. Numbers, alphabets cannot be used for teaching because identification of ABC or 1, 2, 3 itself is a big task for these children. So we have to use things like blocks of different sizes or colors for teaching searching and sorting, or mazes, and so on. Special child, after we taught algorithms, one of the special child came and said, I just say in Marathi, so he was like, my shirt fold karala shikhona, so but steps nahi, that is also algorithm. So that was what really touched us, that okay, we have understood the concept of executing things step by step. And our school children have also developed an app called as Yugma. I'll call Afrin Miss to give the details about it.
So Yugma is a Sanskrit word which means to collaborate. So our students, along with the computer teachers, have made this app. These children are, very attracted to the technology. But some people think, it is a weakness. But thought of making constructive use of this, our students come up with the app. So before making this app, our children interviewed and consulted various doctors, counselors, and parents also. In this process, we discovered that there is no such digital, aid for these children, which can specially help children to connect with the vernacular language. It contains special games and programs which are interesting and will keep children engaged as well as educate them. So here you can see the few screenshots of the programs where we have a program, guess the picture. Like the different pictures are there, and the students are supposed to guess which kind of picture is there. Also, the sound is there. Again, like there is some program which will help them to do the exercise. Like this app, help these children during the pandemic also to do their work. Then again, children can play the music here. The piano is there. The children just keep the fingers on the buttons, and the sound comes. So they enjoy it and try making a new sounds from them. And again, match the following. So lots of different programs and games are there. So this app is made by our students. So there are some limitations, but still they are working on it to improve.
would like to conclude that instead of looking at these children sympathetically, there's a strong need of developing curriculum of computational thinking for these children, which will be helpful for them in everyday life. Thank you.
So the next presenter, Devdatta Ghosh and Jyoti Bisht from Vision Empire.
Good morning, everyone. My name is Devi Datta Ghosh, and my name is Jyoti. First of all, we would like to say thank you for giving us an opportunity to share our experience. And, the topic for our abstract is executing online computational thinking for children with visual impairment. So, we'll give a short background of our organization, Vision Empower. So basically, we are based out of Bangalore, and our focus is providing accessible STEM education to children with visual impairment in different schools. So Project WIT, which is computational thinking for the visually impaired, it's a project under which we play CT sessions with children with visual impairment. And under this project, we do. Yeah, is it? Am I audible? So under this. So under this project we conduct sessions and we play games to teach computational thinking to children. And this project is we are doing with collaboration with Microsoft Research. We are the research partners, we are the implementation partner, and together we design and create games which we play with children with visual impairment. Now in 2019, before the pandemic started, we were visiting different schools in Bangalore, and we were conducting sessions weekly, one sessions in a week, and we were playing games. Now, since our topic is what we did during the pandemic, so now when in 2020 pandemic started, we were also wondering how to continue with this project, how to continue playing games with children. So we came up with certain ideas, and then we started our first pilot, which is with the 6th and 7th graders. And what we did is we had few games which games which we had designed. So these games were basically for the level 1 to 3, which were more suitable for children of grade 1 to 4. But still, since these children, grade 6 and 7 children, were already receiving some science and math support sessions from us over the phone, so we thought, why not try some of these games with them? So we modified these games, we made these games in, we thought of coming up with the game, we changed the design of the game in such a way that we can play with them over phone call. So we called each of the students with whom we were in touch with, and then we brought them together in a conference call. And one of the good things is that the students were really elated and very happy to come together, and they were able to meet their friends over the conference call and play games. So when we told them it's not a teaching session, it is not science and maths and all, we are going to play games, they were really having fun, and they were very much interested to go ahead. Initially, they suggested what games to play to make them feel comfortable, and then we continued with our CT games. So from the learning, so we of course we came with a lot of challenges when we started conducting games in conference call. So from all the learnings, which from this pilot 1, we moved to pilot 2. So we improvised our challenges in pilot 1, and then we moved to pilot 2, and then we made small changes. So we will talk more in details in the next slide. So in pilot 2, we played with a group of children who are from the age of 5 to 10. And there were 2 groups, and we played 1 session in a week. So coming from
talking about the challenges of pilot one, the first one is lack of resources. So because the schools were closed and all the resources were there in the school, there was nothing there with the children, whether it is for reading, writing, or even for play. So everything was there in the school. The second is when we started the games with the children, it became more of math and memory because it was a phone call. And if we just play something with the numbers, then they were focusing more on the numbers. I have to remember these many numbers. It was the element of game was less when we were doing the pilot one. Then blind spot for the facilitators because it was a conference call, and if we ask something to the children that okay, what are you holding, we were not sure that the child what he is answering whether it is correct or not. If you're doing some patterns, then whatever pattern the child is telling whether it is correct or not. And then the last is like poor network connection because the children were at remote location and it was very difficult. So sometimes they'll get dropped from the call. We have to again call them and merge them to a conference call. So from pilot one, we made those variations. Like if there's a lack of resources, we tried that we use the resources which are easily and locally available at their places. That we use some gram or chana, these kind of things to play games with the children. And we also played some card games with the children. So here what we did is, instead of giving each pack to the children, the facilitator was having a pack of cards with them. And they used to pick a card and then we used to tell the children that this is your number. And to reduce the memory and to include the more element of game into those games, what we did is we simplified the games first. That if it is, we used to play a game which is IC10, so we simplified it to IC5, so there'll be less numbers involved in the game itself. And then to know what the children are doing or how they are doing, we ask the caretaker or whoever is there at the home to be present when we are conducting the session. So this all lead to pilot 2. And then, but again, in pilot 2 also we faced a few challenges here. Because the pilot 2 group was different, so it was from grade 1 to grade 5. There was some variation in age and also variations in the cognitive levels as well. And because there was different variations with the age group, so even the children were feeling a little bored. For example, if there's a child who's in grade 1 and there's a child who's in grade 4, so if you play a game, then the child of grade 4 would have already understood the game and that child will feel bored. So then, and to grade 1, we have to explain the game again and again. Doing this only we realized that there was a limited time, so 45 minutes is not good enough for us to explain the game and to play the game with the children. So again, we did some modifications here, some deviations. We started with one-on-one sessions, so where we feel that okay, the children are taking a little more time to understand. We started with one-on-one session with the children, and we again simplified the games. Like the example which I was giving, IC10, and then we made it to IC5. And again, the variations in the game, I think.
So we continued playing games with them, and over the time, the game started developing and evolving. And from all the learnings and from our experiences, we started building more games. So here we will give you an example of one game, say IC10. So IC10 is a game, the main object we play using a playing card which has numbers. It's like the cards, Tash ke patte jo hote hain, similar to that, but these are specially made in tactile form where there is a braille number and there is a braille letter which tells what sign it is. Apart from that, children who have not yet learned to read braille, for them we have small dots on the cards. They can count these dots and they can identify the number on the card. So now, just giving a few examples, like when we started playing IC10, so we noticed now over the 2 years during 2020 and 2021, what we noticed is children have learned a lot, and over the time, they themselves are willing to increase the complexity of the game. IC10 is a game where the objective is to make 10 by using any kind of mathematical functions. So when we start, it can be just an addition, and as and when the session progresses over the days, it can be like we add more mathematical functions like minus, multiplication, square root, different ways of making 10. The objective is make 10, and whoever makes 10 first, it says IC10. So children started enjoying this game a lot, and over the years, over the time,
they started like playing, they started suggesting that can we play IC50 or can we do some multiplication, can we do addition, multiplication, different ways to play the same game. Of course, when we talk of overcoming the challenges, we use certain other models, like certain other resources to help them for those children like who are very young and who are not yet being able to add two numbers to one single digit numbers to make them. So we use chickpeas and ice cream sticks, and we teach them the bundle method where they use different combinations of two numbers in two bowls and then put them together and then count what is the total. So all these things help them understand like different combinations of say, 10, two pairs and all. So we simplified. So that is what we did. And also we started with IC5 rather than just directly jumping into IC10. We start with IC5 and then slowly moving on to IC10. And of course, the fun element is there because what we realize is children keep on like whenever we ask, we give them a chance opportunity to what game do you want to play? They would say like many the thing that fact that they say that we want to play this particular game tells us that they love this game.
Now talking about the impact, so one of the examples which we gave about IC10. So when we were playing the game with the children, so there's one child who was playing with us from a very long time. So we started with IC5, then IC10, and the children itself they said, okay, we would like to play IC50 now. So they were into that level of making the variations and to increase the difficulty level in the game itself. Second, coming to pedagogical processes. So we came up with the pedagogical processes like we wrote the play plan of how these games are supposed to be played and how to make these games accessible and to play online with the children. Third is we also designed capacity building teacher training modules for the teachers where we were not just directly training the teachers, but we were actually playing the games with the teachers so that they also realize the value of play and playfulness within the game. So so that's how we started. And then currently we are conducting the sessions in 3 different ways. So one of the picture here is offline session where our coordinator will be conducting the games with the children in the school. The second is hybrid session where we will be present online with the teacher and we will do a preparatory session with the teacher before the session itself. But the teacher will be playing the session in the school with the children. The third is online session, which we are still continuing. So we have initially we covered level 1 to level 3, and now we are working on level 4 and level 5 of CSpathshala curriculum.
I would also like to add that all these games are not only specific to children with visual impairment. These games can be played with any children and from any school, in an inclusive school, in a regular silent school. Thank you so much.
Thank you. Thank you. We are running short of time. Quickly, can we have all presenters here for certificates? All of them. Mansi, starting from first. Please, all of you come on the dais. Mansi, Brinda, Vaishnavi, Jayashri, Vinal, Smita, Shweta, Upam sir, Swati, Mamta, Amrita, Devdatta Jyoti, everybody. Can I request Malvi ma'am, please, to give the certificates to all participants? And big round of applause for a wonderful presentation. Brinda, Vaishnavi, Jayashri, Veena, Smita, Shweta, Rachiti, Satish, and Prakash. And I hand over all three. Swati, Mamata, Amrita, Afri, Devidas, an area which I love. Yeah, Jyoti. I have a little observation regarding all this work which was exhibited today. Because we are in India, we would like CT to be part of our the way we deliver education. And what we saw amongst all of you is that irrespective of whether it is a language lesson or a mathematics lesson, language plays a very important role. So, vocabulary, the concept of words has to be very clear if we want our children to be masters in mastering concepts. That is one. And the second was experiential way, which I saw all of you explain. This is from rote learning, we are moving into the experiential education, and NEP 2020 is talking about this experiential education. That is learning by doing. And when a child is involved in the learning, it is fun. And when it is fun, the child engages into the learning which you want for the children. So this is learning by doing experiential, which I saw each one of you present. And the third thing, because I saw that differentiation is what I've been talking to our schools, is easily doable in classrooms of say 40, 50, 60, 80. It is differentiation is the key to handling children with less ability and children with high ability. Because India is so thickly populated. So imagine what we can do as teachers for the children with less ability. Today we have had many teachers who spoke about it. Also, I would recommend to you and suggest identify these children. You said there were some children out of 40, 30 were able to achieve. Out of the 30, you observe who were these children. Maybe 2, 4, 5 kids who have achieved it even before the rest of the class. They are the children with high ability. And I must share with you that the Kaveri group has started the Kaveri Gifted Education Research Center for this, because we need to identify our children with gifts, with potential, because otherwise, right from kindergarten, if we do not recognize and observe these children, by the time they reach 10th standard, because of our evaluation system, there will be no creativity. All creativity will be lost. So dear educators, what you are doing is extremely good. A round of applause for all of us. Thank you. Break here for tea. Break of 15 minutes for tea. And the next is exhibition. Here. So we need to gather here for one online presentation and then followed by other exhibits outside. Thank you so much.
Everyone, I'm Ramanujan, and it's my pleasure to welcome you all to this session on the TACT Grand Challenge. The TACT stands for Tactile Computational Thinking. The genesis of this is we had this presentation just before we broke for tea by David Ghosh and two persons from Vision and Power. And last year in the CTiS conference, we had inclusion as one of the important themes, and we had a workshop where it was jointly conducted by Dr. Manohar Swaminathan and Supriya Dey of Vision Empowered. I think they're online. There is Manohar and Supriya. I don't know if you can see on the screen. Can we have them on the screen, please? And so then we wanted to have active collaboration with CSpathshala. We were talking about what is the next step forward. And one of the things is that if we are talking about children with visual challenges, visual impairment, what kind of activities of CSpathshala? But then certainly tactile methods are very important. And but when you start thinking about it, what has it got to do with vision empowerment? I mean, or visually challenged children. Tactile methods are relevant for everyone, right? I mean, we learn by touch. This is something so fundamental. And tactile methods are hardly ever used in our educational processes. And so we can talk about tactile mathematics, tactile science learning, tactile computational thinking. And that's it. And so if we start thinking like that, what are the major challenges? Now, we all, children love to work with their hands. They love to weave. They love to pin things together. They love to. So once they start working with their hands and by touch, the world opens to you in many ways. So we wanted to take for computational thinking, what are the opportunities available through tactile methods, especially for children in primary schools, in elementary schools. So this is the grand challenge that was put forward. And a number of people responded. I think more people wanted to respond. And given the time, we had 30 submissions, all very interesting ones. And some used typically, what you would do in a cited fashion, where we use visual things, but translated into tactile. That some people actually use the tactile medium as a learning medium. So there is a lot of very exciting ideas, and as we go along, so you will see some of them that were selected for presentation at the conference here. And so we have two persons presenting it online, Marika and Shabana. I don't know if they are ready right now, but there are also exhibitions outside. And we invite you to the exhibition, talk to the presenters, look at the games, and touch, right? So some years ago, the Geta Institute and the Institute of Mathematical Sciences that I'm part of, we organized an exhibition in Chennai, which we called Mathematics You Can Touch. And that was all about mathematics, but learning entirely through touch. Now, this is an opportunity to do computational thinking, but through touch. And I think there are exciting opportunities if we look at these. There are many, I mean, I'm hoping that one of the CTiS conferences will be doing, computational thinking through smell. Why not? Right? I mean, there is a garden that in Chennai that I would invite you of the MS Swaminathan Research Foundation, where children with various kinds of impairment difficulties can walk through and simply through smell identify various plants. And I think you can learn quite an amount of botany through that. So I'm hoping that we'll be looking at various things. So this CTiS conference, I think, is taking a very important step forward. And I think the role of Manohar Swaminathan and Soumya Dey and the team at Vision Empower is very important, and a big applause to them for leading this idea and proposing this, taking this forward. And so I invite you all to this. I think they're not going to.
Okay. Yeah. A very good morning to all of you.
And I know you were all very eager to look at the games outside, but we have 2 online presentations because they were not able to come. Have a look at their videos. And what we plan to do is while you're watching and playing the games outside, for the benefit of the online participants, we will be recording and playing at 4 o'clock. And there is a link which will be shared for voting. We request all of you to vote after you play the game because the top 5 most popular ones get to win an award. Yeah. So my honest request: play all the games, experience it. All our submissions, they put in a lot of effort, and we will finish this and break for lunch and come back at 2. Okay. So just give us a minute. Okay. Manohar, will you unmute?
Yeah. Can you hear me?
Okay. Okay, no, play it. We'll ask. Okay.
Hello everyone. I'm Shabana K. I'm a PhD research scholar at IIT Palaparthi.
Anybody want to add anything before we start the session?
Hello everyone. I'm Shabana K. I'm a PhD research scholar at IIT Palaparthi. Let me introduce the game beat counting. The key learning objective of this game is to introduce the idea of loops and conditional constructs in an algorithm. The important artifact used for this game is a necklace with beads of different colors or shapes. The maximum number of unique colors or shapes should be kept as either 2 or 3. And there needs to be a special bead to mark the start of the necklace so that the counting becomes easier. So I'll first show you how the beads for this necklace can be easily made with sheets of newspapers and then give you a demo of the game. We'll now have a demonstration of this activity. So for this activity, we have a necklace with beads of 3 different colors. So here we have beads of colors blue, red and yellow. So instead of varying the colors, we can have beads of different shapes also. So it's better to keep the number of unique colors or shapes as either 2 or 3. Okay, so in the first level, the task given to the player is to find out the count of number of beads of each color. Okay, so in this case, the participant or the player has to find out how many red beads are there, yellow beads are there and blue beads are there. Okay, so let's say that the player first tries to find the number of yellow beads. Okay, so one of the common techniques that is used is like you go through one pass of the necklace and count the number of yellow beads, right? So let's start. So here we have a special bead of white color. So this is used to just take care of the counting so that you know where you have started the count and where you're going to end. Okay, so here let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So we have 10 yellow beads. Now ask the participant to explain the procedure. How did he do the counting in a sequential manner? So the procedure can be explained in a way like this, right? So you take the first bead, check if it is yellow in color. Is this yellow? No. So then what do you do? Just go to the next bead, right? Now this is a yellow bead, right? So then what do? You will increment the count mentally by 1. So now we have seen 1 yellow bead. Now you go to the next bead. So is this yellow? No. Skip to the next bead. This is again not yellow. This is also not yellow. And again we have a yellow bead here. So the moment we encounter the yellow bead, we will increment the mental count by 1. So now the count of yellow beads become 2. Right. So similarly we pass through each bead in this necklace until we reach back to the start bead. Right. So once we make one pass, we get the number of yellow beads. So similarly we do another pass for red bead and also for the blue beads. So if you see here, we have used two concepts, two computational thinking concepts here. One is that of a loop and the other is a conditional processing, right? So how is conditional processing being done here? So when you take one bead, you check if it is yellow or not, right? So if it is yellow, you increment your mental count, otherwise you go to the next bead. So there is a conditional processing depending on whether the color of the bead is yellow or not. Okay. So that was the conditional part. Now what is a loop? So to count the number of yellow beads, you make one pass through all the beads in the necklace, right? So starting from here all the way till this bead. So then we have done a loop. Okay. Now, so we have 3 different colors here, right? So how many different or how many passes of the necklace did we make to get the count of all the 3 colors of beads? So we did one pass for yellow, one pass for red and another pass for blue. So now can you relate the number of passes done to the number of colors? So the number of passes through the necklace is equal to the number of colors, the number of different colors of beads that are present in the necklace, right? So now we have somehow brought the computational part here, right? So the number of passes is in a way related to the computation. So the number of passes is equal to the number of different colors. So now if we have 5 different colors of beads in the necklace, we will have to make 5 different passes using this strategy. Okay, so that was one introduction to the computational part. Now the second level requires you to make a necklace. Now the necklace has to be made in such a way that the count of all the different color beads has to be obtained in one pass. So in this necklace we saw that to get the count of 3 colors, 3 passes are necessary, right? Now the question is, can you make a necklace in such a way that using one pass through the necklace we get the count of all the 3 colors of beads? Is it possible? Yes, right? So if you take all the beads of the same color, okay, and put them together, right? So here I am putting all the yellow beads together, okay, and after that I am putting the blue beads, and finally I can put all the red beads together, right? So then it's very easy to get the counts, right? So I can start from here, let's say, then I can count the yellow beads. Then I know that the moment I reach here, I know that okay, now no more yellow beads are going to be there. So the moment I reach here, I get the count of yellow beads. Then I can count the number of blue beads and then the red beads, right? So then we have now found a way to make a necklace in such a way that the counts can be obtained in one pass. That means we have reduced the number of computations here. Okay, so in this way we can show that, you know, by adjusting the input, so the input in this case is the necklace or the way in which the beads are organized in the necklace. So by manipulating the input we can come up with ways to reduce the number of computations. Okay, so this was the game where you know, some of the concepts such as computational processing, loops, and a very simple introduction to computational complexity has been introduced to the students.
There are 2 levels in this game. Level 1 requires the participant to find the number of beads of each color in the necklace. Now, apart from finding the total count of beads of each color, the participant has to also explain the procedure that was used to come up with these counts. Then the participant has to find out how many passes were made through the necklace and should be able to relate the number of passes with the number of unique colors of beads present in the necklace. Now, level 2 requires the participant to arrange these beads so that the count of all colors can be obtained in one pass. Now, coming to the learning areas covered, the participant is introduced to conditional processing, where a bead is either counted or not in each pass depending on its color or shape. The concept of loops is introduced in 2 stages. One, while making a pass through all the beads to get the count of a single color. And secondly, multiple passes through the beads in the necklace have to be made to find the count of all the colors. Now, a gentle introduction to computational complexity is made, where the participant has to understand the relationship between the number of loops or the number of passes made through the necklace and the number of unique bead colors or shapes. And then finally, by restructuring the necklace to get the counts in one go, the participant learns how the input can be optimized in order to reduce the processing time. Now, this game is based on counting beads, and hence it relies on the sense of touch to move the beads while counting. And for the visually challenged, these beads can be distinguished based on shape rather than the color of beads. The only prerequisite knowledge required for this game is the knowledge of counting. So that's all. I hope that you find this game useful and interesting. Thank you. Hello everyone, I'm Shabana KM, a PhD research scholar at IIT Palakkad, and I'm here to present the game Smallest Pebble. The key learning objective of this game is to introduce a method to find the smallest or largest item from a given set. And the list of artifacts used for this game are basically a set of oval-shaped pebbles which are of the same structure but of different sizes. We can use 6 or 8 of them. And we also require an equal number of containers to cover each of these pebbles. So there are basically 3 levels in this game. The first level is all about finding the smallest pebble through sequential examination. Whereas level 2 is actually a variation of level 1, where instead of finding the smallest pebble, the player has to find the largest pebble using a similar strategy as in level 1. And level 3 is all about repeatedly using the strategy that was found for level 1 in order to sort the given set of pebbles. Let's now have a demonstration of this game. Okay, so for this game we need a set of pebbles. Note that we have 6 pebbles here, and a specialty of these pebbles is that you can sort them based on their sizes. That is, any 2 pebbles you take, you can compare and say that one is smaller or bigger than the other. Okay, and we also have an equal number of containers. Okay, so we are going to cover these pebbles with these containers, and note that these containers are opaque, meaning that once you keep a pebble under this container, you cannot see its contents. Okay, now what we are going to do is we are going to basically spread out these pebbles and keep a container over each of them. Okay, now let's do some shuffling. Okay, and let's just arrange these containers in a row. Fair enough. So we have set up the game. Now our objective here is to find the smallest pebble from this lot. But then there are a few rules. So the first rule is that you can check the content of a container only once. That is, if you open this container and see the pebble inside this container, then you cannot again check this container again. Okay, and also you cannot
simultaneously check the contents of more than one container at a time. That is, you cannot, at the same time, you cannot check the contents of two containers at a time, two or more containers at a time. Okay, but what you are allowed to do is you can hold one pebble in your hand. Okay, so any pebble from this lot you can keep it in your hand and play this game. So what is one strategy that we can do to find the smallest pebble? Okay, let me take the pebble under the first container and keep it in my hand. Okay, now let me check the content of the second container and let me do a comparison. So I see that the pebble in my hand is bigger. Okay, so what I do is I do a swap or an exchange. So I keep the pebble in my hand here and put the container, second container over it. Similarly, I check the content of the third container and see that okay, the pebble in my hand is smaller, so I do not do any exchange. Now checking the fourth container, again this pebble is smaller. Now okay, now we have a smaller pebble here, so let me keep it here. And finally, last container, okay, this is the smaller. So yes, we have the smaller pebble here, right? So this is one strategy that can be used to find a smaller pebble. So another way in which you can play the same game is like you can get the player blindfolded and keep these pebbles in a row. Okay, and then he can do he can use the same strategy. That is, like he can compare these two pebbles, with his touch, and he can compare and he can judge which is smaller or bigger and so on. So the same strategy works there as well. Now this was the level 1 of the game. Now the level 2 is something similar, right? Instead of the smaller pebble, we look out for the larger pebble from this lot. Then what the difference is that we do a swap when the pebble in our hand is smaller than the pebble which we currently examine, right? So in this case we do a swap. That's all. So at the end of it, after examining all the containers, we'll have the largest pebble in our hand. So that was the level 2. Now coming to level 3. So level 3 is all about repeating the strategy in order to accomplish another task, that is sort the pebbles. Okay, so now how can we sort the pebbles using this strategy? So now we have the smallest pebble under the container 1, right? Now how do we find the second smallest pebble? Do we have to check this container? No, right? Because it has the smallest pebble. Now we just need to find the smallest pebble from these 5 containers. So what do? We use the same strategy, right? Take this pebble, take the pebble under the second container in your hand and check subsequently with the other pebbles. Okay, I do a swap because this is smaller. Again I do a swap. Again I do a swap. No swapping. So now this is the second smallest pebble which is kept under the second container. So similarly, now we have to find the third smallest pebble, which means we have to find the smallest pebble from these 4 containers, right? So yes, a swap, no swap. Okay, and yes, a swap. Okay, yes, right. So now if you look, we have these pebbles sorted based on their sizes, right? So this is the strategy where we first build upon a tactic to find the smallest or the largest pebble and then repeatedly apply this tactic to do sorting. Okay.
The key learning areas covered by this game include conditional processing, where the swapping of pebbles is done as and only when required. The concept of loops is also introduced, where the pebbles under each container are examined sequentially in order to find the smallest or largest pebble. The player thus learns the technique to find the smallest or largest element in a list and is also introduced to a sorting technique. Now, this game is based on comparing the sizes of objects or pebbles to be more specific, and it uses the sense of touch to compare the sizes of objects. This game is equally suitable for the visually challenged, as it requires the pebbles to be kept in a row without the use of any containers. The only prerequisite required to play this game is the ability to compare two objects based on their size. I hope that you find this game useful in introducing computational thinking concepts to your students. Thank you.
Hello, my name is Marika. Let me share the presentation. So yes, my name is Marika Parviainen, and I come from the Center of Learning Analytics at the University of Turku, Finland. We have a research group focusing on learning analytics, and we also develop a learning platform called Ville. It's globally available under the name Eduten. Ville-Eduten has learning paths, for example, in mathematics, with a variety of automatically assessed tasks for students and easy to follow real-time analytics for the teacher. Right now, I work in an international team creating Tetras-like tasks for learning computational thinking, of course, with analytics. And this challenge was very exciting for me, as while we are used to creating unplugged tasks for CT, our target group usually has no visual impairments. We wanted to bring the element of wonder and innovation even to visually impaired children. When you can experiment with something that clearly works, but you don't immediately see why, intellectual curiosity arises. We chose the gravity sort, which is a sorting algorithm that can be realized with, for example, an abacus. It was described by J.J. Arulanandham and others in 2002. The idea is to put beads in rows to represent numbers, and then let them move downwards, and again see the rows representing numbers, but now in ascending order. Here we see a child trying his hand with the task. Sorry for the bad quality in video. First, he feels the numbers. Top row, second row. Top row has 4. Second row has 2. Then 5 and 3. The child has a task of sorting the numbers in ascending order. He moves 2 beads from the top row to the row below, but he soon realizes that he can tilt the board. And now he checks the result. 2 in the top row, then 3, 4, and 5. And yes, it was a success. Why this game is tactile and accessible? We experimented with different tactile materials, but in the end, we chose a familiar bead. It has a pleasant round shape, it is easy to grasp, and already associated with numbers. The abacus, also familiar, is used here in an unusual way. Another option is to create an accordion-like board with more tactile materials. The learning area is clearly algorithms. Gravity sort is one way to visualize sorting and discuss the concepts of ascending and descending in tactile manner. We success dividing this activity in 3 parts. First, see how decomposing the number and moving beads swaps the places of 2 numbers. 2. Experimenting with gravity sort. Here it's important to let the child himself realize that how the tilting works. There will be someone in the class who will realize this. And then third, follow up with a creative activity. For example, designing your own sorting machine. And while working with this challenge, we realized that tactile element is important also for not visually impaired children. It motivates and it adds interest. And this event and the Grand Tact Challenge serve as a reminder to us all. So thank you for organizers and to all you participants. Again, thank you everyone. If there are any questions, please.
Yeah, hi Marika.
Hello.
Yeah, hi. And is Shabana there? Shabana, can you turn on your video and say hello to everybody?
Hello.
We have Dr. Manohar and Supriya with us. Sabita, turn off this presentation. Yeah,
Hello, sorry, I have some connection problems. I didn't quite
hear you very clearly.
Okay.
Yeah. She can't hear us. Yeah, am I audible? Marika, can you hear me? This mic is not complete.
No, not clearly. I'm sorry. Sorry, it's probably my computer.
Okay, Supriya, can you hear me?
Yes, now you're good.
Okay, so Supriya and Manohar, can we have you say a few words to everybody? Yeah, Supriya?
Thank you so much, CSpathshala and ACM India for organizing this TAC challenge. We are extremely grateful that at Vision Empower and with Microsoft Research and Ludic Design for Accessibility, the work that we are doing is really catching on with people. And I think we see a lot of interest in the community, and we see so many of you who are working with mainstream schools also come up with great ideas on inclusion. And we really look forward to working with all of you in the future. Thank you so much for this opportunity.
Thank you. Can we have Dr. Manohar?
Yeah, first, I repeat all the sentiments of Supriya. I wish I was there in person. I was planning to come yesterday, but I fell unwell, and so I am remote looking at it and wishing I was there. Again, very happy to have such enthusiastic participation in the challenge, and look forward to this being a growing activity among computational thinking. So the main point I want to make is, like both the presenters made a point, tactile computing is not just for children with vision impairments. It is a different modality for enhancing understanding of the concepts to even sighted individuals. So it requires all of us to continue this momentum, hopefully beyond this conference, and look forward to many more interesting and exciting approaches to CT with the tactile. Thank you so much for the opportunity. Thanks to ACM and CTiS for including this challenge at very short notice and pulling off such a fantastic event. Thanks so much. Thank you.
Thank you, Dr. Manohar. Do you want to unmute yourself?
thanks to Marika and Shabana. Your activities were awesome, just awesome. I think we loved it. The VE team is was watching all of you, both of you, and they just love your activities. I'm sure we're going to incorporate them into our programs. So we have interventions across India with the children. Dr. Manohar is our mentor. And I'm sure Dr. Manohar will agree that we can incorporate these into our curriculum very soon.
Just wanted to add, Shabana's the demo was really very well done. I think it conveyed it extremely well. And I just wanted to add that there is a third level that you could introduce in the first mixed bead. You could then ask the question, can we do the counting of all the different shaped beads in one pass around the loop? And the answer will be yes, you can, if you have 3 people counting each bead separately, like 3 registers for keeping the value, right? And so it gives you another level. And my understanding, I think Supriya and team have much more, is that when you let the children ask these questions and answer them themselves, it leads to very interesting insights and further improvement of the concepts. So thanks again. And Marika, I was not aware of these programs. I'm going to look up your programs, and we will be in touch, I'm pretty sure. So very, very happy that you could take the time to participate in a remote challenge in India. So thank you so much for your participation.
Anna, can you unmute?
Yeah, hello everyone. I'm really sorry I couldn't be there in person to attend the event. But first of all, I would like to thank Dr. Manohar for the insightful comment. Yes, that is true. We could definitely add a second level, I mean, an extra level. And yes, I mean, so, and again, big thanks to CTiS for organizing this challenge. It was fun actually, putting the thinking caps on and coming up with the game. And I'm really glad that it was also shortlisted. Both of them are shortlisted actually. So thanks a lot. I really hope that the educators and teachers find these games useful in introducing the CT concepts to students. So thank you. Thanks a lot for this opportunity.
Is eagerly waiting to go out. So for the benefit of all the online participants, we will be recording the 10 games and we will be playing it at 4 p.m. for all of you. And that is the time we have to vote for all of them. So please remember the games that Shabana and Marika have demonstrated, and we will share the voting forms at 4 p.m. Thank you so much. And for online participants, we'll be back at 2 p.m. Thank you, Dr. Manohar. Thanks, Priya.
Thank you, Dr. Manohar, for joining despite being on.
Thanks a lot, Sonia and Jam. Miss being there. So hopefully next year on this next CTiS.
All the best to the rest of the participants, finalists there.
Yeah.
Wish you all the best and have great fun now playing all the games there.
Yeah. Bye bye. Thank you.
Bye. Bye. Thank you.
Okay, so we have time till 1 p.m. outside, and the from 4 to 6 p.m. as well. So if you are not able to see all, don't do it in a rush. We have another 2-hour session at 4. Yeah. So thank you so much for being so patient with our technical details, and let's have some fun. Pardon me? Hi, Paul. Hello.
No, no.
Paul, can you share your screen? We can test that out.
It won't let me at the moment. So you need to stop sharing. That might help. Yeah.
Yeah, we can see your screen, Paul.
Good. Do you want me to stop sharing again? Or leave it like this for now?
Paul, we can let this be because I think we just take a couple of minutes to start. So I think let's keep the screen.
His video is on. In Paul's video.
Paul, we'll get started in a couple of minutes if it's okay. Yet lunch was a little further away and people are just coming in. And we'll start in 2 minutes. I hope that's okay. Can you hear me, Paul?
Yeah, I can hear you. Can you hear me?
Yes, I can hear you loud and clear. We'll get started in 2 minutes.
Okay.
When you was a little further away, people are just walking or just coming in. And when most people are in, we'll start in a minute or so.
Can you hear me?
Yes. Ask Paul whether it's
Paul, can you hear me?
Oh, yes.
Oh, great.
A bit echoey, but
So good afternoon, everyone. And we had a wonderful session in the morning, and we have a perfect speaker for the afternoon to get things started. Please join me in welcoming Professor Paul Curzon,
He's a professor of computer science at Queen Mary University of London. He co-founded Teaching London Computing and CS4FN projects promoting the fun side of computing to schools. So in case you remember, we have done some of his activities in our classrooms, the magic trick, when we spoke about Dominic Bobby, all of those activities are ones which came from the work that he's done for CS4Fun and Teaching London Computing. He writes much of the CS4Fun magazine and creates activities for teaching computing through stories, role play, games, puzzles, and magic. He has won several excellence awards, and his research includes computer science education and healthcare interaction design. So again, please join me in welcoming Paul. And Paul, over to you. Thank you.
Okay, thank you. So what I'm going to be talking about today is something I've been doing in the way I teach for kind of 25, 30 years, which is unplugged computing. So I'll talk a bit more about that and what I mean by that, but generally teaching away from computers. But I also want to talk about semantic waves, which is a theory of why things like this work. So what I really want to do is combine both what I do and something of the theory about how to make it actually work. So this is actually all part of my Computer Science for Fun project. So teaching London Computing and Computer Science for Fun sister projects. And I've just got a new project to support teachers. And essentially what I've been doing for the last 20, 25 years or so is trying to support teachers to teach computing, but through fun stories, research, history of computing, activities, and so on. And so you can follow this on my blog, cs4fun.blog. And part of what we're doing as well now in this new project is trying to promote diversity and careers in computing. So everything that I'm going to talk about is actually on the Teaching London Computing site. So there are lots of activities there as well. I'm going to do a couple of activities, but there are many more free and available on the Teaching London Computing site. So let me just...
Sorry to interrupt you. Do you want to get into the slideshow mode?
No, I'll stay like this just because it's easier to control and I can see what you can see, and I'll be switching screens. So it makes it easier, as long as that's okay and everything's visible.
Sure, thank you.
So what I've been doing most of my life is teaching computing, but doing it in an unplugged way. So not unplugged alone, teaching programming is the main thing I've been doing for sort of 25 years. I've been teaching introductory computing, introductory programming to undergraduates, but also spent a lot of time going into schools and doing talks in schools and so on. And I use unplugged computing as a way to introduce concepts. So programming is obviously a skill, but it's a very conceptually heavy skill. And it turns out unplugged computing is a really good way of teaching concepts. And it's also worth noting that you really do need to teach the concepts. You can't, with programming, just treat it like a pure skill and expect people to basically just practice the skill. You need to understand the concepts as well. So teaching those concepts is really important. And unplugged computing is just a way of doing that, where you get away from the computer and use things like analogies, similes, metaphors. You can role play computation, tell stories, do games and puzzles, do magic and mystery. And all of those, the idea is to try and make abstract, intangible ideas physical and tangible. So you can kind of point to them, touch them, feel them, move them about. And it also makes it fun. And also, I believe a lot of these kinds of activities are good over gender diversity as well, that they kind of make it interesting for boys and girls. It's not just sort of something where what happens, at least in the UK quite a lot, is the boys take over the keyboards if you try and do group work and the girls get pushed out. So doing things away from computers is a very powerful way, but the core thing about it is it's about making things visible and physical, because everything that goes on in a computer is just hidden inside the box. So I've done a lot of this, when I'm teaching undergraduates, every lecture, I try and do something along these lines to illustrate the concepts that lecture is about. When I go into schools, we do lots and lots of this. But how do you make it work? So it is possible to do unplugged computing activities, and the kids just end up thinking all that they've done is play games. So I've been thinking a lot about this over the years, and then a few years ago I came across work by Cole Mayton called legitimation code theory, and in particular something called semantic waves. And what this is actually a very general theory about what makes a good learning experience, and it's actually much wider than that as well. But for as far as my interest goes, it basically is a very simple idea about how to do a good explanation in a simple sense, but also more generally large learning experiences over a lecture or even over a whole term. What should they look like to make a good experience? And it's been applied to all sorts of subjects, from chemistry to ballet. And what I realized when I came across this is it really closely fits the kind of things I do, and it gives me a kind of explanation of why unplugged computing works, but also how to make it work, and what mistakes you might make that could make it go wrong. So that means it gives you a practical way to improve unplugged lessons, as well as lessons more generally. Even if you're not using unplugged computing, the same kind of approach works just as well. So what is it all about? Let me first try and explain what I mean by a semantic wave. So basically, the idea in this theory is that a good learning experience follows some kind of wave pattern. So what we're trying to teach is a set of abstract concepts together with skills, but also mastery of a technical language. So what we want our students to be able to do at whatever level we're teaching them is to become experts at that level. And being experts means you understand the concepts, not just that you've got a simple definition of a particular word, but that you've got this deep meanings, lots and lots of meanings that you attach to it. So, if you mention a particular programming concept or construct like a while loop, there's all sorts of things that I could then, for hours start talking about things that are related to that, unpacking what that actually means to me. And I've got lots of very deep understanding of that, that go deep into the way I do research as well, and the kind of research I've done into the past. About my area for a while was program verification. So, just mentioning while loops, and I can start thinking about the way that I would go about proving a while loop did the right thing, and so on. So as an expert, I've got really deep, rich understanding of that concept. But novices don't. They don't know anything about it. It's completely new to them. And so we're basically trying to teach them these things that at their level are completely up in the clouds. They neither understand the language nor understand the concepts. And that's what we're trying to explain and get them to be able to do. On the other hand, there are things that they do understand, concrete things, everyday language. And so a good teaching experience, according to this theory, is taking these hard to understand things and linking them down to easier to understand things. And this is called unpacking. So explaining in terms of concrete things, giving examples, giving context. Might just be giving diagrams, you might be giving metaphors or similes, you might be saying it's like this, but you're using concrete things that they already understand and can relate to, and also potentially everyday language. And so that's kind of unpacking these abstract concepts into something simpler that the reader already knows well or can understand. So instead of being in the clouds, we're now very grounded and concrete about what we're saying. And we hope that that means they can understand these things. And then in a good learning experience, having introduced these things that the people understand, and hopefully, as you've done so, linked the things we're trying to explain, you then repack, you link back and take them back up to the abstract world again. And that's where you get this wave structure from. First unpacking into things people already know, and then repacking. And in a simple way, that's what I'm trying to do here, just with this diagram. So a diagram is an example of a more concrete thing. So I'm taking this phrase that you may not have heard before, semantic wave, and just in a simple way, I'm trying to give you a sort of experience like this of explaining what it is. So a semantic wave is just a pattern that a learning experience or an explanation might take that starts with the hard to understand things, the concepts and the language, links it down to things that people know, and then links back up to the original things that you're trying to teach. And the idea is, in doing this, we're trying to allow our students to start to be able to work at this top level, that they understand the concepts and they have the technical language, they master the language. So as time passes over an explanation or a lesson, we should be doing these kinds of waves. The waves could be the other way up. You could start down with concrete things, link them to the abstract things, and then link them back again. It's the waves pattern that really matters. So the theory also says something about bad experiences, and this is the kind of thing that's very easy to do when you're an expert, that you just use a lot of jargon, a lot of technical concepts, and you don't really ever unpack them. And you stay in the world of abstract concepts. You explain your abstract concepts in terms of other abstract concepts. You explain the technical language in terms of other technical language. You stay in the language of experts. And eventually we want our students to be able to do this, but they can't at the beginning while they're learning. That's the end point, them be able to live in a world like this. So if we teach like this, where we never linked down to things they know, then we basically flatline them. And I've had a learning experience when I was an undergraduate a long time ago. You know, certainly some of the lecturers did this to me, that I ended up learning nothing because I just couldn't link any of what they were saying to things I understood. And you can find this kind of explanation all over the place. So, you know, just a simple explanation going to the beginning of a Wikipedia page. I mentioned while loops, while constructs earlier. You know, this is a sort of definition from the beginning of a Wikipedia page for somebody who decides to look at Wikipedia to find out what their lecturer, their teacher means by a while loop or a while construct. They might find something like this. So this is very dense meaning. It's basically all technical words. You know, I've colored in red all the words that have a technical meaning. So it's a block of code, condition expression, it's evaluated, things are true, things are executed, things become false. You know, all of that, if you don't already know what all these technical words mean, you're not going to understand anything about this as a result of reading it. It doesn't give you any enlightenment unless you already know what all the red words already mean. There's one word in here that actually might help, that's kind of buried in it, which is it's about repetition. But the other thing about all of these words is there's other meanings of them that you might start as you're grappling to understand what this is about. You know, you might decide, oh, block, it's something about buildings, blocks in buildings, or spies, we're talking about codes, guillotine, somebody's being executed. We're talking about expressions, are people happy and unhappy, or is it about lie detectors? We're talking about true and false. You know, there's all sorts of everyday meanings that just take you on false trails that are nothing to do with the technical meanings. But as you're grappling to try and understand this, you know, those are the meanings that might come to mind. So this is an example of flatlining, just giving a straight definition. If that's all we did, then we're not really giving a good learning experience at all. Now, there is another way to give a bad learning experience, another way to flatline people, and this is where you can go wrong doing things like teaching with metaphor or teaching using unplugged, which is to flatline people low, where you mention, you know, perhaps you suggest what you're teaching, but then actually you never really make any links. You just do everything with concrete examples and everyday language, and you never really make proper links up to the thing you're trying to teach. So when you do it this way, basically the students come away thinking you were teaching them about cooking or something because you were talking about recipes. And if you don't actually link that to what you mean by the link between a recipe and a program, say, they won't get anywhere. And also where that linkage breaks down is important. So, you know, they come away thinking, but I came here to learn about computing, but nobody's taught me any computing. And that's a typical thing. It's easy to do when you're teaching in an unplugged way away from the computer. You just get lost in the examples and forget about making strong links to the abstract concepts and the technical language you're trying to teach. So I'm going to give you a third way. So this is all due to Carl Maton and part of his theory. that there are other ways, and this is much more common as well, perhaps, of giving a bad experience, where you do down escalators. So you do link the abstract concepts and the technical language you're trying to introduce down to concrete examples, but you then stop at that point and then go on to the second concept and then link that down to concepts. And it turns out this doesn't give a very good experience either, because you're never relinking things back. So you're not making the strong connections back to the thing that you're really talking about. And so again, people can be left feeling that you were just teaching them about the everyday things, about recipes or whatever, if you do it in this way. So what you need for the good experience is not only to go down, but to then link back up again, not just to unpack the concepts, but then to repack them back together. Once people have understood the things you're talking about down here, link each of them back to the actual technical things you're talking about. So LCT and semantic waves have been used in a research context in a very detailed way. So, you know, if you read some of the literature about it, it's all about very, very kind of detailed understanding, sentence by sentence even, of what people are saying and how that's sort of following these wave profiles. And Carl actually kind of thought that, you know, that's one way of using it, but also it should be used in a sort of everyday, just helpful way. And so we started to think about, I wanted to come up with something that was quick and simple, the way I could very easily work out when I was doing things well or when I was doing them badly. I don't want a dense technical method that takes a long time. I just want something quick and simple. So with my PhD student, Jane Waite, we started to sort of think about, well, can we do Carl's sort of heuristic way of doing this and come up with simple questions to ask about an activity? So we came up with this idea of using heuristic semantic profiles, so really sketchy drawings of what's going on, where we're not really worried about the detail, but just relative shifts. You know, in one step of a lesson plan, did we go up or down? Did we link down to concrete on simpler meanings? Did we use everyday language? Then the curve is going to go down. Or did we go more abstract to more technical meanings? Then the curve's going to go up. And so what we're trying to do here is sort of then just in a very rough way plot whether things are going down or up as we go through the learning experience, through an unplugged activity in my case. And so what you then get are very sketchy wave structures like this. You don't get really smooth, perfect waves like that earlier diagram. You get something like this where, you know, you start with a learning outcome and then you break it into the concepts. And so you've gone down a little bit, you've broken things up, but then you link back to the definition. So we've gone back up to the original technical term, and then we give a technical example. So we've gone down, and then we describe in terms of an everyday concept, we've gone down further. And then we talk about how that everyday idea links back to the computing concept. And then we link that back to the original learning outcome. So we're just kind of plotting very rough ups and downs here to give us an idea of what's going on. Okay, so then once you've drawn a sketchy thing like this, you ask some questions. So the three that we came up with originally were that we think kind of matter the most as a teacher. First thing is, are you following this rough wave shape? It doesn't have to be perfect, but is it vaguely U or N shaped? So are you doing both unpacking and repacking? And if you are, that's a good thing. If not, then look for places where you could perhaps make it more U-shaped. Second thing is, how far up and down do you go? Are you just sort of going to very technical examples, so not down very far overall, or are you going to everyday things and everyday language, you're going down a lot lower? So how far down do you go? And also, having done this, I suddenly realized I quite often don't go all the way back up. So I go all down deep, but then I only go halfway back. I don't link all the way back to learning outcomes sometimes in some of my activities. So how far up and down do you go? And then who's doing the packing? And again, this is something my student Jane pointed out that I'm not so good at, and she pointed out is really important. Is it the teacher who's doing the unpacking and repacking, or is it the learner, or is it both? Because if it's just the teacher, who knows whether the students are doing anything? And that's where it's important that you bring in practical activities, get them actively involved. So I'm going to do this now. So that was a very quick introduction to the theory. And what I want to do is also show you some ideas of unplugged activities, but give you an idea of how you could think about semantic profiles like this as you're planning an activity, or even after you've done it, to think, you know, could I improve that? Could I do it better later? So I'm going to do a very fast version because we don't have a lot of time here. And I hope I'm going to have time to do 2 activities just to give you a variation. But to make it practical for you, what I want you to do is do some repacking yourself. So I've just described this idea of semantic profile. So I want you, if you've got pencil and paper, actively draw it, but otherwise just think about it. As I go through this activity, can you spot points when I'm going down a semantic curve? Can you spot points when I'm going up to more technical meanings? And just draw a rough curve to see what kind of shape you think I've ended up with. And I'll show you what I kind of think as we go along. So to do this, I'm going to do an activity, and in this case, a quick magic trick. So I'll start the activity now. If you're going to have a go at thinking about the semantic curve, you kind of start drawing the curve from now. So what the activity is about understanding what an algorithm is. So the aim at the end of this is you'll be able to explain the concept of an algorithm and use the technical term algorithm in a correct way. But I'm going to use a magic trick to actually do this. So we're going to move into the world of conjuring and magic tricks and link that back. But first, let me just give you a very rough idea of what I mean by an algorithm. It's basically a set of instructions, just instructions that someone or something can follow. And the idea that makes it an algorithm is really at core, it's that if you follow those instructions blindly and precisely and very accurately, it always leads to some guaranteed outcome. So if you follow the algorithm, something good happens, or something that you wanted to happen does happen. And that might be something like, you know, following an algorithm for doing primary maths, for doing multiplication, for example, that you were taught it in primary school. If you follow those instructions, then something good will happen, guaranteed. You will always get the right answer to the multiplication if you follow the instructions of how you were taught. So let's kind of look at a bit more about what we mean by that by looking at a magic trick. So this trick is called the teleporting robot. It's actually a magic jigsaw. So actually, if you can see me on the screen, this is actually a physical jigsaw. You can take this jigsaw and cut it out and make it work. Because I'm doing unplugged activities over the internet, you're going to see a on-screen version of it. But if I was doing this physically, I would get people gathered around and I would do a physical jigsaw version of it. But for speed, I'm going to do this way as well. So this is just a jigsaw. It's a picture I drew of lots of robots. The trouble with robots is if they start to gain artificial intelligence, they start playing tricks on you. And these are particularly tricky robots that I ended up drawing. But what I want you to do is just count the robots. So how many robots are there in this picture? So I'll count them with me. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 robots in this picture. There's also 4 green monsters and there's a robot dog I didn't count, but there's 17 main robots. So hopefully everybody agrees with me about that. If I was doing this live, I'd kind of do a show of hands to make sure everybody agrees there are 17 robots. Let's double check. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17 robots. Okay, the point about this is if you give them the chance, one of these likes to disappear. So if I just can get this going. So all we're doing is moving the pieces around and then putting them back together. And now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 robots, 4 green monsters and a dog. Move them back again. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's reappeared. So how can I make a robot appear and disappear? Let's double check. We move the pieces around and now there's 2, 4, 6, 8, 10, 12, 14, 15, 16 robots. So just like that, I can make a robot appear and disappear just by moving the pieces around. And as I said, you can download this from the CSFun website, cut out the pieces, move it around, and you will be able to do this trick yourself. You just take the two pieces on one side, move them over to the other side, and move the bigger pieces across, and a robot will appear and disappear. So you can do this trick. It's very easy to do. And that begs the question, how can you do a magic trick when you probably have no idea how it works? So the point here is, can you tell me which robot is appearing and disappearing, and how is it doing it? Is it teleporting away? Is it being eaten by a green monster? But you could be the magician here. You could actually be the one presenting this. You can do it sort of close up to family, friends, or to a class of students. And even if you still don't know how it works, you can do the trick just by count the robots, move the pieces around in the way it's happening on the screen, count the robots again, and one of them will have disappeared. Move the pieces around again, and the robot will reappear. So I'll leave you thinking about that. If you do want to know how it works, then you can go to our website, but this is a magic trick. You don't give your secrets away just in the magic show, so I'll leave you guessing. And you can download this from that bit.ly link, bit.ly/teleporting robot, and do it yourself. But the question I want you to really think about is, how can you do a trick even without knowing why it works? How can anybody do magic and it work when they haven't a clue what's happening, how it works, why it works? And all you need for this trick is really to know the set of instructions to follow. So as I said, build a jigsaw, and actually you put the smaller pieces of the top two layers on the left to start with, count the robots, remember how many there were, mix up the pieces. So you can, if you're doing as a trick, actually mix the pieces up first and then rebuild it, and rebuild it this time with the top two layers the other way around, with the smaller pieces to the right of the jigsaw this time, and it will still work as a jigsaw. And then count the robots, and the robots disappeared. So just by following those 5 instructions, you can make the trick work, and it's guaranteed to work as long as you follow the instructions exactly. So what has that got to do with computing, and what is actually going on here? Well, it's what magicians call a self-working trick. So a self-working trick is just one that if you follow the steps in the right order, do them precisely enough, then the trick just works. You don't need any special skill. You don't necessarily need sleight of hand or anything. Just follow the instructions and it works. And you don't have to know what you're doing with a self-working trick. As long as you do it and do exactly as you're told that the magic book tells you, it will work. And actually, that's exactly the same concept that computer scientists call an algorithm. An algorithm is just a computer science word for a self-working trick in essence. So what is an algorithm? Again, it's precise steps that if you follow them, guarantee some results. And that's what a self-working trick is. It's a set of steps that, if followed, guarantee. And this time, the result is just a magical effect, whereas with an algorithm, it's whatever calculation or computation you want it to happen. So on the earlier slide, I wrote the steps in English for a human to follow. Of course, a difference here is with algorithms, we tend to write them in programming languages for a program to follow, for a computer to follow. And why do we do that? Well, we want computers to be able to do all the miraculous things they do. And how do they do it? They do it just by following instructions, because computers have no idea what they're doing at all. A computer doesn't know what it's doing. It can't see, oh, something's going wrong here, and change its mind and do something different and recover. It just follows the instructions it's being given. And so that's why computers need algorithms. And if I got you to do the trick, if I was doing a slower version of this, I would have handed out the jigsaws and got you all doing the trick yourself. And then I would be telling you the instructions and you would do it as I told you. And I would be essentially programming you like a computer. You don't know how the trick works, but still by following the instructions step by step, it does work. That's what I need to do with a computer. Give it the instructions, get it to follow them step by step. And the point is, computers can only follow precise steps and they can only follow them blindly. If the steps aren't accurate enough or do the wrong thing, then the wrong thing will happen. So we have to write them in a precise language just to make sure there's no ambiguity about what they should do. But it is about blindly following steps, and they have to always work. We don't want a computer program that sometimes works when the computer follows it and sometimes doesn't. Just like a magician doesn't want a trick that sometimes works and sometimes doesn't. Okay, so at that point, that's the end of the magic trick, and I hope I've introduced something about what we mean by algorithm. This is a fast version, so I won't actually get you to do this, but if I was doing this in a lesson now, what I would get you to do is now write down for yourself what you think an algorithm is. Write out the sort of basic explanation in your own words of what an algorithm is, to make sure you've actually kind of internalized what we've been talking about. And then after you've done that, I would come back and talk about what I think the precise, the important aspects of an algorithm are. Things like its instructions of how to do some specific thing. You've got to follow the algorithm's instructions in a specified order. You've got to do them exactly. But if you do, they guarantee to do that thing correctly. And actually, just to introduce another concept, essentially, you need a computational agent to be able to blindly follow the instructions. And what do I mean by a computational agent? Just something that will blindly follow them without knowing what it's doing. So if you were doing this teleporting robot trick, you'd be acting as a computational agent, just following the instructions, not knowing why it works. But if you do the instructions exactly, then a robot appears and disappears. So you don't have to have any understanding of what you're doing or why as a computational agent. And that's essentially what computers are built to be, computational agents. And the result should still be obtained even without any understanding if this algorithm really is working as an algorithm. Okay, and that's sort of the end of the unplugged activity. So what I've been doing there is trying to explain the concept of an algorithm. So doing this with a fairly simple concept. I've used a magic trick to do it, an unplugged activity. Hopefully, if you were thinking about this as I was going along or even drawing it, you've perhaps drawn some kind of semantic profile. It may or may not be exactly what I've drawn, but my first version of this, the way I originally did that teleporting robot trick, actually at science festivals originally, this is sort of the semantic profile that I planned, a series of steps through the trick that more or less correspond to the slides I just gave you. So I start off with a learning outcome. I then explain the aim of the trick is to understand algorithms, but don't say anything more about that. I do the trick, set out the instructions to do the trick, make this link between self-working trick is the same as an algorithm, and that leads to the idea of programs, and then summarize the meaning of the algorithm. And when I kind of started thinking in these terms of these, having drawn the profile like this, and then asking my three questions about, is it a U shape? Well, yeah, this is a kind of U shape, but it's a cliff edge drop at the beginning. Going back up is pretty good. It goes up in a bunch of steps. So that part's fine. I am going all the way back up. I'm going fairly deep down into concrete things of magic tricks and jigsaws. But what I'm not doing for sure here is getting the student to do anything. And the way I just did it, it's all been me talking. I've done lots of unpacking and I've done lots of repacking. I have no idea whether you have or not, partly because I'm doing a fast version. So after thinking about doing this profile, drawing the profile and thinking about the questions around it, I actually improved it. And I did a little bit of the improvement there in that, first of all, I tried to get rid of a bit of the cliff edge by giving a simple explanation of an algorithm first. And actually, I did a bit of a wave in there just on the spur of the moment, in that I started talking about primary multiplication algorithms. So in my explanation, I actually did a little semantic wave at that point when I went down deeper to another example and then back up again. And also, when I do this now, I get the learner to do the trick. I do it, but then I get everybody else to do it. And that's getting the learners to start doing some of the repacking, not just me. And then at the end, the step that I said, oh, I haven't got time to do it now, but that's where I get you to explain it before I explain it. Again, there, it's about making sure you're doing some repacking. There are lots of different ways you can do repacking exercises, but a fairly standard one is explain the concepts that we've just talked about. Give your own explanation. And here I've improved it. It's more of a wave. It's got student doing some repacking as well. So I found a way to improve it, and hopefully that gives a better experience. Okay, now what I want to do is a different kind of unplugged activity, just to show the general idea. I've got to rely on some technology at this end working for this, but what I'm going to do, again, an unplugged activity, that was magic. This is about the idea of role-playing computation. And this may or may not work when I switch technology. Looks like it may work. Okay, so this is an activity called box variables. Again, you can find this on the Teaching London Computing website and the resources to do it. But the idea about this is to teach variables and assignment. And I found, as I've been teaching programming over 25 years or so, one of the biggest hurdles for real novices is getting over what the meaning of a variable is, how variables really work. And if people don't get over this, they end up thinking they'll never be able to program. They just think they're thick, or they just can't do it, or programming isn't for them, and they give up. But it's actually a really easy thing to understand. It's easy to fix, but it's easy to misunderstand it. So I've decided early on, I've got to find ways to teach this better, but also find when people haven't understood it and then fix the misunderstanding. So it's really important understanding how variables and assignment work. So I'm going to do this as an activity again, and you can think about the semantic wave as I do it, and what kind of wave shape am I creating. And so what the aim of this activity is to understand variables and understand, well, at one level, a variable is just storage space that computers use, but it's more subtle than that. So what you've got to be able to do at the end of this is explain what a variable is, work out what simple variables, simple programs that manipulate variables do step by step, ultimately be able to draw dry run tables, and then the next step after that would be able to write programs using this. Okay, so first of all, let me say, what do I mean by they're more subtle than just a storage space? So you can think of a variable in a program as just like a storage box, and this is a common way of doing it. And I actually have sort of old photocopier boxes that I use. When I'm teaching this on stage, I kind of take in boxes that we use, but they're more than just boxes, and you can end up with misunderstandings if you just talk about them as boxes. So I talk about them as special boxes that can also store, create, and destroy as well. So it's a box that's got an integrated shredder and an integrated photocopier as part of the box. So it can copy things, but it can also destroy things. And I don't know whether this made it over to India, but there was a couple of years ago, kind of near the start of the pandemic, a British artist called Banksy actually made a storm by one of his works of art was sold at auction. And the moment the auctioneer's hammer went down and said sold, the frame of the piece of art went into action and started shredding the picture that had just been sold, and it sort of started to appear out of the bottom. So if you came across that, go look up Banksy shredding art and you'll probably find it. But that's the kind of idea I'm thinking here. It's a box that's got a shredder in it, and it can shred the things in it when you ask it to, but it can also make copies. So this is my idea of what a variable is. Now, to really illustrate what I mean by that, we need a bit of a program. So I'm going to use a very simple bit of code here. This is actually in Java, but this will work in any language. And what I'm going to do is go through this program line by line in terms of boxes. Now, if I was doing this and I was there live, I would get three of you out the front and I'd be giving you boxes and we'd be doing this with people. Because I've got to do it over the internet, I'm going to do unplugged over the internet again. So I'm going to attempt to swap what I'm sharing, and hopefully you'll see a different screen. You'll have to remind me when I forget to switch back. So hopefully you can now see my table desktop with my hand around. And what I've got here is a row of boxes that I'm going to illustrate this activity. So what I'm going to do is talk you through this program. So I'll do it a bit at a time. It's Java, so Java has declarations. If you're used to Python, you won't necessarily like this idea of having declarations. But what I'm going to do is go through these instructions one at a time and show you what happens with the program. So the first 3 lines of the program are string color 1, string color 2, string temp. So what do those 3 lines actually do? They just say, go and get some boxes. So if I was doing this live, I would have people holding the boxes. I can't do it live, so I've brought some Lego figures along out of Star Wars. They're suitably diverse, at least as diverse as I can get. So we've got Leia, we've got Finn, and we've got R2-D2 to represent different groups, and they're going to essentially hold my boxes. But when I do the first instruction, I do these one at a time. And the first one says string color 1. That says go and find a box. So find any box and give it a name. So I give it a name. So this is where Finn comes in to hold the name. That box has now been named color 1. And then I move on to the next instruction. That says get another box called color 2. Oh, and these boxes have got to be big enough to hold data called strings. So strings are just sequences of characters. But then we need another box, same size of box, and we're going to call it color 2. So I'll get R2-D2 this time to look after that box, and color 2 now exists. And now I'm going to use those names. They're just there to help me know which box to use. So I go on to the next, and that says string temp. It's doing more again, so Leia can come and help me now. So I need another box, Leia's box this time, and it's going to be called temp. So we've already got something associated with these boxes. The boxes come with names. And so there's the box and there's the name, and they're separate things. Okay, moving on with my program now to the core of the program that does all the work. Having set up my resources, that's a little bit like a recipe, collecting the ingredients. But now I've got to go through this line by line. And again, we do this one line at a time, one after another. That's one of the things people often misunderstand, and they think you do it all together, or it doesn't matter what order you do things. You follow instructions in order. So the first instruction says color 1 gets the value red. So what is that saying? It's saying we've got a storage box, find the right storage box color 1, and it's saying put the string, the value red in it. So that's what I do. I get a value red, and that goes in the box color 1. And so that's the box's variables are working like a storage space. This is a storage space. I've now stored something in the box called color 1. And if I ever want to get it again, as long as I've remembered the name color 1, the name gives me a way of getting that. So now there are 3 things that we've got to realize that are different about variables. There's the box itself, which is the variable. There's the name of the variable, color 1, and there's the value that's stored in it at the moment. Okay, so then having done that, we can move on to the next instruction. And the next instruction says color 2 gets the value green. Okay, so that's basically just doing the same. We've got to find the right variable, color 2 by its name, and we put the value green in it. And having put green into color 2, same thing happens. It just stays there. It's a storage space. Color 2, R2-D2 will guard it for me. And if I ever need it, I'll be able to get at it by using the name of the box. Okay, keeping going then. Now something slightly different happens. Temp gets color 1. So what does that mean? Well, at one level, it's the same. I'm going to put something into the box called temp. But what am I going to put there? Not color 1 itself. Giving the name of a variable says go and get the thing from color 1 and put it there. But this is where it's not just like a box. It doesn't mean go and get the value out of color 1. It means switch the copier on. So this is where I mean the boxes have copiers associated with them. What it actually says is make a copy of what's in color 1, take that copy and put that into temp. So temp gets a copy of what's in color 1 is really what this is telling you to do. And so now we've got 2 copies of this, and we haven't changed color 1 at all. An instruction like this, an assignment, only changes temp. It doesn't change the thing on the right-hand side, only the thing on the left-hand side is changed. So temp gets color 1 means temp gets a copy of what was in color 1, but color 1 stays the same. So far, so good. But now we've got something similar again. Okay, maybe this will just be the same. This says color 1 gets a copy of what's in color 2. Okay, so far, so good. We go to color 2, press the copy button, we get a copy of what's in color 1, and now we've got the copy leaving, of what's in color 2, leaving color 2 alone. But now it says put that into color 1. And again, this is something people get confused. They think storage boxes, oh, I could fit lots of things into a box. But no, once you put something new into a box, the original thing is destroyed. So if I'm going to put a copy of color 2 into color 1, so green goes in there, the original value gets destroyed. So this is where the shredder comes into action. And I really do mean destroy. It kind of completely gets shredded into small bits and totally destroyed, eaten, spread across the room, so it can never be got back. It's completely gone, unless of course you made a copy and stored a copy somewhere else. Okay, now we've gone through everything that happens. So color 2 gets the value temp is basically the same. So color 2 now gets a copy of what is in temp, so we make a copy of that. So I go to temp, I make myself a copy of that, and that's going to go into color 2 this time. So at this point, I put the new value in and I tear this up. Actually, I don't have the budget to tear randomly pieces of paper up, but you can imagine this is totally shredded, but I'll keep it so that I don't waste paper. But you can't get it back. It's gone, it's shredded. And at that point, I've finished executing the instructions. I've done them one after another. What do we mean by execute? Just follow the instructions and something happens to the variables. But the key thing there was the variables aren't just storage spaces. They can't store more than one thing. What you're doing is making copies of things and then destroying when you put a new value into a variable. Okay, I'm starting to run out of time, so I will stop this and cut this short and go back to my slides again. At this point, oops, hopefully this is working. So at this point, what I do is I have question and answers, and people would be able to point at the boxes and say, well, okay, can you just go through what happened with Leo again? Or why did that happen there? Or what would happen if you didn't have temp is the normal question people ask me when I'm doing this. And so we can then act it out and actually do exactly what people were asking. So, and at this point, I've told you a lot about variables. So what I would get you to do now is do some repacking yourself, actually try and write down everything you know about variables, what matters, give your own explanation of how variables work. And then, having you had time to do that, I would then go through and summarize what I think the main things that you should have picked up from this. Things like it's a storage space that holds data for later use in a program. They have names there, so the computer knows which one's meant. They hold values, and values are different to names, and they're different to the actual variable itself. A variable is the storage space. It has a name, it has a value that's in the storage space. And it's important not to confuse variable names with values. They can only store one value at a time was an important point. And when you access the variable's value, you make a copy is the important point. The original value is not changed at all. And when you put a value into a variable, you destroy whatever was there. So they're kind of the main things I want people to have picked up about this. So me summarizing it then allows people to compare that with what they wrote and see what they missed or if they confuse things, and then we can do question and answers again, and that is another chance of doing some repacking. So again, when I originally started doing this activity a long time ago, the original version of it looked something like this. So I do the learning outcome. I talk about in terms of a box, a shredder, and a copy. I give an example program that's actually doing a little bit of a curve because now we're down at everyday things. And then I go back to the program that's a bit more technical. So I've gone back up. Then I introduce the role play. And then all the way through the role play, what I was trying to do there was jump between the boxes and the program. That's why I actually printed out the program and put it there on the screen in front of you with the boxes, so that I can go between pointing to the boxes and talking about the boxes and going to the program and talking about the program. And that allows me to do a series of waves where I go backwards and forwards, down at this lowish level, talking about the basics, and then eventually overview it. And of course, thinking about my 3 questions, I realize actually I can do better than this. So as we go through this, it would be better, instead of me just talking as I did just then, in the middle of the role play, I ought to have some breaks and ask people questions, give the chance for the audience to ask some questions, and that would give them some chance to doing some unpacking themselves in the middle of me going backwards and forwards. And actually I do that when I'm lecturing this. I just didn't think to write it in my lesson plan as something that was important. And then eventually, instead of me just overviewing, again, the thing I always fail to do, I just do the repacking myself. So I ought to be putting in a chance for the students to summarize. And again, maybe you can think of other places in here where you can give the students more chance to role play. The other thing about this is only one part of the lesson. So this is just the first activity, but notice it's now not just a single curve, it's waves within waves and waves following waves. And that's what really matters to make a good experience. But what I do next is actually then start another wave. I do this overview and then we go into a practical activity. And again, I've got to rush this, we're running out of time, but I do unplugged exercises now that are pencil and paper unplugged, where I get the students to use tables, dry run tables, trace tables, and pencil and paper, and I give them some simple programs and they have to work through them step by step to work out how they do. So now I'm doing another wave. I'm not going quite as deep on this wave because hopefully they've got some conceptual understanding I can build on, but then getting them to do some repacking, and this is all them repacking, and then I do it. So I'll explain how this works, which is kind of me going around the curve. And to give some context to this, one thing I might introduce is the fact that Ada Lovelace actually is often claimed to be the first programmer. So she's the person who worked with Charles Babbage in the Victorian times, creating, so 19th century, trying to create the first steam computer that was never built. And people talk about her as the first programmer, but Ursula Martin actually pointed out she didn't actually write a program. So this is a copy of it. The thing people say was a program isn't a program, it's a dry run table, it's a trace table. She didn't actually have a program to write, but she used it to find a mistake. She was using this, exactly the same method, these dry run tables, as a way of understanding how Babbage's machine would work if he ever managed to build it, and how algorithms running on it would work. Anyway, I'm running out of time, so let me just kind of start to summarize. As I was doing the sort of preparation for this talk, I actually realized I gave 3 questions. There's actually another question that's really worthwhile adding, a 4th question, which is, does the semantic profile include waves within waves and waves following waves? Because that's the thing that really makes it powerful. It's not that you just do a single wave, it's that you do waves within waves, waves following waves, so that you're constantly packing and unpacking sub-concepts and parts of it. But anyway, just to summarize, so this heuristic semantic profile method, I think, really helps improve activities. It helps you understand how not to flatline people and to check whether you're doing things as well as you could do. And it puts this focus on unpacking and repacking and how low you're going, how high you're going. It's on the important things. Is it a wave shape? And I found it, even myself, I've been doing this for 20 years. And as soon as I started doing this, I found ways to improve my lesson plans and the activities I was doing. And I think it also helps explain why sometimes people do unplugged activities and they say, actually, this, when we did the feedback of the evaluation, we found that students didn't really learn anything. And I think unplugged can go badly wrong and be just fun when you don't put these wave structures in. And so this gives a way of making sure an unplugged activity isn't just fun, it actually is successful as well. So the main things are programming concepts can be introduced in fun ways away from a computer. They're a memorable way to teach concepts. This physical enactment takes the wave deeper than just metaphor. So it's a good way of going deeper. And the box variable activity, they're key topics. So I think it's a really important thing if you're teaching programming, make sure you help the students get the mental model right for that. And Unplugged is a good way of doing it. It's really easy when you find the students who haven't got it to fix it. At which point I will shut up. Just to say, all of this is free on my website. So csfun.blog is where I write articles. teachinglondoncomputing.org is where all the activities are that I've ever invented. And my publishers like me to mention there's a book you could buy. That's the only thing that isn't free. Everything else is free. And at that point, thank you very much.
Thank you so much, Paul. Paul, can you hear me? Paul, am I audible? Can you hear me, Paul?
Oh, yes, just.
Oh, wonderful. Thank you so much.
Let me turn my volume up.
Thank you so much, Paul. I really enjoyed that. I'll just open it up for questions. First, maybe I'll take a few questions from the audience and then ask people who are online if they have any questions.
Okay.
Jan, maybe Jan, could you come here? I think it'll be easier to manage that. Yeah. Okay, she could come. You can see you as well.
Yeah, I had this question about the self-working trick, right? I mean, talk about the algorithm as a self-working trick. I saw where you were going, but you end up with this feeling of enacting something that you don't understand, right? Then where does it fit in the way? Because in the unpacking and repacking, something is still left behind.
Yes. And actually, when I do this, so this particular trick that I do with primary school kids is to help understand what an algorithm is. And actually, I do it over a lot longer time, and I get them to actually have a go at doing the trick. And actually, I don't use this particular trick for that. I use a different self-working trick with cards. What I definitely do is actually explain how it works to them. So I don't leave them like I've left you guessing. Partly that's sort of the lack of time for me to explain exactly how the trick was working. I would have needed another 10, 15 minutes or so just to make sure I go through it in detail. So I've left you hovering a bit, and I've missed out a bit of kind of explaining what was going on. And certainly when I'm doing this with kids, that I wouldn't have left them not knowing how the trick works, because that's not really fair on them. However, you're grown up, so you can go and look at the website if you really want to know how it works. But going back to how it fits into the wave, if I've got, is that the right version? No. So how I see the wave working out, I didn't spend a lot of time explaining this. So I'm going down at the beginning before the trick, where I'm just giving explanations. I then do the trick. And what I would have done is got you to do the trick and try and work out how it works as well, so that you actually start from the position of doing it and being, with the card trick that I do called invisible palming, you get absolute gasps, the whole room erupts into amazement when suddenly the trick works. They've managed to invisibly move a card from one pile to another, and they've no idea how the card moved, even though they did it. And that's a lot more powerful version of it than this one. I can't really easily do that over the internet though, which is why I switched to this particular one for that. So they do the trick, but they also spend some time here trying to work out how it works. And so they're actually processing what's going on. How do these steps lead to the trick actually happening? So they're deep into why the algorithm works, at the point where I then go on to explain the self-working trick as an algorithm, and then take them back up and back into the world of, we're talking about algorithms here, at which point they know they have actually managed to do the trick. They had this kind of 5 minutes of or longer of total amazement where they did the trick over and over again, and it worked over and over again, but they've no idea how. And then gradually they work it out, and then I teach them how it works and show them exactly what's going on, and then we go into this. So the full version of this, when I kind of do it with primary school kids, it is a lot more convoluted. So as I said, I was doing a fast version to try and just get the idea across. So if I missed out important things. Perhaps that emphasizes even more the importance of repacking and exactly how unplug can go wrong when you do them in a way that doesn't make kind of concrete links and fill in the gaps like that. So I hope that explains that.
Thanks. And just to say that was Jam. But I think what you did will work well, because I'm sure everybody's going to go back and look at the website and try to figure out, try to understand how the trick works. The next question is from Anita.
So do download the jigsaw. You can download it, cut it out, have a go at it. You've got to work out which robot disappears, and then go and have a look at the instructions after you've had a go at it for a while. If I was there physically, I would hand out jigsaws for people to have a go at it.
Thanks so much for that, Paul. Yes, absolutely had us hooked. I just had a question about the waves and the variable semantics that you were showing there.
Yeah.
I somehow thought that the waves, although they were occurring, quite often, they would go up a bit higher. Could you talk to that a bit? Because I thought the depth would be more, and then you would go back and connect with what the concept was, and then come back deeper. But maybe I had that a bit wrong.
Yeah, so the first thing is, back to what I said, these heuristic profiles they're just sketches. They're not really trying to say exactly how deep you go or exactly how high you go. They're just trying to give the idea of we're going up or down, we're going down, and then we're going down again, we're going up, and then we're going up again, rather than really trying to say how high or low they are. And I would say role play is the going very, very deep. So if we were doing this sort of on some kind of real scale, going from learning outcome to box and shredder in itself is going quite deep. An example program is actually quite high up the scale, because a program is all technical. It's a concrete example, so it's giving context. So in that sense, it is a wave. And if you just had a wave on its own, which was just doing the program and then running the program to show what it did say, then that would all be a very shallow wave up at the top. And introducing the role play, you're definitely going very deep. So actually, when I'm going backwards and forwards between the role play and talking about code, actually, I am going pretty high. I'm not necessarily going up to the full version of everything about what an assignment is and a variable is. There are multiple concepts there, assignment, variable, sequencing, that I'm all mixing together to try and give an understanding of all three. And whenever I'm talking about those, I am actually very high up in terms of it's very technical language. It's very deep concepts, essentially, that I'm trying to get across a little bit of, but I'm not doing the full version of them. So I'm not going all the way back up to the top each time, but I am going up and down. And this sketch is not, I'm not worrying about how high and low I go in the middle. I'm just sort of worrying about, am I going up and down or not? Does that answer the question?
It does. Thank you for that, Paul.
So I would say don't get too hung up about exactly what the shape or depth and so on is. More important is just, could you go down lower? Could you introduce a role play that would take you down below, the level of a concrete example? And could you go up higher? And possibly I could go higher here. I could actually do this last step and link back to the specific learning outcome that I introduced at the beginning, and that would probably be an improvement as well, thinking about how high and low. But exactly how high and low you're going isn't something to worry about unless you're doing research and really interested in the precise effectiveness of things. Okay.
I think before the next question here, I just want to remind people who are online, if they have any question, please put that in the chat.
Hi, Paul. Thanks a lot for that lovely explanation and a very precise talk it was. I would also love to introduce myself. This is Ila from PyJam, Foundation India. And I've spoken with Paul, I think like 4 to 5 years back through email. I'm not sure if you remember me. So, and I'm also happy to share that we have implemented semantic waves in our curriculum at PyJam Foundation already. And my question today is that, Paul, can we start with a wave of lower height for the repacking and then go to the next level of repacking. For instance, especially the rural communities, when talking about them, like it could be, a bit of complexity. There is a bit of complexity involved, when we introduce these terms like automation or decomposition directly to kids at primary level, right? So
Yeah.
what if we could start with something like divide and conquer, for instance, replacing the word decomposition, and then the next level we go, while we are unpacking it, we go back to a higher wave where we introduce the concept of decomposition, and then we come back. So like you were talking about multiple levels of unpacking and repacking, but with different heights, right?
Yes.
Lower level first, and then a bit of a higher level. So what are your thoughts on that?
So I think what you're saying is right. Essentially, there are different layers you can talk about. And one thing I think people are doing poorly, possibly at the moment in this country anyway, is we're trying to pack too much into primary school. And so, we are not just in computing, actually in other areas, English especially, the syllabus here has gone really technical, and the kids are having to work out, what words in English mean about grammar that I haven't got a clue what it actually means. And that feels to me like you're going too high too soon. And you can do the same, in the computing syllabus here, we've packed quite a lot into primary school that I don't think is necessary. And I think that does come down to the kind of thing you're alluding to. Essentially, I sort of mentioned it along the way in one of these examples, that once you've got people to a particular level, here, then you can build on it. And so I'm doing that just within one lesson, that I do this activity, and then I build on the activity to take them potentially higher still, or deeper into the technical stuff. And you don't have to introduce everything necessarily at once. But once you've built a foundation, you can use that as a ground thing that you can then build people on. So if you go back to the thing I said about while loops, for example, once you understand all those words about expressions and conditions and true and false and so on, what the technical terms of those mean, once you've got a deep understanding of that, you can build on that to get a deeper understanding. And then you can go into the kind of thing I immediately think about with loops, which is invariance and so on, because of my verification background. So once you've got the foundation, you can build on it, and that becomes something, a kind of bedrock. Even then, it's still useful going lower to link back. And one of the things I do when I'm teaching across a lecture course, so this is over 12 weeks, is I'm aiming to link from one lecture to another like that. So I build things up in one lecture that are very memorable, and unplugged things are very memorable. So they give you a way that I can refer back to something I did, a month earlier, and they know exactly what I'm talking about. So, when I'm teaching recursion, I'd act out on stage that The Cat in the Hat Comes Back, which is a children's Dr. Seuss story. And so all I have to do is remember the line of cats, and people then know what I'm talking about. And then I can build on that and kind of go higher and talk about, divide and conquer or whatever I'm building on top of it. So I'm doing that week by week in a lecture course, but you can do it year by year across a curriculum as well. And I think it is really important to do that. You're not trying to make them master everything on day one, and that's part of a teacher's job, to work out the right series of steps. And it's partly where lies to children come in, the idea of teaching something that's not quite the full story. Newtonian physics isn't quite the full story, but that's no reason to start teaching primary school kids, Einstein's relativity straight away. What you do is you find a series of levels that you can scaffold people up to where you ultimately want them to be. And, that's where the skill of teachers coming in, is knowing exactly how to do that, which concepts to cover first and how to build on them. And one thing I think is really important in computing, and especially programming, it's really, really important that students do get a mastery of one thing before they move on to the next, because it's very easy to get a superficial understanding and think you know what's going on. You move on to the next and then on to the next, and suddenly out of nowhere you're totally lost and nothing works the way you thought it was going to. So when I teach, I've got this idea of mastery, and I try and build in as much opportunity as I can, that the students master what I did in 1 week before they go on to exercise and activities for the later things. And again, it's a similar kind of idea. It's building a series of semantic waves that aren't just flat sea, it's gradually climbing a mountain with a series of waves.
I was asking about that. And I love it that you mentioned learning outcomes, because it's not mentioned, complex concepts, it's just learning outcomes, and then finally the teacher overviews. So learning outcomes it could start at any level. Thanks a lot for that.
Well, thank you so much, Paul. We unfortunately have run out of time now. I think there are many questions the teachers, and I think all of us, we learned quite a lot from your talk. Thank you so much for spending your time there with us. And I'm sure there are many more questions. I have a few. I'll collect all of them and send to you. And I think hopefully we can stay connected with the teachers in India as well. Thank you so much, Paul. Thanks again. Please.
Thank you for listening. And my apologies, I couldn't come to India this time as well. It would have been nice to, but the world as it is. But thank you very much.
We'll find ways to get you to India, Paul. Thanks. Bye-bye.
Bye.
Yeah, thank you, Paul, and thank you, Vipul. So we move on to the next session on CTE and mathematics. And for that, we have Ritvik Kare, who's consultant at the Department of Social Welfare as the session chair.
Hello, everyone. I'm Ritvik Kare, working as a consultant in the Department of Social Welfare, Government of Andhra Pradesh. Now we're entering into the session 3, CTE and mathematics education. I know the sessions after post-lunch will be hectic, but I promise that we have a wonderful presenters here, 8 presenters, out of which 2 are presenting in live and the remaining 6 are presenting through virtual mode. Now we have Sparkle Madhav Granade from the Achievers School. Title is Impact of Implementation of Computational Thinking in Curriculum. Yes.
A very good afternoon to all. I am Swati Ranade. I thank the organizers CTiS for selecting my abstract and giving me the opportunity for presenting my views in front of you. I also thank the mentors for giving their valuable guidance in making my presentation. Let me take you through the slide. Yes. So the theme which I took was impact of CTE activities on student learning. The target group were students of class 4. They were 35 students. In the last academic year, I was working with the Achievers School, Baroda, Nagpur. This is a small school located in the rural areas of Nagpur district. Most of the teachers were not aware of CTE, but I, with my previous experience from Dr. Kalmari Shamrao High School, decided to implement the CTE in this school as well. So I was the only one doing it. Now this slide talks about the activity implementation. The topic which I chose was shapes and patterns. Now shapes and patterns are interrelated to each other. Patterns occur when shapes are repeated. This concept is very similar to the concept of looping. Looping is doing the same thing over and over in a particular order until a certain condition is met. The activity was introduced with the help of simple patterns like what comes next. You can see it in the first picture there. Then the degree of difficulty was increased by changing the condition. That is the second picture. At first, all patterns were introduced in a linear manner. Once, when the students were familiar with the linear patterns, the next step was to introduce cyclical or circular patterns. The circular patterns, like mandala art and rangoli drawings, were shown to understand the concept of circular patterns. Relating the topic to day-to-day examples, made it simple for the students to understand the concept of patterns better. These cyclical and circular patterns form the base to introduce the concept of tessellations. A tessellation is a pattern created with identical shapes which fit together with no gaps. The students understood the tessellations pattern and also designed one for their own. Now the variation part. As I mentioned earlier, the Achiever School is located in the rural areas of Nagpur. On the route to the school, there are many houses with mud walls. Some beautiful paintings with white colors are made on the walls. While traveling from the bus, the students happen to observe all these things. Taking inspiration from this, I introduced the traditional art form of Odisha, Jyoti Chitta, wherein the rice flour paste is used to decorate the houses. It is a form of rangoli which looks like mandala art but made using rice flour paste. The traditional form is made on the floor, but I asked the children to do it on a hard board. They had to draw the pattern first using a pencil and then carefully use a stick and rice flour paste. The children had to make the art form with precision and finesse. Now this is the students' work which they have done. Although prima facie, all the artworks looked similar, but there was a variation in each one of them. I started observing the variations using the lens of patterns learned in the class. Talking about variations, the basic shapes used while making the patterns and their placements are different. The thickness of the line while using the patterns, that varied because the children used, I had only mentioned stick. Some of them used broomsticks, some of them used matchsticks, some of them used ice cream sticks, and some of them even used the paintbrush. So the thickness of the lines, and some used a combination of these sticks. So these combination led to the variations in patterns and the overall appearance in the aesthetics of the art. Also the thickness of the lines which I mentioned, the color of the board which they used, the background, that also gave a very different effect. The complexity and intricacy of the pattern because of the use of finer sticks, it was intricate design could be made. Also, they could draw small patterns, like small shapes. And of course, the distance between different shapes to make the patterns. This also is the artwork wherein we can clearly see because of the use of different sticks, the thickness of each and every pattern is changing and we can clearly make it up. Now, of course, anything comes with a challenge. So it was a time of online schools and doing art online with children of 10 years of age was quite a task. Unlike in physical schools, I could not demonstrate the recipe or procedure of making the rice flour paste. For the art form to be proper and up to the mark, the consistency of the rice flour paste had to be right. If it was too watery, it wouldn't be fixed on the hardboard, or if it was too thick, they couldn't work with it. It was not workable. So the consistency had to be correct. Now, as teachers, this pandemic has truly taught us to face unprecedented changes with great courage and creativity. It has unlocked our brains to find solutions that are easy and doable in the interest of the students. To overcome this challenge, our friend measurement came to my rescue. The students had learned the concept of measurement in their previous years. I gave them the exact measurement of rice flour and water in terms of tablespoons to make the paste of the right consistency. Also, short video demonstration was made. Here I got the chance to introduce the concept of algorithm, because if you just mix both water and rice flour paste, sometimes it can become lumpy. So little by little they had to go on adding water and the paste so that they get to the right consistency. The recipe is nothing but a procedure to be followed step by step in the correct order. My challenge became a boon in disguise as I could introduce one more concept to the student, that is the concept of algorithm. Now talking about the impact, this activity created a solid impact on the students. In the words of Jeff Bezos, the human brain is an incredible pattern matching machine. The students started observing patterns in almost each and everything. They observed the patterns in leaves, flowers, patterns on a kitchen towel roll, patterns on their mother's sari, dupattas, patterns on the wrapping papers. The children also talked about the patterns in music, like the Sat Sur they learned during the music class. They also talked about the colors of rainbow which they see. The list was exhaustive. They also showed me some tessellation patterns in their house, like the tiles on the walls, tiles on the floor, and tessellation patterns on the carpet. As it was online class, children used to take the devices and run around the houses to show their discoveries, you can say. They could identify and tell the difference between a normal pattern and a tessellation. Like if somebody went wrong and if he said that, okay, this is a tessellation, before I correcting them, they corrected each other. No, it is not a tessellation. You just see on the floor, that is a tessellation. So the pure learning also happened. They learned multiple concepts in the same topic. They learned the importance of algorithm and the concept of loop. They also understood that the instruction should be precise, clear, and to the point so that they can reach the desired output each time. Based on the concepts learned in this class, the children could relate it with the other concepts in this other subjects too. They could correlate the concept of algorithm with the procedure they used in the science experiments. Because in the science experiments also, if you miss out on one step, you don't come to the desired output. So they could relate. Some even talked about the recipes which their mothers usually do, because they are 4th standard children. Many of them accompanied their mothers, especially while the mother was cooking. So they told that yes, sometimes if my sister tries this recipe, it doesn't come out to be the same. But when mother uses the same ingredients, it is the same. So they understood that the procedure has to be correct. They could relate the topic with their surroundings. They observed the mud houses near the school and compared the jyoti art with the drawings made on the mud walls. They could also contrast that the drawings made in jyoti art were on the floor and those made on the mud houses were on the wall. However, both were used for decoration purposes. Though the medium and place was different, the color and the purpose was the same. Here they could compare and contrast between two things. They could learn a new art form from a different state. With all the above examples and observations, I could conclude that the impact on the students in this activity promoted the computational thinking in the students and enhanced the students' learning. With this, I conclude my presentation with the quote by Richard Riley. Education should prepare young people for jobs that do not yet exist, using technologies that have not yet been invented to solve the problems of which we are not yet aware. Thank you. Thank you so much.
Thank you, Swati. So we appreciate your efforts in implementing computational curriculum because as a part of administration, I know how difficult and what it takes to implement curriculum. Computational curriculum. So next, you guys might be thinking why this guy from Department of Social Welfare is present in this conference. Just to say that a Department of Social Welfare in the government of Andhra Pradesh is running 191 institutions, which caters to the needs of 1,17,000 students from class 5 to class 12. So from our AP studies, we have 7 presenters
And my co-fellow Nitisha will be introducing all of them. So all of them are being, out of 7, 6 are being presenting from the virtual platform. I would like to request Nitisha to introduce them.
Yes. Good afternoon, everyone. I'm very happy to be here. We have our 10 of the AP Spheres teachers with us here virtually and one there presenting at Pune. So I would like to introduce the teachers and their presentations will be followed in the same order. So first is Prasanna from North Addanki School. Next presenters will be Karuna, Sundarama, Rajkumari from Mupala School. And the third presentation would be of Pallavi and Sureka from Baliparu School. And followed by Vijay Kiran's sir's presentation from Gahi's from Gannavaram School. And next we have Sridevi from Bapatla School. And the next presentation is going to be of Padmavati, Varalakshmi, and Deepti Sri. And all these will be presenting online while we have Satyanarayan sir from Draksharamam School presenting at the Pune ISIR Center. Thank you very much. I think now we can proceed with the presentations.
Good evening to all. This is VBVL Prasanna. I am working as TGT in Dr. B.R. Ambedkar Gurukulam North Addanki, Bapatla district, Andhra Pradesh. In my school, we have around 640 students, 21 teachers, and only 6 teachers are involved in CT. Only one period allotted for this CT per week. Our school working under APSWREI Society. This APSWREI Society running 177 residential institutions in Andhra Pradesh under the Department of Social Welfare, Government of Andhra Pradesh. The society institutions conducting residential education to SC, ST, BC communities from 5th class to intermediate classes. As part of support to enter professional courses, society conducting special coaching to the intermediate students for IIT, IEEE and MCET entrance examinations. The prime objective of the society is to provide quality residential education to the above targeted communities. Now, I would like to share my presentation with you all. I have submitted presentation on learning composite and prime numbers using CT skills. Now, coming to the activity implementation. I chose 2 activities. One activity is one of the traditional method of learning composite and prime numbers is through the Eratosthenes number chart. Here I upload photographs of Eratosthenes and number chart. In this chart, list all the numbers from 1 to 100, cross out 1 because it is neither prime nor composite. Next, encircle 2. Cross out all the other multiples of 2, that is 2, 4, 6, 8 and so on. Next, encircle 3 and do the same process. Similarly, continue the same process with 5, 7, 11, 13 and so on till all the numbers in the list are either encircled or crossed out. Then we say that all encircled numbers are prime numbers, remaining crossed out numbers are composite numbers except 1. Okay. In this activity, I got a challenge. That is, some of the students are not able to cross the numbers properly because of their confusion. In my thought, there is another activity for better understanding about these prime and composite numbers. Next, we are going to next slide. In my class, 40 students are there. Every student have their own roll numbers, 1, 2, 3, 4 and so on up to 40. Okay, 40. Now I start the activity. I told them, students tells your roll numbers, and then they told their roll numbers one by one, and then I told them write factors for your numbers, and they will write and come and read their factors. Students will come onto the desk who have two factors like 2, 3, 5, 7. I told them they are coming to the desk and they told, ma'am, my number is 1. Uh, so I am not either positive, either prime number nor composite number. And then number 2, ma'am, she told that, ma'am, my number is 2 and I have two factors only, that is a 1, 2. And similarly, number 3, number 5, number 7, and so on. So then I told them remaining numbers have more than 2 factors. In that factors also, one is a common factor. Okay, so who have these only two factors, they are all called as prime numbers. Prime number. And next, coming to the next slide. In this, I concluded to the students that whose numbers have two factors, that is 1 and self number, are called prime numbers. Remaining numbers are called composite numbers except 1, because of 1 is neither prime nor composite. Here I uploaded photographs, some photographs. They all the photographs are done by our students. Odd numbers, even numbers, prime numbers, and the factors of that number 12 they create they create as a flower. And then next coming to the next slide. Coming to the next slide, here I write a conclusion and also impact of the students. And the students participated actively in this activity because of they're enjoying very well about saying their roll numbers, of the factors of the roll numbers, and preparing the flower charts, and also they got better understanding. I think they got better understanding in prime and composite numbers. Here I used CT skills, like decomposition, algorithm, patterns. In the decomposition, breaking of the task to smaller parts instead of identifying prime and composite numbers from 1 to 100. Each student identifies if his own roll number is a prime or composite. And algorithms, in algorithms also following the step-by-step approach to finding the factors of the roll number. In the patterns, identifying the patterns to special or any observation in each student factors. In this activity, my experience is that it was very interesting task, and it is very useful to us to develop our computational thinking skills. I learned some interesting articles and gather useful information on this computational thinking. In real life situations also, CT is very important and very useful to us, and also to students. Thank you. Thank you for giving this great opportunity.
Good afternoon to all the delegates on the stage, and happy to meet all the teachers who are attending for the 4th conference of Computational Thinking at School 2022. This is NNV Lakshmari, P. Karuna, and T. Sundaramma from APSW School, Muppala, Krishna District, Andhra Pradesh. Our school is at Muppala, Krishna district, Andhra Pradesh, and about 2001 the school has started, and more than 2 lakh students have completed their studies here, and there are 30 teachers and 4 math teachers in the school, and we are using 21st century skills for problem solving. Now, it is a challenge for the students for understanding the concepts of mathematics, and teachers are different approach to make geometry interesting for the students. Now we are using geometry for explaining the concepts of mathematics, that is sum of interior angles of a triangle is 180 degrees. So objectives of activity. The objectives of activity is to develop skill of abstraction among the students. Engage the students in this activity using GeoGebra tool. Now we are using here GeoGebra tool for explaining the sum of interior angles of a triangle is 180 degrees. Now we are taking a triangle of different size. So students will take a triangle of their own and draw interior angles of a triangle in this. And we are taking now a triangle of ABC and marking 3 interior angles in 3 different colors for identification. So students will enjoy doing this project and can also understand in easy way the concept, that is sum of interior angles of a triangle is 180 degrees. Here we are taking 3 angles, and now we take a line segment and we take these 3 interior angles on a line segment, forming a semicircle. So already students are having previous knowledge of sum of interior angles of a triangle is 180 by forming a angle of semicircle is 180 degrees. So we are showing that the interior angles form a semicircle and angle in a semicircle is 180 degrees. So in this playway method, the student will easily understand the concept and can enjoy the studying and understanding the concept of mathematics. So now we are using your GeoGebra tool for making concepts easy. So the students will enjoy step-by-step activities with this help of GeoGebra. They found geometry interesting, so as the teacher will continue by effort to use this approach for further development of the abstraction among the students. So all these observations together used for the final conclusion of the statement. So thanking for you, a wonderful opportunity. Thank you very much. Thanking you.
Good afternoon to everyone. This is Sureka, math teacher of Dr. B.R. Ambedkar Gurukulam, Palaparthi. Good afternoon to everyone. This is Pallavi Sammangi, math teacher of Dr. B.R. Ambedkar Gurukulam, Palaparthi, Krishna district, located at Andhra Pradesh. In my school, around 600 students from 5th to 12th classes and 20 teachers working faculty. We are very happy to be a part of the 4th Conference on Computational Thinking in Schools 2022. Now, coming to my paper presentation, we have submitted the sum of the angles in a triangle is 180 degrees by playway method. Background of this paper: geometry is a compulsory subject in mathematics. Students are learning many problems in geometry. Recalling the correct statements in problem solving is a challenge to them. This paper talks about generalization, practical observation, and abstraction. The 7th class students learn sum of the angles in a triangle is 180 degrees for internal angle by Pleway method. Objectives of activity. The objectives of this activity is to develop skill of the abstraction among students, engaging the students in activity using geometry tool, verification of the theorem using geometry, recitation of observations of students, collection of all observations and forming a statement by students individually, generalizing the observation in the form of theorem statement, abstraction in problem solving. After completion, activity implication. Angle sum property is decomposed in small facts. Students following instructions step by step using algorithm, observe the facts practically, and written their observations in your notebooks. Observations help in generalization and forming the statements using proper geometrical language. After impact of the student, students learn computational thinking. Students decomposed the problem by considering the steps that can be following my instructions like draw triangles, their own measurements by using protractor. Considering the challenges, students abstracted their possibilities, then applied their conditional logic to the problem and analyzed the data collected. After repeated application of solutions, we conclude the statement. Finally, we frame the algorithm for successful implementation. First activity, take class of 40 students was taken as sample class for this activity. They instructed to follow the steps of activity using geometry and registered their observation in table form. So, teacher asking questions and student giving answers their own by observing the triangle. First of all, teacher asking question, draw a triangle of your choice. Students using ruler and different triangles are drawn. Teacher asking how many sides are there? Student observed 3 sides. Student give the answers. There are different types of triangles. Again, teacher asking one more question. How many angles are formed? Student asked different answers giving to the teacher. Finally, they measure the angles and find the sum of the angles 180 degrees. Student generalize the sum of the angles in a triangle is 180 degrees. So after all these steps, conclusion is made by the student. From all these observations, student declared the statement that the sum of angles in a triangle is 180 degrees. Thank you.
Separate research area.
Thank you, madam. Thank you. Thank you, madam. Thank you, Vananda. Thank you.
Good morning, all. My name is Vijay Karan Bathpuri. Today's my conference topic is about teaching computational thinking and probability using statistics package and two others. I am from Dr. B.R. Ambedkar Gurukulam for Boys, P. Gannavaram, Narendrapuram. Number of teachers involved in computational thinking is one, that is me, and number of periods per week is one, about 45 minutes. Next, we go on to the topic. And today, we used basic probability concept in computational thinking, that is flipping a coin. Before that, we go on to the importance of probability, in which is an effective mathematical tool, a widespread research area, and it is programmers are continuously trying to accomplish a full automatic system for the probability for real life applications under various circumstances. Though probability is very much important, the students and teachers are not obtaining the full experience of the theory because of lack of proper tools for exploring it. And for that, this paper has concentrated on bringing up some basic probability calculation, which is implemented in SPSS, FlipsMu, and GeoGebra, that is a simulation technique, which can be easily understood by everyone. In this activity, I selected a group of 20 students, 10 from each section A and B, 7th class, and they are calculating probability of head when a coin is tossed using simulation in SPSS, GeoGebra, and FlipsMu, and time taken is about 45 minutes. It is to develop skill in simulation using the predictive analysis of the students, means students can easily predict the futuristic analysis, futuristic outcomes in their daily life. That is a pragmatic oriented. In this, students engaged in activity of tossing a coin. Each student has given coin, and they toss a coin, that is flipped a coin, and note down the observations, whether heads or number of heads or number of tails. And these are results are put in simulation mode in FlipsMu, GeoGebra, and SPSS. And all the collection of observations are framed by student each individually, and these are compared with theoretical and expected frequencies. In FlipsMu, the obtained result is something like that. That is, number of heads is 45.52% and compared with tails 54.48%. Similarly, in the SPSS, we got the value of total flips, say 1018, 507 were heads and 511 for tails. And next we move on to the actual computational thinking concept, that is about decomposition, in which tossing of a coin for calculating probability of getting head in n flips, it is decomposed into finding the probability of getting head, find the probability of getting tail, and finding the expected probabilities, and last find the observed probabilities. These are all comes under the decomposition when a coin is tossed for n flips for finding head. Next, if we move on to the pattern recognition, in this concept, the students identified in a chart where after flipping and after noting the number of heads, they plotted the graph, which looks like this. Means some way patterns go down and some patterns got raised. And similarly, they draw the pattern which is on the right side, that is when a coin is tossed twice, coin is tossed first, that is once. Getting head and tail probabilities are 1/2. When coin is tossed twice, then the probability of getting head and tails remains same, but getting head and getting tail and tail is about 1/4 respectively. This is the pattern recognized by the students in the experiment. Next, we move on to the abstract concept, third, abstraction, in which we got the probability, we calculated the probability mass function, which are away from the students' knowledge. but out of interest, they started to draw the probability mass function, in which Bernoulli distribution and the Bernoulli trails comes under this abstraction point, in which basing on the Bernoulli distribution is calculated, in which the Bernoulli trail, any trail can be only two outcomes, which is success or failure. There is no another chance, another outcome. Therefore, P denotes success and Q denotes failure. In this, we have taken small case and uppercase. Small case is about the success, and the failure, in which P is equals to 1 minus P. Total outcomes, that is 1 minus success, that will be the calculation of failure. And in this algorithm, first step-by-step process, in which first one teacher I instructed what is the probability of getting ahead. The student answered that is half, this is 0.5. And similarly, what is the probability of getting tail means the answer is 0.5. Similarly, steps 3, 4, 5, 6, 7, and 7, they conclude that there is a difference between theoretical observation and expected observations with practical observations. That is theoretical versus practical. And they find out that the resultant probability of getting ahead when a coin is tossed 5 times is 0.4. When compared with tails, it is 0.6. They checked whether any relation between obtaining heads or tails. Yes, there is no relation, both are independent in nature. Tossing of both coins once or one coin twice, both are independent in nature. There is no relation. Next is use the simulation technique in a total class of 7th class A and B section, which are taken as sample for this activity. Students learn simulation of tossing a coin several times and find the probability of success and failure, where success equals to 1 and failure is equal to 0. And they put simulation for coin for n times. We got for 1000 flips. They are instructed to follow the steps for using SPSS, FlipSme, GeoGebra, and register the observations. FlipSme is available on online, and GeoGebra, well, online only. And SPS is a trial version, which is having a trial license for 130 days. Before vacation, we started, and after that, I didn't get any output. These are the three techniques they used and registered their observations. Those are the students who are using simulation technique for finding the number of heads and checking the probability of number of heads and number of tails, whether both are equals to half for 1000 and or simulations. If they find out that for the number of trails is increased to n times, then the probability of getting heads is equal to the probability of getting tails. Which they are also has a keen interest how to calculate the probability by bookish examples by approaching me, and they are keen to know the probability techniques, how we can apply from the sample space S, and how can they derive the probability of success and failure through expected outcomes when compared with practical outcomes. The students are very much encouraged. They enjoyed the step-by-step activity, and they explored the analytical tools as SPSS, FlipSme, and GeoGebra. They show an extreme interest in probability using those online tools. Hence, as a teacher, I will continue my efforts to use this simulation approach for further development of probability thinking among the students, which will develop the analytical skills. And thank you for watching my conference paper.
Myself, Sathuluri Sridevi, working as PGT Mathematics in Dr. B.R. Ambedkar Gurukulam, Vijaypuri South, Andhra Pradesh. Today, I am presenting
my topic in 4th Conference on Computational Thinking in Schools, which is scheduled 8th July 2022 to 9th July 2022. About my school. Dr. B.R. Ambedkar Gurukulam, Vijaypuri South, located at Palnadu district, Andhra Pradesh. The school started in the year 1992 and functioning under the control of Andhra Pradesh Social Welfare Residential Educational Institutions Society. Its aim to provide quality education to the poor children, most of whom belongs to backward community. More than 800 students are studying from 5th to 12th standard in my school. About 25 teachers are providing quality education to the students. Computational thinking. Computational thinking is a set of problem-solving methods that involve expressing problems and their solutions in ways that a computer could also execute. To the students at my school, it's an approach to tackling challenging questions and ambiguous puzzles. It improves clarity in students' thoughts as it gives a systematic approach in solving a problem. In performing the task by breaking it down, focusing on what it has and what is to be done to complete tasks using computational thinking. So, in education, computational thinking is a set of problem-solving methods that involves expressing problems and their solutions in ways automation process, but also using computing to explore, analyze and understand processes. The 4 cornerstones of computational thinking. First one, abstraction. Removing aspects of problem that are not needed for its solution. Second one, decomposition. Breaking a complex problem into smaller parts. Third one, pattern recognition. Looking for similarities among and within problems. Fourth one, algorithm. A plan, a set of step-by-step instructions to solve a problem. Geometry. Geometry is a branch of math that focuses on the measurement and relationship of lines, angles, surfaces, solids and points. The basic geometrical concepts are dependent on 3 basic concepts: point, line and plane. Why geometry is difficult? Proofs are a hot topic to get into and everyone struggles with it. Geometry is creative rather than analytical. Hence, statements are not understood by the students. Problem solving using theorem becomes difficult. For example, triangle inequality theorem. What are inequalities in geometry? A geometric inequality is an inequality involving various measures like angles, lengths, areas, etc. in geometry. Inequalities can be posed either as questions, much like equations, and solved by similar techniques, or as statements of fact in the form of theorems. Inequality in mathematics. A statement of an order, relationship, greater than or equal to, less than or equal to, between 2 numbers or algebraic expressions. Triangle inequality theorem. Triangle inequality theorem is that the sum of any 2 sides of a triangle is greater than or equal to the third side. Symbolically, we can show it as A plus B greater than or equal to C. Applications of triangles in real life. Architecture, strength in engineering, locating cell phones and or vehicles using satellites or tower triangulation, aiming an anti-aircraft gun at enemy planes, measuring surface areas in land cartography, adjusting eyesights for rifles, heading to a harbor while being at sea with a lighthouse as one corner of the triangle. Vectors in air navigation. Package design. Triangles are used to make rafters in buildings and curved domes. Some bridges have triangular structures and the Egyptians made triangular shaped pyramids. What is triangle inequality? The triangle inequality theorem says that in any triangle, the sum of any two sides must be greater than or equal to the third side. For example, consider the following triangle ABC. According to the triangle inequality theorem, AB plus BC must be greater than AC. AB plus AC must be greater than BC. BC plus AC must be greater than AB. How does triangle inequality work? An easy way to understand how the triangle inequality theorem works in any triangle ABC is imagine yourself walking along the sides of the triangle. If you have to go from A to B, for example, the shortest path will be segment AB. If you first go to C and then to B, the distance you cover, AC plus CB, will surely be greater than AB. Alternatively, let's try and understand the triangle inequality theorem through construction. Suppose that you are given three lengths x, y and z. You are asked to construct a triangle with these sides. Activity. Instructions given by teacher to the students. I have selected a group of 20 students from 9th class. 3 different lengths of sticks distributed to each student. Asked them to make a triangle with given sticks. Asked them to measure and record each side of the triangle in the given tabular form. In computational thinking, we have 4 steps. First one, abstraction. I have asked students to make a triangle from the given bundle of sticks. Then students tried to make a triangle from the given sticks. Some students able to make a triangle, some students not able to form a triangle. Second step, decomposition. I have asked the students to measure and check either the sum of the two sides is greater than the remaining side of the triangle or not. Then students measure the sides of the triangles and record in the given tabular form. Third step, pattern recognition. I have asked the students to find the sum of two sides and compare with third side of the triangle. Then students find out the sum and compared with the third side of the triangle. Fourth one, algorithm. I have asked the students what you have observed. Then students find that the sum of two sides is greater than the third side of the triangle. According to the instructions, the students measure the lengths of the sides and find the sum and compare to the lengths of the third side as shown in the tabular form. Conclusion. Computational thinking helps the students to understand the problem clearly. It allows students to take a complex problem, understand what the problem is, and develop possible solutions. Students can develop analytical and numerical skills. Computational thinking is a very useful problem-solving technique. For teacher, this activity-based learning is an effective tool to teach geometry. Students enjoy this activity-based learning just like game. Thank you all.
Good morning to everyone. I am very thankful to everyone for giving this wonderful opportunity. I am CTiS2022, working as TGT Mathematics teacher from APSWR School, Kumardevam at Kovuru, East Godavari District, AP. Teachers from this are CHVN Varalakshmi Madam, K Padmavati Madam, and next one me as CTiS2022. Number of students 620 members, grades 5th to 12th standard. Number of teachers are involved in CT, 3 mathematics teachers. I am going to explain about the topic area and perimeter of a square formula. Let us see how to find out area and perimeter of a square formula. Activity implementation. Students will observe the geometrical shape of a given figure and also find out the area and perimeter of a square formula. Challenges and variation. First of all, I draw the square shaped geometrical figure and each side of a square denoted by A. I asked students, what is the shape of the figure? The answer given by the students is square. Again, I asked a question each side of a square denoted by A. Answer given by them is each side of a square denoted by A. I asked them how to define area. They answered the space occupied by a square. Next, why is the area of a square a side square? They said that a square is a 2D figure in which all the sides are equal measure. Since all the sides are equal, the area would be length times width, which is equal to side into side. Finally, I asked them after all these observations how to define square formula. They said area of a square capital A equal to side into side equal to A into A square unit. I gave an example. If then side of a square is 5 centimeters, then the area of a square would be, the answer given by them is capital A equal to 5 into 5 equal to 25 centimeters square. Next, I asked them what is the perimeter of a square. The response from the students is the perimeter of a square is the sum of all the four sides of a square. Again, I asked questions here, what is the sum of all the four sides of a square? The response from them is a plus a plus a plus a equal to 4a. Hence, from the above observation, what is the perimeter formula of a square? The answer given by them, p equal to 4a. Next, I gave an example. If the side of a square is 4 centimeters, then find out the perimeter of a square. The answer given by the students is p equal to 4 into 4 equal to 16 centimeters. Okay. In this way, students can easily find out the area and perimeter formula for a square. Thank you to all for giving this golden opportunity.
Okay, now we have another presenter, S. Narayanamurthy from our Dr. B.R. Ambedkar Gurukulam, Draksharam. So he'll be presenting on making abstract algebra concrete using CT.
Good evening, everyone. I'm very glad to be in front of you to share my presentation. This is Narayanamurthy from Kakinada district of Andhra Pradesh. I'm a mathematics teacher in Andhra Pradesh Social Welfare Gurukulam, Draksharam. Our school is of 450 strength, and I and my colleague Arjun imparting the skills of computational thinking among the children from the last year. Well, my topic for the presentation is making. My topic for the presentation is making algebra abstract to concrete using CT, computational thinking skills. Now, the major hurdle for the children in learning mathematics is its abstraction. As teachers, we have to make these abstractions clear and make them think systematically to solve the problems. If this had happened, they start learning and enjoying learning mathematics. For this, how should our approach be? We should make them analyze the problem. When immediately after seeing the problem, they should grasp what was given and what is to be achieved and what will help them in achieving it. Right. Well, what is computational thinking skills, and in what way they'll help children learning. Let us look into it. Well, what is computational thinking? Computational thinking is the step-by-step process of performing a task, solving a problem, by breaking down into manageable steps, and using strategies like abstraction, decomposition, pattern recognition. We'll look at these definitions in few minutes later. Well, before that, where do we use these computational thinking skills? See, each time we perform a task by dividing it into further smaller tasks, and having observation what we are doing and what is going to be done and what will help us in doing that. When we do each time such kind of tasks, we are unknowingly using computational thinking skills. Let us explore this with a general example, and later we use these strategies, how they'll be involved in learning mathematics for the children. We'll discuss in the next slide. Yeah, let us take the example of making tea. See, when we have to prepare tea, all of a sudden it will not happen. See there, we'll take the tea bag and we'll pour hot water into the cup, and then we'll mix milk and water and stir well to make the tea ready, right? So the process of making tea is divided into several steps like this. So this is actually decomposition, right? And then we are smart enough not to take salt instead of sugar to make a tea, right? And moreover, we don't take kgs of sugar for preparing just a cup of tea, right? So whatever they are necessary and how much ever they are necessary, that is our next task, right? So this is abstraction. We should have a look into whatever necessary and how much ever whatever they are necessary, and we should rule out the unnecessaries, right? This is called abstraction. And then the whole process, one by one, step by one process of making tea, taking the tea bag and then pouring hot water and then mixing mixing milk and sugar and then stirring. This is algorithm. The task of performing one step after the other. This is called algorithm, right? Now, how does this help in children learning? How does this computational thinking skills help in children learning? So let us apply these strategies for deriving the algebraic identity a plus b whole square is equal to a square plus 2ab plus b square. Looking into each step, what strategy we have used, right? Let us go to the next step, please. Thank you. See, when we ask the children what does a plus b whole square means, he immediately answers a plus b into a plus b. See here, the quadratic is is divided into product of two linears. This is decomposition, right? Then after asking what do you do later, the student who has the idea of distributive property writes that like a plus b into a plus b into b. This is pattern recognition, because when he had the idea of distributive property, he applies the concept to write this a plus b into a plus b as a plus b into a plus a plus b into b. And he uses this abstraction to use distributive property again in the laws of exponents and addition of algebraic terms to get the product finally a plus b whole square is equal to a square plus 2ab plus b square. This step one by one performing is known as algorithm in arriving the identity, right? Now we switch on the same identity to prove in a geometric approach, because the children will easily learn when they see it naked eye. Okay, next step please. Thank you. See the same result whatever we proved earlier in algebraic approach, we prove that by geometric approach now. Now I asked the children to take a cardboard and label the side length as a plus b. I asked them to divide the whole square into 4 regions, having two of squares with side lengths A, B each, and the remaining 2 as rectangles. Now, the children will recognize that those 2 are squares and the rest of 2 of them are rectangles. And when one is of length A and other square is of length B, he could label the remaining portions of the whole figure. Now the whole figure is divided into 4 regions, which is in a way it is decomposition, and then he recognizes with his previous experience that those 2 are squares and the remaining 2 are rectangles, and he applies the formula of area of a square x into x, x square, to get these 2 as a square and b square, and the remaining rectangles ab each. And now he integrate with his abstraction. Upon adding these 4 will give you the total area of the square. So a plus b whole square must be equal to a square b square added to 2 ab's, and at last he arrives the identity a plus b whole square is equal to a square plus 2ab plus b square. Now, what impact this computational thinking skills will have on students? Let us see. This computational thinking guides the student in a step-by-step way. Student understand each step, and he'll know why this is happening in each step, which is very, very important in student learning, because that when he doesn't understand at any moment, he gets distracted from the class, and it becomes a phobia for him. So at every stage, he should realize, oh, okay, this is why this is happening like that. So this is very important. And then coming to the next point, the strategies that are used in computational thinking skills while solving the problem will enable to encounter new problem. This is an active student must be very ready to encounter new problems. See, decomposition makes him how he can break down the solution into smaller parts, and then pattern recognition will enable him to use his past experience to work him out, and then abstraction, not doing any mistakes and not getting out of the track, and at last performing all these tasks one after the other is the algorithm by which he can arrive the final result. And now that he understood the derivation of a plus b whole square, he tries to apply this idea for a minus b whole square, and then a plus b whole cube, in general for a plus b whole power n as a plus b whole power n minus 1 into a plus b. Thank you.
Thank you, S. Narayan sir, for showing us how to make abstract algebra complete using computational thinking. Yes, and as we have another 5 more minutes, I also would like to discuss with you all on how AP Sperry's have come up with computational thinking this long. So we have started this computational thinking in the year 2017-18 academic year with the help of CSpathshala through Naipunya Vikasam program. So Naipunya Vikasam program is one such a program which is initiated by the Department of Social Welfare, where it teaches life skills and English for students, and also for IT and CT for our students from class 5 to class 12. So we have hired some of the people like who are engineering graduates or graduates of MCA. So for us, it's never a difficulty to train those teachers to teach CT and all. But after 3 years, so we got a blow of, so we, for some undisclosed reasons, we have to stop that Naipunya Vikasam program. So then, even after that, we also have a pandemic. So all the CT classes have been stopped, all of a sudden. So now, going back, where our students are encouraged to do a lot of logical thinking in classrooms, now we have come to a point where our students have to again mug up for the things. So again, what we thought is like, again, we came back to the CSpathshala Sonia, and she told me that there is an Tamil Nadu's model made that integrating CSpathshala's curriculum into their regular teaching. So we have taken some of the core team members from our schools, like we have invited some of our senior faculties. So we said, if Tamil Nadu SCRT can integrate ACM's curriculum, why can't we integrate the same curriculum into your maths textbooks? They have taken 1 month of time, and they have integrated each and every chapter to ACM's CSpathshala's curriculum. And now they're asking us to have our TOTs. Our teachers are asking us to have TOTs to teach them, to give them many examples to teach in the class. Before that, before 1 year, when the same set of teachers were asked to volunteer themselves to teach the computational thinking by giving their extra period, they were unable to come because the government schools runs like they're rank oriented. They don't want to give their classes for other things except their syllabus or curriculum. So when this integration of syllabus into the regular math textbook came, our teachers coming up and asking to have a TOTs, because every teacher need a lot of examples to teach their students. And this computational thinking, when we integrated with the regular curriculum, it is giving them a lot of examples so that the teacher don't need to check other textbooks. They only can, they directly can get into this computational thinking and can give a lot of n number of examples for each student. And also they're coming with prerequisites and post-requisites in each chapter by giving different examples and different workshops. And yes, I also would like to thank Sonia, like officially from the Department of Social Welfare from Government of Andhra Pradesh. I would also like to thank Sonia and Vipul Shah for continuously hand-holding our teachers, because now you can see there are 87 abstracts that we have received from Andhra Pradesh alone out of in this conference. So that's a good number to say. And yes, I think we can conclude this session, and we are also on time. Now I would like to hand over this session. Before handing over this section, I would like to invite Madam Meenakshi to give up the certificates of appreciation. So first, I would like to call Swati Madhav Ranade. Next is Narayan. Thank you, ma'am. I'll be taking all the virtual presenters' certificates with me so that I can share it from my office. Yes, thank you. And from all the presenters from AP Squares, I would like to take this opportunity to thank everyone who are present here, and especially the CSpathshala and ACM India chapter for making this event a grand success. Thank you. Yes. Are there any questions? Yes, thank you. What was one?
Thank you, all the teachers who presented in person and online. So interestingly, I told a couple of people, but we are having a similar setup for Nagpur tribal welfare schools, and those teachers are having a residential conference just like us. So they are streaming online. So I just requested them to join us. So can them please. Yeah, so we have 78 teachers there. Okay, so it's very nice. I said all of you should know. And they are going to begin their journey of computational thinking. So we thought this was a very good way to start. So thank you to Mahesh sir and Ravindra sir for making this possible. Now we can all move outside, and the program will continue for the online participants, where they will see the recordings of what you did in the morning. So we have the demos again, and please do join us for tea. Thank you. And another thing, 6 o'clock we have to be back in the hall for Ram Krishnamurthy's talk. Yeah, thank you so much.
Sonia, is this, are we good to go?
Unmute the.
Sonia?
Yeah, can you hear me?
Yeah, are we good to start?
Start.
Okay. Welcome back to the third part of the TACT Grand Challenge. So after the first session online, we had in-person game sessions in the atrium at ISER. I'm sure those who were there really enjoyed the games. The games were then recorded by our volunteers from PCIT. A very big thank you to all of you for your support. Now that you've done the hard part of the work, all of us who joined online will sit back, relax, and enjoy the games. Before that, let me just give everyone a little background about what really happened in this challenge. So first of all, the support and response that we received for this session was enormous, considering that this is the first such challenge. The quality of submissions was highly commendable, given the very short time that was given to the applicants. The submissions came from various parts of India and several countries outside India. So we had about a dozen experts who double-blind reviewed the submissions, and 13 out of the 30 were selected for final presentations today. One presenter could not turn up for the final presentations due to personal challenges. And of the 12, you witnessed 3 games online this morning. And now you will witness the nine more. And the top 5 of these games, with fair weightage given to votes received for the games that you have witnessed, will receive prizes sponsored by Microsoft India. Quickly, I'll just tell you, go through what are the games. So we have a presentation from Aditi Iyer from the Center for Creative Learning, IIT Gandhinagar. The game is Reasoning with Punched Cards. And then we have Swati Dave from USA and Gauri Ramchandran from India, who have put together the game 5 Stones. And along with Ramya Nitharshini Balaji. She's from Netherlands. Then we have Jyoti Bisht and Meghna Chaudhary from Vision Empire with Connect. Then we have Gauri Joshi from Dr. Kalmadi Shamirao High School from Pune with Patterns with Textures. Then we have Khushbu Jain from Abhigya and Abhirami and Ambika from Srishti School of Art and Design and Technology, Bangalore, with their game Shout Out. Then we have Kavleen Kaur from Credo Learnings, Delhi, with the game Fire Rescue. Then we have Gauri Tushar from Azim Premji University with the game Grid the Sticks. Following that, we have Geeta Ghodmade from Meghe Group of Schools, Nagpur, with Patterns with Pentaminos. Then we have Devi Datta Ghosh and Rajeshwari Pandurangan from Vision Empire again with the game Market. Then we will wrap up this session. As and when you watch the games, please vote. The voting link will come up on your screen along with the game after the game. So you can score the participants. So welcome once again and hope you all will enjoy each and every session, game session, which will follow one after the other. Thank you. We are good to go.
यहाँ पे 26 कार्ड्स है जिसमें A to Z पूरा लिखा है, राइट? अब क्या होगा, इसको मैंने शफल कर दिया। इफ आई आस्क यू कि ठीक है शफल्ड है, इसको ऑर्डर में अरेंज करो, तो क्या करोगे? A ढूंढोगे, B ढूंढोगे, C ढूंढोगे, फिर उसको ऊपर ऊपर लाओगे, राइट? बट दिस विल टेक अ लॉट ऑफ टाइम, डू यू गेट इट? पहले A ढूंढा, A अभी तक मिला क्या?
नहीं, then
फिर A ढूंढोगे,
you have to search one by one for every
you have
letter.
to search one by one and then you have to put it in order. So a better way of doing it, to do it quickly, what we did here is we have punched holes here. Okay, now what I will do is मैं इस stick को लूँगी, I'll put it here in the first hole, pull the cards which come along and then place it in front. ठीक है? ऐसे ही मैंने सारे holes के लिए लगाए। 1, 2, 3, 4 and 5. So now अभी देखो क्या हो गया, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So सारे कार्ड सॉर्ट है। What did I do? I just मैंने सिर्फ होल में ये लगा के लकड़ी लगा के उसको बाहर खींच के सामने रखा। Now same thing, this was for 32 cards. अगर if I want the whole रामायण, so I had 52 episodes in रामायण, उसको मैंने इन कार्ड्स में लिख दिया। So these are 52 cards. Again, यहाँ पे if you see कि ये सीता हरण हो रहा है, ये रावण आ गया, अभी वो हरण भी नहीं हुआ, रावण भी आ गया, फिर यहाँ पे हनुमान भी मिल गया, राइट? इट हैज़ टू बी इन अ सीक्वेंस. सो एनी स्टोरी, एनीथिंग विच हैज़ अ सीक्वेंस कैन बी अरेंज्ड थ्रू दिस मेथड. सो यहाँ पे जो होल्स है, यहाँ 2 टाइप ऑफ होल्स है, एक गोल होल है एंड एक जो है ये सीधा वाला होल. सो दिस इज समथिंग जो हम बाइनरी काउंटिंग सब बोलते हैं ना, बेस्ड ऑन दैट. ये एक स्टोरी था. अगर 52 कार्ड्स आई पूरा करना है, पूरा वर्ण वाला लिखना है, तो उनको भी इन कार्ड्स में डाल सकते हो. सेम इसको शफल कर दो, होल से ऊपर राइट से चालू करो, लेफ्ट तक के जाओ एंड ऑल द कार्ड्स विल बी सॉर्टेड. नाउ अ क्वेश्चन इज, if I don't want so many holes, if I want to restrict it to let's say 4 holes or in this case 3 holes, I want to restrict my sorting to 3 holes. So what I do here is I have 2 different types of holes. So here if you see, यहाँ पे 3 अलग अलग होल्स है, एक पूरा बंद है, एक आधा बंद है एंड एक पूरा खुला. सो इसमें क्या होगा, इसमें आई हैव टू यूज 2 different type of pins. तो this is again shuffled. What I do is right से first I take the small pin and इसमें इसके अंदर डाल के इसको बाहर निकालते. Then I use the big stick and right. फिर when I do it, फिर all of them ये cards sort हो जाएंगे. So you can also try it. Now yes, one more question is, अगर मुझे 26 कार्ड चाहिए थे तो मुझे यहाँ पे 3 टाइप ऑफ होल्स में मेरा काम हो रहा था. अगर मुझे 52 कार्ड चाहिए रहते तो मुझे यहाँ कितने होल्स चाहिए? लाइक 3 अलग टाइप से मेरे पास, लेकिन हाउ मेनी प्लेसेस वुड आई नीड? सो दैट इज समथिंग व्हिच यू कैन थिंक.
ओके, फॉर 26 इट वाज 3
होल्स. 3 होल्स में काम हो जा रहा था. इन फैक्ट फॉर इफ आई हैव ओनली 2 different टाइप ऑफ होल्स, ठीक है, सो आई वुड हैव नीडेड हाउ मेनी होल्स टू पुट एवरीथिंग, पुट ऑल द डेटा हियर इन दिस.
ओके, इट विल डबल.
डबल मतलब
52 के लिए लाइक वी हैव currently have 2 types of holes.
Okay.
So it will be 4 types of holes.
Types of holes is only 2. That is ये पूरा गोल and ये पूरा सीधा. Right. So now you can think कि how many holes, 1 2 3 4 5 positions है ना, how many positions would I need for this? 52 cards.
It should double 10
Think.
positions.
Okay, think. Will I need 10 positions or will I need something else? So that is something which you can think.
Anyway, the positions will remain same, like number of positions will remain same.
Okay, think. Okay, I will not answer this for you now. So yeah, so for people with special gifts, like the people who can't see, for them what we did was ABCD को इसमें छेद कर दिया. So either you can have a hole here or you can engrave something on it so that they can actually feel it. They can feel the numbers as well here. So they can directly connect what is written here and what is the binary representation of that.
Extended. So our dear colleague Aditi went to her hometown और भाखरवड़ी लेके आई.
Okay.
And during the break, the भाखरवड़ी just gone missing. And there were 5 people in the lab, and we wanted to figure out भाखरवड़ी खाई किसने है. So there were 5 people, Manish, गौरव, सरिता, तापस एंड जय. दिस 5 पीपल वर देयर इन द लैब और हमें पता करना था कि खाई किसने है. तो वो जो सारी पॉसिबिलिटीज़ है, जैसे हमने पंच कार्ड में लिख दी. सो स्लिट मीन्स कि उन्होंने खाई है. सो जय, सरिता एंड गौरव ने खाई है अगर ये वाला कार्ड, दिस शोज द कार्ड शोज दैट पॉसिबिलिटी. और टोटल 32 पॉसिबिलिटीज़ है. 5 लोग हैं, या तो उन्होंने खाई होगी, नहीं खाई होगी. 32 पॉसिबिलिटीज़ है, सारी हमने ये कार्ड्स में पंच कर दी. एंड देन व्हाट वी वांटेड टू डू, एंड वी नो फ्यू थिंग्स. फॉर एन एग्जांपल कि अगर मनीष ने खाई है भाखरवड़ी तो सरिता ने भी खाई होगी. तो इसका मतलब हम क्या करेंगे कि वी वांटेड टू पिक अप अ कार्ड और वी वांटेड टू रिमूव रेदर सम ऑफ द पॉसिबिलिटीज कि अगर मनीष ने खाई है तो सरिता ने खाई होगी. तो कौन सी वाली पॉसिबिलिटी नहीं होगी कि मनीष ने खाई है बट सरिता ने नहीं खाई है. तो वो वाले कार्ड्स को हम यहाँ से निकाल दिए. सो वेरी फर्स्ट पोजिशन इज फॉर द मनीष. तो यहाँ पे मैं अगर डंडी घुसाता हूँ, सो इंसर्ट द स्टिक हियर. So then I wanted to remove some bunch of cards which will have the hole in the very first position. जिसका मतलब है ये कार्ड्स में मनीष ने नहीं खाया है. And my interested one is कि भाई जिसमें मनीष ने खाया हो और सरिता ने ना खाया हो. So सरिता's position here is on the middle. तो इन कार्ड्स को मैंने रिमूव किया. And these all cards shows the possibility जिसमें मनीष ने खाया है पर सरिता ने नहीं खाया. You can see all the cards कि M होगा 1 और सरिता का नाम मिसिंग होगा in all of these cards, which shows कि ये possibility नहीं हो सकती. And sequentially there are logical statements which we keep on removing the cards, and the one which will be remaining among the last, these are the possibilities. उन्होंने खाई होगी. तो अगर पता करना है आपके खाना कौन चुरा लेता है आपके किचन में से, do the punch card and do the logical reasoning. This is how we wanted to extend it. Thank you very much. So
5 stories is actually played along generations across the world. What we are trying to do is to bring this historical game into the classrooms to add some numbers to it and then try to see how this data can be analyzed. Many of us have played the game 5 times. The idea behind this game is the hand-eye coordination to succeed. But when we put the point system in this game, the study of data collection and analysis can be interesting. So, as I said earlier, this game is played across the world. It has different names, and then it has been played across the world. Yeah, and then how the game works is what we are going to talk about first. So we have 5 stones, the traditional 5 stones in hand, and then they are thrown on the flat surface, pick up 1 stone and then catch. As you see, the catching of this game is a hand-eye coordination which is required. But then once they finish one level, catching the stone one by one, they get a score. After finish their level, they get a score of 4 points. And then level 2 will be to catch 2 stones at the same time. I missed, so I didn't finish level 2. So, and then the level 3 will be catching 3 stones at the same time and so on. Once they finish each level, they get incremental scoring. So, level 1 gets 4 points, level 2 gets 8, and level 3 gets 12 and so on. In this way, once the data is collected, it is in the hands of the teacher or the educator to find out how or to see how this data can be interpreted in the classroom. So, the guiding questions can be, the basic guiding questions can go through ranking and arranging in the ascending order and descending order of the scores, but then it can also go to higher level math and statistical interpretation by getting the mean, median, and mode concept. To see how the data is represented, they can use the scorecard as a data representation, or they can actually build pictographs or use the same stones and beads to build a pictograph on the table in bench in fact like this. And then also give how each, what is the score for each shell or bead they are using as a pictographs. Once that is done, to level up the game, they can actually extend this to build their own model where the creative thinking is encouraged. Now, to build their own model, they can see how their data can be coming into picture, how they are going to collect the data with this new game which they are creating, not the one we have shown them. So, and that making the own data actually it increases the creativity and the thinking, logical reasoning thinking of how the data will be collected and how it will be analyzed. And key learning indicators we have here. Of course, we are thinking of math skills of how a data can be collected and interpreted. And what can be done to make predictions with, we can also make predictions based on the data. So instead of playing the game, if they have the data in hand, what are the predictions that come into picture? That's another indicator when it comes to math skills. But then it is also interdisciplinary, like when we discuss it's played across the world with different names, we are actually showing or putting the geographical skills. And also when we think of the different tactile materials used in the game, like the seeds or the beads or the stones, or if nothing is accessible in the classroom, they can actually use erasers to play the game. So once we put these materials in picture, the touch and feel is implemented. What is the next level we are proposing is to put a gungu in a cloth bag like this, and then the sound will enable the visually challenged kids to play the game. And other skills, of course, are the reflexes and the hand-eye coordination, which play an important role to play this game. Thank you. My name is Gauri Ramachandran. My other team members are Swati Ravi and Ravya Nitarshini Balaji. They are not present, so I am the only one present to demonstrate this game. Thank you.
That was 5 stones. I know the sound was
का
weird.
दूसरा साइड किसी और ने पकड़ा है, बट आपको भी पता नहीं है कि वो किसने पकड़ा है।
Connect.
क्या करने वाले हो आप इसको इस तरीके से हल्के से डालने वाले हो, ठीक है, ताकि सामने वाले को पता चले कि आप उससे पूछ रहे हो कि वो कौन है। तो आप पूछो, फिर आपको बोलना है कि कौन है वो, ठीक है। आपको अपना नाम बताना है, पुष्कर। तो आपका नाम प्रणव। प्रणव जो है वो पुष्कर से कनेक्टेड है ना। तो अगर मैं एक और आपको ना एक ही हाथ में सारी नोट्स एक हाथ में पकड़नी है, वरना ना थोड़ा कंफ्यूजिंग हो सकता है। ठीक है, आप थोड़ा सा दूर चले जाइए ताकि थोड़ा सीधे रहो। यस, ठीक है। अब अपना पुष्कर, हाँ पुष्कर, तो आप 2 लोगों से कनेक्टेड हो ना, आपके पास 2 रस्सी आएगी। आपको एक ही करके क्या करना है, आपको थोड़ा सा दूर हो सकते हो ताकि रस्सी काट पकड़ो। आपको ऐसे करके ये रस्सी खींचनी है, ये चेक करने के लिए कि आप किससे कनेक्टेड हो। तो आप पूछो फिर कौन है उधर, आपको कैसे पता चलेगा। तो जिसकी भी रस्सी हिल रही है आपको बताना होगा, ठीक है, कि आपका नाम क्या है। आप कह सकते हो कौन है। मेरा नाम प्रणव। एक साइड तो प्रणव है और दूसरी साइड कौन है, आप खींचिए रस्सी। शुभम। तो अगर प्रणव आप किससे कनेक्टेड हो आपको याद है, पुष्कर से ना। बट अगर आपको शुभम से कनेक्टेड होना होगा तो आप कैसे होगे, क्योंकि कोई डायरेक्ट कनेक्शन तो है नहीं। बट क्या हम कोई और रास्ता देख सकते हैं जिससे आप शुभम से कनेक्टेड हो जाओ। कैसे, पुष्कर से पहले कनेक्ट। हाँ, पहले आप, हाँ, तो पहले प्रणव जो है वो पुष्कर से कनेक्टेड होंगे और पुष्कर के थ्रू शुभम पे जाएंगे। 2 रास्ते पकड़ने के लिए एक गली नहीं जाएगी। जिसमें हमने सिर्फ 2 रस्सियाँ ले रखी हैं, अगर हम इसे और कॉम्प्लिकेटेड बनाना चाहेंगे तो हम इसमें और रस्सियाँ और
जो शुभम को दे दिया और दे दिया इसको, ये कौन है? राइट।
दोनों रस्सियां एक ही हाथ से पकड़ना
और
दूसरे हाथ से इसे हिलाना, ठीक है? अगर आपको चेक करना है
जिसकी भी रस्सी हिलती हुई दिखाई दी, अगर जो हमें पता चलता है तो वो उसका मतलब नाम पूछा जा रहा है, ठीक है? हाँ, अभी तुम्हें ऐसे पकड़ना है कि तुम्हें दोनों रस्सियाँ कौन सी हिल रही है वो पता चले। हाँ, मतलब तुम्हें इस तरीके से पकड़नी है कि तुम्हें कोई रस्सी हिला रहा है तो तुम्हें पता चलना चाहिए कोई रस्सी हिला रहा है, कोई रस्सी हिला रहा है, तुम्हें लग रहा है? हाँ, वेरी गुड। और अभी इसको भी और एक दे देते हैं, और ये ले पकड़, हाँ ये ले, हाँ पकड़, इसको भी दे देते, ये रह जाएगा। हम लोगों ने बहुत मुश्किल कर दिया गेम, देखते हैं तुम लोग। हम लोगों ने गेम पूरा मुश्किल कर दिया अभी तुम लोगों के लिए, बड़ा चैलेंज डाल दिया तो तुम लोगों के लिए, चैलेंज कर दिया तुम लोग। टाइट पकड़ो, टाइट। अभी तुम लोग एक चैलेंज कैसे हल करते हैं हमको देखना है। हाँ, अभी जो भी रस्सी हिलाएगा, जिसको रस्सी हिलते हुए पता चली, इसका मतलब भाई उसको सामने वाले को नाम बताना है। तुम्हारे पास भी दो रस्सी है ना, तुमको पता है दोनों तरफ कौन है? तुम्हें रस्सी हिलती हुई पता चल रही है, ऐसे पकड़ोगे तुम्हें पता चले कि तुम्हारी एक, कोई भी रस्सी हिले तो तुम्हें पता चले। हाँ,
अब सिचुएशन देते हैं। आपका नाम क्या है? श्लोक। अगर श्लोक को
पुष्कर,
हाँ, अगर श्लोक को पुष्कर से कनेक्ट होना होगा तो श्लोक आप कौन सा रास्ता लोगे?
बहुत सारे रास्ते हैं।
पूछ सकते हैं हिला के रस्सी, और आपको याद करना है कि इसमें उधर से रस्सी पकड़ी है और फिर वो किससे कनेक्टेड है, आपको थोड़ा सा याद रखना पड़ेगा। तो आप चेक करो आप किससे कनेक्टेड हो। आप ना दूसरे हाथ से इस रस्सी को इस तरीके से हिला सकते हो। कुणाल, तो आप कुणाल से कनेक्टेड है, आप कुणाल से पूछिए कि वो किससे है।
कुणाल तुम्हें पता है कौन कौन है?
अच्छा, आप ना दूसरा हाथ यूज करिए रस्सी पे से हिलाने के लिए, हाँ, वरना फिर थोड़ा कंफ्यूजिंग हो जाएगा। हाँ, पूछिए, बोलिए मुझसे कि कौन है? प्रणव। तो कुणाल, प्रणव और प्रणव किससे कनेक्टेड है तो पूछ सकते हैं।
प्रणव कुणाल कनेक्टेड। प्रणव किसको किस और दूसरा और दूसरी तरफ पूछो जी। हाँ, याद रखो कौन किसको कनेक्टेड है।
आपको कुछ पता चला कि आप कैसे प्रणव पुष्कर से कनेक्टेड थे? अच्छा, आप डायरेक्टली किससे कनेक्टेड है? ये कौन है? ये कुणाल। कुणाल किस से कनेक्टेड था? प्रणव से। प्रणव किससे कनेक्टेड है?
प्रणव किससे कनेक्टेड है?
सही तो बोला आपने। और किससे? हाँ, पुष्कर से। तो ये वाला रूट है जो आप लिख रहे हैं। तो पहले कुणाल, प्रणव और पुष्कर।
अभी ये भैया कौन है? अजिंक्य। अजिंक्य, तुम्हें जाना है पुष्कर तक, तुम कैसे पहुंचोगे? अरे वाह, क्या बात है। और अजिंक्य को श्लोक, अजिंक्य को श्लोक तक पहुंचने कैसे पहुंचोगे? शुभम से पुष्कर, पुष्कर से प्रणव, प्रणव से कुणाल। अरे क्या बात है, सबसे बड़ा चैलेंज था और तुमने हल किया हो, क्या बात है। आपकी एक्टिविटी टेस्ट हो गई।
थैंक यू।
फैंटास्टिक।
That was connect. Now we have patterns with next.
So my activity is to understand the concept of patterns. So you need to blindfold and you need to feel this different textures for this particular pattern, and you need to tell me at the end what will be coming next in the series. So say for example, swimming then two foods, you need to actually feel the way they are arranged, and you need to identify or recognize or predict what will be coming next in the series. So it is according to the level of difficulty. This one is really very easy. Then you can add the difficulty level by adding some complexity into the shape. The next activity is you need to hold this shape and tell me identify this shape, and you need to tell me the odd man out. Which of this is odd? Because these three are having same texture, the other is having not. So like this, you can tell from any of the shapes. So there are hexagon, triangles and circles. The next activity is I'll be giving you this triangle shape, and you need to arrange it in ascending order or descending order within 1 minute or 2 minutes. Yes, as per the shape, where you can actually fill in and tell me which is the biggest and which is the smallest. And the last part is the matching. So here is column A and column B. So you need to
Sonia, the video got paused.
recognize the shape, the texture inside, and match it to the shape which is on the next side, on the B side. So this helps in remembering the shape and also the texture associated with the shape. Thank you.
Hello, I am Gauri Joshi from Dr. Talmadi Shangrao High School, Ganesh Nagar, Pune. So hi, I'm Amrita, and this is my game Shout Out, and I did this with 3 other lovely members, Abhirami, Khushbu and Abhigya, who unfortunately couldn't be here today. So this game is called Shout Out, and we started by looking at play-based learning for visually impaired individuals, because we realized it was still a novice space and there was a lot to be explored in that space. So our game is inspired by the game genre of social deduction games. So games like Mafia, Killer or Among Us, these are all social deduction games. And so what social deduction games essentially are is where as a group you're trying to form team allegiance and you're trying to eliminate the bad person. So there's always like one bad person and like a few good people, and you're trying to eliminate the bad person. And why social deduction games? Because they involve skills like critical thinking, decision making, group communication, and as a group like you're assigning roles to each other. And we also included an element of arithmetic strategy into the game, because social deduction games are largely also based on visual cues. So for example, when we're playing Mafia or Killer, we're always looking at each other to see, who has a straight face, who's not smiling. So it's based on a lot of visual cues. And we want to take the genre as such and see how it could be made more inclusive. And so this is a game that you can engage with in mixed visual cues. So the game's called Shout Out, and to start off with, each of the characters are given character cards. So the 4 main characters are, you have the king, you have the queen, you have the soldier, and you have the pirate. So each of these cards, so all the elements in the game are also designed keeping in mind tactility and contrasting colors, and as well as there's basically different differentiating factors for people of mixed visual groups. So once you receive the character cards, you don't reveal your identity to the rest of the group. And so once all of you receive the cards, as a group you embark on 3 missions overall. So to go on the first mission, you pick the first mission card. So the mission card tells you how many players are required for this first mission. So this first mission requires 4 players to embark on the mission. So as a group, you decide who are the 4 people that will be going on this mission. So once you decide the 4 people, each of those 4 players receive these smaller tokens which are put inside the cards, and you don't reveal these numbers to any of your group either. So this is where the game starts. So once you receive your token numbers, what you do is you use these tiles, and each of these tiles represents one number. So this represents 1, this represents 5, and this represents 10. So using a combination of these tiles, you have to make a sum of, you have to reach the number which is on your token card essentially. So once you reach the number on your, so once all 4 people reach the number on their token card, you open up the initial mission card and there's a total sum inside it. So what you do is, so the sum is 60. As a group, you count the total sum on the board, and if the sum on the board is equal to the sum on the mission card, then the mission passes. But if the sum on the board is not equal to the sum on the mission card, then the mission fails. So if the first mission fails, then you know that there's a pirate amongst you, right? And when you go on the second mission, suppose I was suspicious of somebody in the group, I have to make sure that they don't embark on the second mission. But if they're the pirate, they have to lie and convince the group that they should embark on the mission and why they should do that. So that's where aspects of group communication and decision making comes in, right? So whoever wins 2 out of 3 missions wins the entire game. So if the pirate manages to fail 2 missions, then they win the game overall. But if the good people manage to pass 2 missions out of 3, then they win the game overall. So that's the game shout out. And so we started off by looking at the game for visually impaired individuals. But as we went on, we looked at how the game can be implemented in different parts of the system. So we looked at if it were to be included, say, in mainstream school settings or even in old age homes or sensitization centers, how would you tweak the rules a little and use the same elements? So to teach concepts of computational thinking like data or spatial understanding, for example, because the elements are so diverse, I'll give you a very simple example of how data and computational thinking can be taught using the same elements. For example, so students can be divided into smaller groups with like one facilitator, and they can be given just the tiles, for example. And using the tiles, students can be asked to engage in touching the tiles, what are they feeling, what are they seeing, and encouraged to note down this data in whatever way they feel fit. For example, they can note down this data using tally marks. And once they've noted down this data in whatever way they want, the teachers can ask probing questions like, why did you choose this form of data representation? And basically engage in class discussion. And so these are different ways that the elements can be used to teach different concepts of concepts. So yeah, that's it. Thank
Start.
Hello, good morning. I'm Kabir from Federal Learnings. I've come here with a game known as Fire Rescue. There is a fire in Federal Town which is this.
This is Fire Rescue.
It consists of a 6x6 grid where the buildings are there and some of the houses, these houses are on fire. We have the fire team available, but the challenge is for us to help the firemen reach the buildings on fire. Now there are multiple types of buildings. The houses can be on the ground floor, the houses can be single story, or the houses can be double story. Now how to create a path to reach the buildings on fire? We have 3 types of blocks to use to create the path. There are these 3 blocks. The first block is a bridge which can be placed here on the board to create a path. The second type of block is this 2-block ladder. The third is this 3-block ladder where we have these 2 squares and 1 ladder. Using these blocks, you can create various combinations to create a path for the firemen to reach the houses on fire. Now, like as all games, this one also has some rules. The fireman cannot jump up or jump down from the buildings or from these blocks. He can only walk on the bridges or on the ladders, or he can climb the ladder up, he can climb the ladder down.
Yeah, start.
So the name of the game is, and now you have grid the sticks.
Grid the sticks. As the name suggests, you need to grid the sticks. So before that, we will try to understand about the sticks. So this is the vertical stick, and I will make whosoever comes to play, make them feel that this is a vertical stick. This is a horizontal stick, and the important point over here is point of intersection. So this is a point of intersection when I keep one horizontal stick and one vertical stick. Now we are ready to play the game. So we have 2 dice over here. One is a bit larger and another is smaller. I need to roll them one by one. So the larger dice represents the number of vertical sticks I need to use. So as you can see, I have got 2. I will feel it and say that I need to use 2 vertical sticks. Then I will roll the smaller dice, which represents the number of horizontal sticks. So I have rolled it and I got 5 on it. So I will use 2 vertical sticks and 5 horizontal sticks to make our grid. So we will now start making the grid. So first we arrange 2 vertical sticks, then I arrange 5. The game has to be played blindfolded. So I have arranged 5. Now I'll ask the participant to predict the number of point of intersections, because now they know number of vertical sticks and horizontal sticks. Then after they have predicted, I'll ask them to count. So the counting needs to be done from left to right, row wise, so that you don't miss any point of intersection or recount anything. So after counting, I get 10 points of intersection. Then I'll ask the participant to share their observations. And I will further ask them, how did they predict the number of points of intersection? Do they feel, is there any relation between number of sticks used and the point of intersections you get? This way, they keep on giving answers, and after multiple trials, the participant will understand that the number of point of intersection is the product of number of vertical sticks used and horizontal sticks used. So as you can see over here, we have used 2 vertical sticks and 5 horizontal sticks. The product of 5 and 2 is 10. So we get 10 points of intersection. The challenge further to this game is that I ask you in which month you were born. Say you're born in July. July is the 7th month. So consider number 7. I want you to make all possible formations of the game where total number of points of intersection is 7. So you have to come up with all possible formations of game where the point of intersection is 7. So this way you will get 2 formations where you have 7 vertical sticks, 1 horizontal stick, that's 1 formation. Another formation is 1 vertical and 7 horizontal. So this way you can teach the commutative property of the multiplication, and further you can teach them about factors, multiples, and the concept of prime. Thank you.
Hello everybody, my game is patterns with polynomials. So polynomials are like different shapes formed by joining the blocks face to face, not to vertex. So for this I have used blocks. So visual impaired children can identify this the block touching them, right? So these are the faces, edges and vertices. So the game is to join the blocks together and form different polynomials. So 2 blocks at a time are called as dominoes, 3 at a time are called as triminos, 4 at a time tetramino, 5 at a time pentamino, and so on. Right? So for example, the first level, these 2 levels, making dominoes and making triminos, are simpler ones. So we are going from simple to complex. Okay. So the first step is join them each other, right? Do as many possibilities as you can. Then eliminate the shapes which overlap each other, and then declare how many are possible. So how many dominoes are possible? So for dominoes we have to use 2 at a time. For triminos we have to use 3 at a time. So here there is more complex. So after 4,
This is what we call as market game. That's market. So market is a concept which we all are familiar with, and it's a simple process of buying and selling. But how can we make it like a game? How do we play it like a game? This is what I'm going to talk about. So initially what we do is we orient children, we set up stalls, and then we put different items in each stall, and then we orient children about what are the things in the market. Now, also, one important aspect of market is money, as we know. So we use play money, and these shape cutouts are very useful for making play money. So this play money of different shapes you can cut, triangle, square, rectangle, anything, and circles, and then you can put some denomination for it. Say 2 rupees, 3 rupees, or 5 rupees, 2 rupees, 5 rupees, ho gaya, 10 rupees, 100 rupees, depending on the level of children. You can just put some value for this money. And then we divide children into different groups. So in session 2, what we do is we divide children into groups as customers and shopkeepers, and there is a simple buying and selling process which goes on. So children go buy and they come and tell that how much they bought, what is the total that they spent, and shopkeepers on the other hand, they say that how much they earned. I can continue. So in session 3, we give them some conditions like, say, you can take only 50 rupees or 51 rupees or 54 rupees and go to the market and spend only that much amount and see what did you buy. Whether you bought 2 items or 5 items, it's your choice, but you have to spend only this much money. That involves a lot of thinking, which children will have to come up with. And then in session 4, again we change the condition. Now here the condition is like, we give them a situation, say it's your birthday and you want to invite 5 of your friends and you want to buy things. Make a list of those items that you want to buy. Estimate how much money do you need to take to the market. So you make an estimation, take that much of money and go and buy those items and find out whether your estimation was correct or not. So that way, actually this game is very flexible and you can change the rules according to your wish or according to how children want to play, and you can go about playing this game. Thank you. I hope it is okay.
So that was market. I think there are 3 more games. No, was that the last one? Yeah, I think the last 3 games you have already witnessed in the morning. So I think that was the last game. So I hope all of you got a chance to understand. I know there was a lot of disturbance during the recording because these were face-to-face presentations there with so much crowd. But I hope you got the essence of it. Some of the videos I could not probably be recorded in entirety. But I'm sure everybody enjoyed whatever they saw, and I hope it was enough for you to understand the essence of the game, what was the learning in the game, and accordingly, I hope you have all voted, and if you have not, please go ahead. The link was shared after each. If you have not got the QR code, I think it was on the chat also. Did you? Okay, let me put that on the chat. Just give me a second. Yeah, I have to just get the QR code out. Sonia, are you there? Can you put the QR code there? Just let me check if I can.
Hello, Supriya, am I audible?
Yes.
No, you need to put the link to the Google form in the thing because you can't.
Yeah. That QR code, if you scan, you'll get it. But I'm putting the link. Just give me a second. Yeah.
Yeah.
Yeah, I've just put the URL on the chat. Please let me know if you can access it, and you can put in your scores for all the games that you saw. This is as much as hybrid allows, unfortunately. Yeah. So the people who attended the games there obviously enjoyed playing the game and experiencing the game. But for us, those of us unfortunately who could not go there and play the games in person, this is as much as could be arranged. But I think this itself was arranged by Sonia yesterday evening, and I think we're really thankful that she could do this. So yeah, I hope all of you will vote. And I think based on your votes and the jury's recommendations and scores, 5 winners will be announced tomorrow. Sonia, are you there? Do you want to this session to continue for some more time, or should we wrap it up?
We wrap it up, Supriya. We come back at 6 p.m. for the
Sure.
invited speaker.
Yeah. So thank you so much. Thank you everybody for joining online. Thank you, CSpathshala and the ACM India for CTI and entire CTiS organizing community for the TAC Grand Challenge. Dr. Manohar, would you like to say something?
Thanks to everyone for organizing this and for everyone for their enthusiastic participation. Thank you all very much.
Thank you everybody. Yeah. Bye then.
They're right there. No. Hi, is anybody here who can help me test things out?
Yeah, hi Sriram.
Hello.
This is Sonia here.
Oh, hey, Sonia. Nice to talk to you.
Where do you want to go?
I was hoping I could just test out my.
Yes, please test. 1 second.
Okay.
Where should I look? Here. Okay. Hi, can you see me?
Yes, I can. Can you see
Okay,
me? I don't know
great.
if you can.
Yes, I can.
Wonderful. Okay.
Yeah.
So what I'm going to do, I actually have a slightly complicated screen setup. So it'll just take me one moment.
It's just ये share screen हटा दो.
So let me just do this. Okay. So I'm going to share screen. So let me first make sure I can share screen. And I want to have this projecting. Yes, so that's not projecting.
Hello. Yeah.
And
Sriram,
so
I'm
I'm going
going.
to screen share this screen.
Sriram is there. Yeah. You're just testing his screen share.
How does that look to you? Do you see my title slide?
We'll be using the other mic, other camera, the audience camera, not the podium one, right? You don't need the camera this one, right?
Right now we do. Just you wait till we are talking to him, no? No. No, let it be on.
Let it be.
Yeah, let it be on.
So, just switch the camera off.
Audience camera. Sriram, is it okay?
Well, I don't know. Can you see my title slide?
Yes, we can see it.
Okay. I want to now. The thing is, I'm going to switch between that and something else during the talk. So I just want to test the switch. Okay.
Yeah.
So I'm going to do a new share. And I'm going to show this. Okay, so now you should see a browser window with like a big purplish background of some sort. Okay, great. And now if I switch back to my slides, now you should see my title slide again.
Yes.
Okay, and if I go here and you can see my slide advancing and going back.
Yeah.
Okay, perfect. I think we're all set then.
Yeah, it's good.
Sorry, somebody just said something.
No, that's picking up background now. No,
Okay.
Asking to move the slide. I didn't see. Oh, you want to see the slide advancing? Yeah. Can you?
Okay, I just did that and I did that back.
Yeah. Okay. Yeah.
You saw it, right?
Yes, we did.
Thank you.
Yeah.
I don't know if you can see me like waving or anything like that.
Yes, we can see you waving.
Okay, great. Wonderful. Okay. Thank you. Thanks for all the organizing work. This is wonderful.
Yeah. We'll just wait for Venkatesh Raman also to join.
No problem. No problem. Yeah. Okay, I'll just leave this up and I'll mute myself and then we can do whatever we want later on. Yeah. Thank you.
Hi, Shreya.
Good morning, good evening, Venkatesh. I see you're on now.
Yeah, can you hear me?
I can hear you wonderfully. Thank you.
Okay. I said hi before. I was wondering.
Sorry, I had my headphones off.
Okay,
Sorry about that. Yeah.
Yeah. Thanks for joining so early for you.
Oh yeah, no. This is great. I'm glad you were able to make accommodate my timing. You know, it's some ways these 12-hour changes, these big changes are almost easier than. I actually have a PhD student who's from Taiwan, and he's spent the past month in Taiwan, and in a way, it's actually very easy because they're perfectly 12 hours. So my morning is his evening, so we could meet, even twice a day. So,
what time is it now?
For me, it's now 8:15 in the morning. So it's really not.
Yeah. Not so bad.
No, it's fine. It's fine. Okay, I'm gonna just mess with my screen stuff a little bit, but I'll tell you what. I will take my headphones out. So if you say something, I'll be able to hear you, but otherwise, and I can plug that in when we're ready to speak, so we'll get slightly better audio. And we don't start for another 15 minutes, right? The actual talk starts in about 15 minutes, 14 minutes. Sorry, I don't think I can hear you suddenly. Let me.
Yes, you have 15 minutes.
Okay, good. Thank you.
I was muted. Yeah.
No, sorry. And you're at the Math Institute in Chennai, is that right?
Correct. Yeah.
Good.
Yeah, I'm going to be back in 2 minutes.
Take your time. I'll put my mute on when I'm not around, when I'm not listening.
Yeah, welcome back to the next invited talk of CTiS 2022. We'll begin in about 2 to 3 minutes. Sriram, hearty welcome on behalf of CTiS participants to this talk. Thanks for joining in. I hope you can hear us. Yeah, okay. Venkatesh, I hope you can hear us too.
Yeah, I can.
Yeah, so we're sort of stretching the limits of hybrid working here. Both the session chair and the speaker are online, and part of the audience is online, and the rest is here in person in the classroom. They will very soon activate the camera where you can see the audience. Online audience will slowly start trickling in. So we will begin in about 3-4 minutes. Yeah, thank you.
I'm going to take my slides off for a moment. I'll be back. I'll put them back on in a moment.
Yeah, sure. Yeah, while we're waiting for audience to trickle in Pune, I would also like to bring to your attention, Venkatesh and Sriram, that you'll see a few other classrooms. They are teachers from tribal welfare schools in Nagpur, and they are literally watching this whole conference replicated as a training for them online. So those are the other 2 classrooms that you see. Hearty welcome to all of them too.
Venkatesh, can you please confirm that you see my title slide again?
Yes, we can.
Wonderful. Thank you. I'll be back in 30 seconds.
Yeah. So Meenakshi, let me know whenever we can start.
Welcome to the second session. So I request Professor Venkatesh Raman sir to continue the session.
Thank you. Thanks the organizers for making all this virtual people joining at various virtual locations. It's also, just tiny bit early for Sriram and a bit shade late for the Indian audience. And I think it's sort of as much stretch as it can be as a hybrid model. So it's a pleasure to welcome
Am I the only one who can't hear him?
Sorry. Okay.
Sorry. There we go. Yeah.
Okay. Yeah. So it's a pleasure to welcome Sriram, who is a professor in computer science at Brown University in the US. His expertise is in programming languages, software engineering, formal methods, networking, and so on. He's contributed to several software systems, but since 2016, he has been devoting a lot of energy and time in computing education research, as he calls it. And he has been doing computing outreach for more than 20 years now, almost 20 years now. And he has won 6 Soft's Influential Educator Award, among many other awards. And he leads one of the largest outreach program called Bootstrap, which is an international outreach program to integrate computing into non-CS areas, in particular math, physics, social studies, and other disciplines, which is what brings him to this audience. So we look forward to hearing him. Over to Sriram.
Thank you so much. So first, I want to confirm that people can hear me. If you can just raise your hands and wave, those of you who have cameras on. Okay, I see one or two of the remote rooms are not waving their hand. I don't know if the Nagpur people and Vanmati people can hear me. Can you hear me? Can you just raise your hand and wave a little bit, please? Okay, I see some hands up. Okay, very good. Okay, thank you. If there's at any point, any audio problems or something, just wave, and one of us, either I will notice, and if not, I don't, Venkatesh will notice and jump in and tell me to fix something. Okay, so thank you everybody for coming. This is a tremendous organizational effort. Doing this sort of hybrid thing is extremely hard. And thanks for staying up late to listen to me. My name is Sriram. Venkatesh already told you a great deal about me. A little bit I'll just add. I'm physically located here in Providence, Rhode Island. Providence, for those of you who don't know, you've heard of New York and Boston, I'm sure. And we're basically between New York and Boston on the east coast of the United States, very close to Boston, a short train ride away. So if you're ever in the Boston area and want to come down and visit, please do. But of course, I'm not from Providence. Where I really am is from Bangalore. So it's a delight to talk to people who are in Bangalore or from Bangalore or Bengaluru, however you prefer to call it. And so this is really home for me. Lalbagh is sort of where I spent a good chunk of my youth. So it's just nice to be back with an Indian audience. I am during this talk, and I didn't fully appreciate the hybrid format, but we'll try to figure this out. During the talk, I will have a few audience participation questions. So if I have this up, that means there's going to be an audience question. What I normally do when I do these things on Zoom is we use the following protocol, which is you type your answer into the Zoom chat, but you don't hit enter. Okay. So because once one person answers, other people start going quiet, and I want as many people as possible to answer. So what we'll do is, for those of you who are on Zoom, you type your answer, but don't hit enter. Right? When I tell you to hit enter, then you hit enter, and then I can see all of your answers. Now, similarly, for the people who are in the live audience, you don't have Zoom available, and that's okay. Again, think of your answer, get ready, and when I say go, the people on Zoom will hit enter, and the people who are in the live audience will just yell out their answer, and we'll do the best we can. Does that sound? We'll give that a try. We'll see how that works. Okay, so here's your first question for the audience. Okay, do you understand the format? So type the answer, but don't hit enter. Think of the answer. Don't say anything. Okay, go. Hit enter.
Yes.
Okay, wonderful. See? Okay, good. All of you get it. Good. I'm expecting I guess I thought there'd be a few more people on Zoom maybe, but if not, if most of the people are live, that's even better. So then I can just hear you yelling out, and that's fantastic. Okay, so next question I want to ask is, what are the main subjects you teach? So take a moment type in the answer. And those of you who are live, you know the answer already. So, okay, go. I want to hear some answers now. Okay, so
Numeracy, literacy, CT.
Okay, good. Other answers? Few more. Just yell out a subject. I want to hear more people yelling. Okay, very good. Perfect. Okay, so then I have one more question for you, which is for those of you who are doing some sort of computational thinking work, what programming tools do you use? Okay, so again, take a moment, give the Zoom people a chance to type in an answer. Okay, and okay, if you're on Zoom, you can hit enter. If you're live, just yell out the answer. I see a scratch. Okay, so I'm mostly hearing Scratch and Python as answers. Okay, very good. Okay, good. So with that background, which is good because this basically helps me confirm that the audience is roughly what I was expecting. That's very good. What I want to do now is I want to switch to the theme of this conference, right? The whole theme of the conference is computational thinking. And this is, of course, the famous paper by Jeanette Wing. I assume everybody can read what's on the slide. If you have any trouble, can you just wave your hand showing me that you can read what's on the slide? Okay, good. So the audiences can, okay, wonderful. So you can all see the slide, right? So this is this very famous paper by Jeanette Wing that introduced this term of computational thinking. And, you know, she talks about this, right? She says it's a universally applicable attitude and skill set that everyone would be eager to learn and use. It's not just for computer scientists. And critically, she says everyone, everywhere will be a reality. It's integral to human endeavors, disappears as an explicit philosophy. Okay, so I have one more question for you. Right? So this is, again, another phrase from the paper where she says computational thinking involves solving problems, designing systems, understanding human behavior, etc., by drawing on the concepts fundamental to computer science. Right? So the whole argument here is we have these fundamental ideas in computer science, and these ideas help us understand everything about the world, even about people and so on. Okay, so that is the premise. That is the whole basis of this conference. So here is my question for you. And I want you to take a minute, and I literally mean a minute, to think about it or to type in your answer. But again, don't hit enter. Let's wait for a moment before you hit enter. Okay. And so here is the question for you, right? Because this is the whole point of the conference. Okay? Name 3 to 5 kinds of computational thinking that you practice daily. Okay? That's the question. And I'm going to give you a minute. Okay, so that's enough time for people to have typed at least a little bit into Zoom. So if you're in Zoom, go ahead and hit enter. And if you're in the live audience, yell out your answers.
Here are 6.
So I'm not hearing as many answers here. Okay, so I don't know whether this is because of our interaction mode or whether the answer is actually, we don't actually practice that much computational thinking in daily life, right? Most of us don't actually do this. And there's some question here about about a whole subject where we tell other people that this is what they should be doing, but we don't necessarily practice it ourselves, right? Something to think about. It's not a debate I want to get into here. I'm just going to sort of express that I have some skepticism. In fact, I have a research-driven, a very deep research-driven skepticism about the whole idea of computational thinking. I'm not going to talk about that during this talk, where I can discuss that later on during Q&A if you'd like to. Okay, but what I want to do instead is I want to talk a little bit about the subject here, which is computer science, and talk about what's happening to computer science itself. Okay, so here are 2 major trends that are happening in computer science. Okay, and in particular, when I say computer science here, I'm talking about the kinds of computer science that people teach in schools. You know, you teach students like app development, how to build some things in Scratch, et cetera, right? You teach students like for loops and while loops and things like that. And I want to talk about a major trend that is happening. Okay, so the trend is that computer science is shrinking. And what do I mean by this? So here is this big edifice of computer science. And many of the things that we have been teaching our students to do explicitly by hand over the past decade, there's a huge amount of pressure from above where a variety of artificial intelligence-based systems are increasingly starting to automate what we used to do by hand. And what we used to teach by hand, teach people to do by hand, computers are starting to do. We see the story over and over, right? We used to write assembly code by hand. We invented compilers for that. We used to optimize code by hand. We invented optimizers for that. We used to solve combinatorial optimization problems by hand. We invented solvers for that. We used to solve SAT questions by hand. We invented SAT solvers for that. And the same way, all sorts of things that we do in programming that we've traditionally taught are now being done by AI-based systems. Okay, so there's one sort of pressure that's coming in where a bunch of the things that we're teaching start to feel like they're becoming obsolete. Right? Now, on the flip side, there's also what I would call sort of pressure from below. There are these increasingly low code and no code and systems like that essentially automate the creation of simple computing programming tasks. Again, a bunch of the things that we think is really important for us to teach, for our students to be able to do, various app development kinds of activities. We now have systems where people with no programming experience can go on a website, click a few buttons, and actually get a better program than we would have written by hand. One that automatically adjusts to different platforms, that deals with various system differences and so on. And this stuff is completely routine, right? And people with very little to no technical education or programming are able to use these systems because that's what they're designed to do. Okay, so you'd start to now ask, okay, so how does this relate to other things? Now, of course, we've seen this kind of argument before, right? This is similar to the argument that we've seen in math education about calculators. So both these AI systems and these sort of low-code systems are a little bit like calculators in arithmetic, right? There's some very routine task and automation can take care of the task for us. But we still have an argument for why we should teach arithmetic in schools and not just delegate everything to calculators. And I think it's useful to examine those arguments in a programming context, right? One argument is that arithmetic is a timeless human skill, right? It's been with us forever. It's been with us thousands of years. It's not about to go away. But I think it's easy to argue that most of the details we teach in school computing really are not timeless skills, right? A lot of these are extremely minute, low-level skills that are very specific to platforms. They don't even last 5 years, much less lasting for thousands of years. Now, sometimes we have to do arithmetic where there isn't a calculator, right? We're out in the open. Again, computing, programming is not a thing we need to do out in the open. We don't need to do it on leaves and on trees. It's a thing that we do with computers, with systems around, right? And finally, doing arithmetic is something that actually helps us assess information. If I read a newspaper and there's some statement in there, some claim about, carbon dioxide or about the economy or population or something like that, being able to quickly do arithmetic helps us actually make sense out of that information and even question, is this information valid? Is this fake news, right? Do you honestly think, this is a question for every educator in the room to think about, and I'm not saying there's a right or wrong answer here for what you do, but the question you need to ask yourself is the computing you're teaching actually achieving the same thing? And I would argue that a lot of the things we do in school computing does not actually achieve that. But this is going to be a theme that I'm going to come back to later in the rest of this talk. Okay, so on the one hand, we have these systems that are automating away. We have the equivalent of calculators, and even the arguments for calculators don't quite make sense in computing education. So we have to be rethinking what we're teaching, especially if we think we're teaching skills. Those skills may already be obsolete, if not going to become obsolete very soon. Okay, now, the funny thing is I'm going to tell you the other trend, which is that computer science is expanding. It's expanding in all sorts of fascinating ways. Okay. So I have another audience participation question for you. So again, you all know the rules now. You type into chat and wait for a moment. You think about the answer live. And then when I say enter, you either yell out the answer or you hit enter on the keyboard. Okay. So this is a very simple question, no trick question here. Okay. Which companies remind you of computer science? When I say computer science, what company names come to mind? Okay. Just think for about 10 seconds. It's a word association task. Okay, at least for the fast typist, that's enough time. So go ahead and enter and yell out, please, so I can hear you. Okay. one.
Yes, ma'am. I think.
Terrific. Okay, so I'm seeing a whole bunch of things in chat. I also heard a bunch of you. I heard people mention like TCS, Infosys, and Google, and places like that. So I think that seems to be the bulk of the answers. There may have been some outliers. I'm sorry if I missed your answer, but that's sort of the bulk of the answers, right? And certainly true how I would think about it as well, right? But of course, what's happening in the world is that there's computer science, and then there is this entire world of computing uses, right? And maybe like a better picture for this is really more, you know, something like this, right? Something like this, right? So we have an iceberg and we have sort of computer science sitting up there. And then we have all these companies that you yourself named, right? So you mentioned Google and Microsoft and IBM and Infosys and TCS and so on, right? So those are sort of the computer science companies we think about. But then there is this entire world of computing uses, and there are thousands, I mean, millions of companies that now use computing in various ways, okay? So all these companies are doing things in computer science, and they all have need for computer scientists. They all have need for the kinds of skills we talk about. And in some sense, like every one of these companies is now a computer science company, whether they like it or not. Just like every company is using electricity, every computing company is using, like, you know, basic infrastructural resources. They're all starting to use computing as well. Okay, so there's a million different sectors, and I've just listed a few, you know, finance and pharma and things like that. But what's interesting is even these computer science companies actually are down here, because if you think about what a consulting company does, they are consulting for some use that is sitting in some domain, and therefore their consultants have to pick up some sort of knowledge. To be most effective, they have to work within some domain, right? And even if you take like the purest computer science companies, you know, like a Google or a Microsoft or something like that, well, you know, what do? They do things like, you know, Google Maps that requires you to know various things about GIS. If you do Google Earth, you need to know about geology, right? And all of these tools that they build and all these services that they build also interact with the world and also have all sorts of computing uses, right? So in some sense, like everybody is a computer science company to a varying extent now, and some of them just don't know it. You know, about 10 years ago, I was trying very hard to engage. I was doing some research on app stores, and I was trying very hard to engage with automobile manufacturers in Detroit, you know, the sort of the older automobile manufacturers, you know, like whatever, GM and so on. And it was very difficult to get to talk to them because they were like, you know, I was doing security research, like, we don't have computers, we don't have an app store, we don't have any security problems, we have nothing to talk about. Now, of course, all of them have a console in their computer, in their car, right? And certainly, you know, sort of, and you know, this is increasingly true in India as well, right? The cars now have a console, the console has apps, and you can install things, you can run things and whatnot. And now they're all in the computer business as well, right? So their cars, you know, cars are basically computers with like a motor to run the wheels, right? And so this is why there have been some very influential articles in places like, you know, Wall Street Journal, Economist, and so on. And basically they make these strong statements like software is eating the world, the oil is more, you know, data is more, you know, these are all provocative statements. You can agree or not agree with them. But the basic premise is still important, right? Computing is a deeply applied discipline, and most of what we do in computing is actually applied. It's not basic computer science. So if we're thinking about ideas like computational thinking and computing education, we really should be thinking about where computing lives, right? So what I'm basically saying is this: computing, there's all these other disciplines, and until now, what I've talked about is that computing contributes to the practice, the way we actually do this discipline. But what we actually need to understand is there's something deeper going on here, which is that perhaps if we do this well, computing can also enhance the learning of these other disciplines, okay? The way we learn these subjects can and should change and is already changing. Okay, so if I now take the same picture and look at it from the perspective of subjects, you know, math or maths, whatever you prefer to call it, physics, social studies, and all these subjects, we can change the way these subjects are taught. And we are, the Bootstrap project that was introduced here is changing this, right? So this is a sort of different line of thinking. It's what we call integrated computing. Rather than teaching computer science as a standalone subject, where a lot of the skills we're talking about there are anyway starting to become somewhat obsolete, why don't we take computer science and embed it in all these different disciplines, teach it in a way that makes sense for the discipline and also improves the way that discipline itself is taught. Okay. So we've been, doing Bootstrap itself since 2007. I've been doing outreach since about 1995. We have several different curricula. These are all free online. So you can, I'll put a URL up at the end. So everybody's welcome to download it and use it. We don't charge any money for that. Just take it, do whatever you want with it. We have several students, good percentages of people and et cetera, et cetera. What I want to do in this talk is I want to give you a concrete example. Okay, so I want to walk through a little bit of the Bootstrap data science curriculum, and I want to give you a very concrete sense of how a curriculum like this works. All right, so we're good. We're gonna now actually see a small curriculum demo of some sorts. Okay, all right. So the thing is, most of the Bootstrap data science data sets that we have are for an American audience. So I decided to take some creative license here. So I thought about what could be a fun data set that I could do with an Indian audience. And so I went to Wikipedia and I said, oh, I know what I'm going to get. Pardon me if this isn't your interest here, but I went and got a small data set that is something that I enjoy, which is, test cricket triple centuries. Okay. So if you go to Wikipedia, you get a page that looks like this. And it's got, of course, you have to have a picture of Bradman on there. It's got some cricket fields and so on. And then there's a giant, table of the data. Okay. So what I want to do is I want to now switch away from the slides. And I'm going to change my sharing to the browser window. Actually, yeah, I think I need to change the. So let me hit share. Okay. So can people confirm that you are seeing a browser window? Can you just wave and confirm that you're seeing a browser window? You're seeing like a Wikipedia page, basically. Okay, fantastic. You're seeing a Wikipedia page. Okay, so this is the same Wikipedia page, and you can see there's a table here. So what I've done is I've pulled the table out of here, and there's actually a little bit of massaging I've done to the table. So I pulled the table out here, and I'm using a tool called CodeApp that we've also contributed to. And so here is the table. Okay, so I have a data set, and you can see that there's various data over here, and this is all of the scores over here. Okay. Okay, so what I want to do, and again, people can see that there's a table on the screen now. Is that what you're seeing? Okay, yes. Can you just wave to confirm you're seeing the table? Okay, thank you. All right, so let's go and do some data analysis with this, okay? So my machine seems to be a bit slow today, sorry. Try to construct a graph here. Why is this so slow? Sorry, something is a bit wonky on my machine. Okay, there we go. Okay, so what I want to do is let's do some analysis. Okay, so let's, for example, ask who has actually scored these, which countries have actually scored these triple centuries. Okay, so I'm going to ask for the countries that are 4.
Shriram, is there any way you can make the screen bigger? Because I'm not sure how visible it is, particularly.
I see. Okay, tell you what, let me hopefully once I show the graphs, it will not. So hold that for a moment, and just you can tell me in a moment if it's still not very visible. Okay. So I'm going to take the 4 column and drag it over here. Okay. And I can just tell you what's going on here in a moment. I'm sorry, my browser seems to be in a really slow mood today. So I think the machine's a bit overloaded from running PowerPoint and so on. Okay, so here is, can people see the general shape of this graph? There's a graph here, and there's a bunch of vertical lines, right? There's a little histogram thing going on here. Is that generally visible? Can you raise your hand if you can see it? Okay, and so and I'll just read out the labels here to you. So basically what we're seeing is there's a large spike for Australia and a large spike for West Indies, okay, and a smaller spike for Pakistan. So basically Australia seems to have done really well at this business. West Indies seems to have done really well at this business, okay? And we can also ask for other plots over here. So I can ask, who have the scores been made against? And I'll drag that over here. And one moment. Okay. And so we're going to get another graph. And basically, all you need to know is there's a very tall spike over here, and that very tall spike is for England. Okay. So it sounds like, Australia and West Indies do really well at this, and England seems to be, that's good. If people beat up on England, that's fine. So England seems to get beaten up quite a bit. A lot of triple centuries seem to be scored against England. Okay, so that's an initial. So that this is sort of an exploratory data analysis, right? So we're looking at the data, we're doing some basic operations on the data, and finding out like, maybe something is really great about Australian and West Indian batting, and maybe something is really bad about English bowling, right? I mean, that, it sounds not implausible. But now we can also ask this question, like, where have these triple centuries been scored? So now I'm going to ask for which country were these triple centuries scored in, okay? And so I'm going to drag that in, all right? And in one moment that should come up. Sorry, this usually runs a lot faster. I think my machine is just having trouble running this many things at a time. Okay. Okay. And can people see that there are basically two spikes in this graph over here? Even if you can't read the labels, can you just wave your hand telling me that you see two spikes? You see two spikes. Okay. One of these spikes is for England, and one of these spikes is for West Indies. Aha. This is interesting, right? Because this now tells us that maybe we have to reinterpret what's going on in the for and against graphs, the left two graphs, in light of where the matches are being played. And now this brings us to something very important. If you're trying to do this kind of exploratory data analysis, you have to know something about the domain, right? You can't do it absent of the domain. And in this case, we have some knowledge about the domain. We know something about West Indian cricket grounds. We know that the major West Indian cricket grounds are actually kind of small and sort of batter friendly, right? So let's do the following. So now I'm going to use the transformers plugin that we built on top of CodeApp. Okay. And so what I'm going to do is I'm going to ask this transformers plugin to again, it's loading, one moment. Okay, something has gone wrong here. I think it's timing out. Okay. Why is this doing this? Sorry, I had this demo all built up and everything was ready to go, and now my machine is now letting me down. Okay, there we go. So I have this transformers plugin. And so what I'm going to do is I want to do an operation. So now I'm going to do a programming operation, okay, which is I'm going to filter a data set. So I'm going to ask for the filter operation. And I'm going to select the clipboard data. And what I want to do is I want to basically say, is this in the country not equal to West Indies? Okay. And now if I apply that transformation, okay, and so what we get is a new data set now. Okay. And this data set has 24 rows rather than 31 rows because we've taken out the 7 rows that were in the West Indies. Okay. And so now we can start to ask new questions over here. So for example, we can construct a new graph over here. Okay, so that went over there. Pull that window down over here so we can see it a little more clearly. And now if I go over here and ask, which countries have been scoring these triple centuries. Okay, so this is the same kind of graph we were constructing earlier. Okay. And now I'm just going to line up this graph with the previous graph that I had, right? And now we see something dramatically different, right? What we can see is the Australia column is still very tall. The England column has gotten shorter, but the West Indies column has almost completely disappeared. So essentially, it sounds like there's a huge home advantage to the West Indian batters. And if you take away that advantage, there's only one century or triple century over here. And if you click on this, you can see it's, it's Lawrence Rowe's triple century, but whatever, right? So if you click on this, you can see like what the data point is and where it happened and so on. And then we can start to build more of these operations, right? We can start to perform, actually, sorry, this is Chris Gales. Okay, so we can start to perform these operations. We can build up functions. We can ask, what are the matches? What are the things that happened related to the ashes? That would be a new kind of function over here, right? We can save the transformation over here, give it a name, and save it so we can reuse it over and over. So if we want to filter out West Indies from different things, right? And we can perform all these different functions here. We can build new things. We can transform them. We can perform grouping operations, sorting operations, some very basic statistical operations, and so on. And so we can do all of these things as a form of exploratory data analysis. Okay. I wanted to give you a longer demo, but the machine seems to be a bit slow, and I don't think that's a good use of your time. But I hope you can start to get a sense of what I'm doing over here. Okay. So what I'm going to do is I'm going to shift back to the slides instead. Okay. Give me 1 second. Slideshow. Here we go. Okay. Okay, so do people see a blank slide? Can you just wave saying you see a blank slide?
Not yet.
Okay, now? I think it's
Yes,
still waiting.
now, yeah.
Okay, good, good. Okay, so what I want to do is I want to talk about what we just saw. Okay, we saw 6 steps. So the first thing we did was we examined the data. Okay. Having examined it, we start to formulate some hypothesis. And as I said, if the machine had not been quite a little more cooperative, we could have generated many more, right? I had some hypotheses related to the ashes. So we could look at ashes related things. We can look at location related things. We could filter out England and see what filtering out England impact England has. And it's interesting, by the way, if you filter out West Indies, you see a dramatic difference. If you filter out England, you don't see quite as dramatic a difference. So somehow the England scores are somehow more sort of uniformly distributed, whereas the West Indian scores are somewhat, more biased. Okay. And then you can start to translate those into computations and actually perform these computations and generate new values. Okay. So again, we're doing computational work, very much doing computational work. But then we analyze the answers, and based on that, we might go off and we might iterate and ask new hypotheses, right? Looking at this output triggers new questions for us. And all of these steps that I took over here are actually extremely well-founded in different kinds of research. Okay, so the first 2 steps is a technique called notice and wonder that we borrow from math education to help, there's this term that we use in computer science also, which is sense making. How do you make sense out of a thing that you are given? You're given some abstract blob of stuff, and you have to try to develop some meaning about it. So we use this notice and wonder method from math education. All the computational stuff is taken from 2 of my books. One is called How to Design Programs. The other is called A Data-Centric Introduction to Computing. And the second book in particular is our approach at basically defining what a modern computer science curriculum, introductory curriculum would look like, right? So you you do these computations, and there's a lot of different scaffolding methods to help people do the computations well. And finally, you also need some kind of like either domain expertise or some sense of curiosity, some level of interest to be able to do this well, right? If you're not interested in this at all, then you're just going to like say, okay, tell me, hey, teacher, tell me what to do. You click some buttons, you get some output, and you move on, right? But if you have some interest in the subject, you tend to automatically, all these other techniques become useful because you tend to automatically care about the subject a little bit, okay? And so this is the kind of process that we use in Bootstrap Data Science. And we've done some research to look at how students actually do these sorts of things. And here's what we found. So we're looking, for example, at what they feel they learned, right? We can also look at what they've learned, and we can see that they've actually learned things, but we also want to know what student perceptions are of their learning, right? And I've divided it, it's sort of a 4-point Likert type scale. So the strong agreement, agreement, and disagreement, and strong disagreement. And what you can see is that basically the disagreement levels are extremely low, right? So they feel like they've actually learned something about programming, learned something about data analysis, and learned something about visualization and graphing. And these are all critical skills that they need anyway in any kind of schooling system, but they're learning this through the medium of working through these data sets, right? So we're trying to change the way computing is taught, the way graphing is taught. So we're changing computing, mathematics, statistics, business, all of these subjects through these kinds of computational methods. What we also find is like we let students choose their own data set, right? So I couldn't give you that choice, but in my case, I picked the data set. I picked something that I'm interested in, right? And when we choose the data set, and we see a very interesting contrast, about 40% of students pick a data set that is something that they already knew something about, but just as many pick something that they didn't know something about. So in the first case, they're already interested in it, they have some connection to it, and so they want to learn more. In the second case, they wish they knew more, and that's what drives their choice. But what's even more interesting, 16% talk about it affects them personally, right? They have some deep personal connection to this. And what kinds of data sets do they use? So now these data sets are in an American context, so they may or may not make sense in other countries. But these are the kinds of things. So we have students looking at food and health. So in particular, there are students who are getting these data sets about, how much sugar is in soda, meaning like, Coke, Pepsi, things like that, right? So soft drinks, basically. What's the nutrition in soft drinks? What's the nutrition values in cereals? What about snacks? They're looking at cancer rates in different communities. They look at, in the US, there's a lot of concern about the quality of policing, and how is policing disproportionately affecting different racial groups? So racial differences, for example, in police arrests. So these are things where, because we have this very diverse student population, some of these things are extremely personal. They may have a family member who was arrested, they think unfairly. And so now they have very invested in understanding what is actually going on in like police arrests. Of course, we have students interested in sports and entertainment of various sorts, movies and baseball and things like that. Different countries may be different sports, but we also have students who have environmental interests, so they're very interested in animals. Some of them, we work with students who are sort of low-income students who are interested in, what college careers might look like. So they are interested in data sets about colleges. So you can see how these things connect. If you give students a choice of data sets, right? And the thing is, we don't have to do superficial things. We can actually do deep things once we get student engagement. So we carefully design the data sets so that the data sets have in them all of the characteristics that we want the students to care about. And so teachers contact us and say, can we get a data set about X? Can we get a data set about Y? And we have some rules about what a good data set should have, right? It has to have certain kinds of characteristics. It has to have, so that we can ask all the relevant questions. But then the curriculum doesn't care what your data set is. The students are motivated by the data set, and they automatically go through and learn all of these different skills. They learn programming skills, a little bit of statistics, they learn visualization skills. And by picking these data sets they care about, you can see that they feel a deep personal investment. Okay. So what I like to say is that basically every child has a data scientist inside them, right? They all, and you know this, right? You know this maybe from your own childhood, or you know this maybe by watching students in your class. If there's something that they really care about and they want to make that killer argument, they will make that killer argument by pulling out statistics, right? If they want to argue that, Tom Brady is the best quarterback or Virat Kohli is the best batsman, they will go and pull out 100 different statistics, and they'll manipulate numbers in all kinds of ways. And these are the same students who'll tell you, I don't like math, I hate math, math is irrelevant, has nothing to do with anything. They will instinctively go off and do data science to make a point that they care about, right? And that contrast between the formal subject and the discipline that they think helps them is a very, very interesting contrast, and something that we deeply exploit. So a lot of our students are students who are either, they're at an age level where they're starting to lose interest in math, or they are starting to identify away from math, or things like that. And our approach brings those students back into the subject by presenting the subject in a very different way than the way it's traditionally presented in math classrooms, whether in the US or in India. Okay. And so in general, for us in the data science space, we talk about what we call the 4 ingredients model. Okay, so curriculum should have 4 parts. It needs to have a, so it needs to have domain knowledge. It needs to have some amount of programming, some amount of statistics, and the critical 4th component that a lot of people forget is some sense of civic responsibility. Okay, because it's very easy to run some statistics to get some answer and then go off and say that's the answer. And in some cases, people even go off and make national level decisions, international level decisions like austerity decisions, just by computing an answer and not asking enough questions about it. Okay, so we care deeply about the civic responsibility part also, which is to ask questions and to force yourself to interpret the answer so that you make sense out of it and make sure that the answer has some validity. Okay, and all of these are interlocking pieces. But the reason we use the word ingredients is just like, you know, when we're cooking, right? When you have ingredients, you have a choice about how you combine them. Okay, you don't have to put all of them at the same time. You don't have to put the same amounts. You have to, you can use variations. And depending on the needs you have, depending on the kind of dish you're trying to make, use different combinations. You can make it hotter, you can make it saltier, you can make it spicier, whatever, right? But ultimately, if you leave out something essential, you don't get the same dish, right? And that's why we talk about this as the 4 ingredients model. You want to have all those ingredients so that at the end of the day, you're not just doing some data science, you're actually doing responsible data science. Because as we're moving into this AI era, I assume that this is, I don't need to tell you this, I assume you're all aware of this, but increasingly we have social decisions that are made by data and by AI. And if you don't understand the data that went in, you will get garbage out, and that garbage out can actually harm people. There's no shortage of articles now that show the actual harms, outright harms that are done by the bad use of data science and artificial intelligence. So if you want to do these subjects and you're not talking about the social impacts of this, you're not doing it right, right? That would be an essential ingredient. Okay, so that's a quick overview of our data science curriculum. And in general, as I said, we do several subjects and they all have a kind of, you know, a playbook, right? There's the same story we do in all of these. So we start off with some bottom-up thing, right? In the algebra curriculum, we say, hey, kids, we're going to design a video game. And here's what you get to do. You get to design your own game. But of course, we carefully limit the kinds of things they can do so that we can achieve all the same learning objectives. The real-world data sets are curated to achieve learning objectives. Physical experiments to achieve learning objectives. So you always start bottom-up. The bottom up is the motivation. It's the thing that creates excitement. It creates engagement. It creates student investment in what they're learning, right? They get to personalize. They get to pick what they want to do, but within bounds so that they stick to the thing we are trying to teach them rather than going off and doing some random thing on their own, right? And then we use several aspects of math and statistics and programming and so on to guide the design, to scaffold it, to help students who are having trouble be able to be successful, to aid in the debugging and so on. And it doesn't look anything like what you traditionally do. We don't even have a debugger. I have built several programming languages. We build and deploy programming languages on the web. None of them has a debugger built in, because our methods of debugging are very, very different from what you traditionally see in a computer science curriculum. Okay, we use and we can talk about that later on if you want. So the point is, we have all these different aspects working together. And at the end of the day, right, our goal, of course, is that we want our students to be able to, perform these activities that are authentic, right? If you go to a math class and say, I want to teach for loops, and I want to teach variables that change, and I want to teach functions that don't pass the vertical line test, a good, responsible math teacher will chase you out of the room, right? That is the only responsible thing to do. To say, look, you call it a variable, but your variables don't work like my variables. You use the word function, but your functions don't work like my functions. In fact, your numbers don't even work like my numbers, right? Like in Snap, certainly, and I think also in Scratch, like basic arithmetic doesn't work the way arithmetic works in the world. So if you're a math teacher using these, you're basically telling your students two completely different stories about mathematics, and that's not authentic. That doesn't make any sense. Instead, these subjects reinforcing each other, systems like Snap and Scratch and Python actually de-enforce each other, right? They're actually in combat with each other, and you're using the same words to mean two completely different things, And math teachers reject that. Stats teachers reject that. So when we go to these subjects, we have to teach the subject in a way that they find authentic. Otherwise, they will never do the integrated computing. Okay. The other thing we do in the US is we team with various national teacher groups, because that's also how we make sure that we're actually doing the subject in an authentic way, not just making up our own thing. Okay. So the advantages to thinking about these kind of integrated curricula is there are lots of very practical advantages, right? You don't have to find extra teachers. You don't have to find extra money. You've already got time and space the curriculum. We don't have to throw some subject out. But I think there's a more important advantage than that, which is, as I said at the beginning, computing is something that is done in a context. There is very little pure computer science being done in the world. Most computer science in the world is actually being done in a context. So for the vast majority of our students, the way we should teach computing is also in context, right? The small percentage are going to go off and do like actual computer science. Yeah, I mean, I'm a computer science professor. Of course, they need to know those basic skills, but that is a much smaller percentage. The vast majority of them need to know the kinds of skills that I'm talking about today, okay? Now, you might say, well, look, okay, but let's just focus on the practical aspects, right? We already have a computer science course, problem solved. Well, I don't think it's that simple. Because if you look at what's happening in computing education, every few years, there's some kind of X for all, right? So we had CS for all. Now there's a data science for all. There's already people talking about AI for all. And there's these new waves over and over. And the question is, how many courses are you going to add to the curriculum? To add a course, you have to throw something out. How many subjects are left for you to throw out? There's nothing left to throw out. Where are you going to find the teachers? Where's the money to pay for all of this, right? So in the short term and in the medium term, just keep on adding these courses isn't going to work. Now, you might say, oh, we're done with computer science. Now we're going to do data science. If that's what you think, then why were you teaching computer science at all? Maybe you didn't believe it was that fundamental if you can keep throwing things out, right? So either you believe it's fundamental and which needs to stick around, or you think it's not fundamental and then like there's a question of why you're even doing what you're doing. Right? So this is not a thing that's going to get solved in the next few years, right? We have to keep being adaptable to these different waves. But I want to make a broader point, which is that these are not just some short-term thing, okay? First of all, it's a long-term strategy for accommodating new needs. Secondly, it's an educational strategy that shows how subjects connect. One of the main weaknesses we have in school curricula all over the world is we teach each of these subjects completely isolated from each other. Okay, but when you go into the world, you never practice these things in isolation, right? If you're standing in a line, if you're trying to achieve some task, you don't get to say, is this a civics task or is this a programming task? Because those are not allowed to connect, right? So if you don't connect the subjects in schools, you're forcing students to find the connections for themselves and they won't necessarily do it, right? That's the whole problem with the computational thinking idea, is it assumes people will just magically make connections the way Jeanette Wing does, and most people do not, right? And finally, one of the nice things about this integration idea is we get to revisit subjects many times. So we, for example, are now doing data science. We're starting to do in the primary school. We already do it in the middle schools. We do it in the high schools. We do it at the college level. And this is what good curricula look like. Spiral curricula are the idea that you revisit an idea, a topic over and over and over, each time in more and more sophistication. Right? So you see the topic many times, you see it in more sophisticated contexts, but you have some background to build on. And that's how layer upon layer, you eventually develop a deep understanding of a subject, right? But if you just teach things in silos, you're not going to get this. And this is why we are very big believers in integrated curricula, because then we can reinforce the subject in many, many different ways, right? So last comment I want to make is that for us, everything is a research-driven curriculum. We have PhDs in all these different subjects that I've talked about that are on the team. And if you go to our publications page, you'll see a whole bunch of papers, some which are about the impact on students, some which are on curriculum philosophy, some which also are on the technologies that we build to enable all of these things to happen. Okay, so that's Bootstrap in a nutshell. I've given you a walkthrough of the Bootstrap data science curriculum, shown you a quick example. You know, if you want to learn more about Bootstrap, you can go to our website. DCIC World is the new textbook that we're writing. That's sort of our reimagining of how computer science should be built for the modern age, right? For the data-centric age. So DCIC stands for Data-Centric Introduction to Computer Science. So I'll leave these URLs on here, and now I'm ready to take questions. Thank you. And feel free to, you don't just have to ask questions. You're also welcome to push back. You're welcome to criticize things that I've said. Anything is fair game. So please feel free to express your thoughts. The only thing I would request is people who are in the rooms, if you can either come up to the front or use a microphone or something, because it's a little hard to hear the people at the back. Okay. Thank you.
Okay. Thank you very much, Sriram. We covered a lot of things, including making the students pick their own data sets, make their own hypothesis. You covered the civic responsibility in data science. You covered how to make time for computing. That's one of the challenges teachers always have. Yeah, now it's time for questions. So anybody...
And thank you. That's an excellent summary. I think those are all the main points that I was trying to make. Thank you.
Anybody in the room who have questions, maybe you need to route it through somebody there. And if somebody has questions in Zoom.
Yeah, you're welcome to type questions on Zoom as well, anything. And comments, anything is welcome. Criticism is welcome too. Yeah. As I said, I have a pretty strong position about computational thinking, and it is not the position that this conference takes. So I'm happy to stand up and discuss these controversial points too.
No, I think this whole day today, I remember the talks were all about CTE in math. So
good. Okay.
There's a lot of people who resonate with what you talked about.
Wonderful. I see there's somebody in the front who's got a microphone. Can you please go ahead, ma'am?
Hi, thank you so much for that. That was brilliant. My name is Alita, and I'm a great fan of human-computer interaction. I'm from New Zealand, and we do quite a bit of that. You touched a bit on that, especially when you were talking about integration of subjects as you push on to the senior level, especially looking at high school. Could you talk a little bit of how that relates to when they're moving into university? Because heuristics is a basic thing. Are you focusing a little bit on that as they start pushing into that curriculum area? I'd love to hear that.
Yeah, that's a great question. I think, wow, that's a great and complicated question, because there's actually many pieces, as you know, to the question that you asked. At the university level, it's a little difficult to say anything uniformly, because certainly in the US university context, which is the one that I understand best, having lived in this country for many years now, there is no standardization at all. Right? Every university is welcome to do whatever it wants. Nobody standardizes their curriculum with anyone else. Yeah, there's some ACM curricula. As you know, the ACM curricula don't talk about any of these subjects, right? So it really gets left to individual departments to decide what is important that's not in the ACM curriculum and decide how to work that in. Right. So, for example, in my department, we have both huge strengths in both human-computer interaction and various forms of AI and reasoning. And so we think these topics are important. And so we work these into early courses. Right. But I think in a lot of departments, that's not the case. And in fact, this is one of the problems with the ACM curricular structure. The ACM curriculum structure always lags computer science by 10 to 15 years. In fact, I'm talking about data centricity. If you go look at the ACM curriculum standards, right, the last ACM curriculum standard was about 2012, 2013. It barely even talks about the existence of data in the world. And this is ironic, right? Because the major deep learning papers came out in about 2010. By 2012, it was clear computer science had changed dramatically, right? We lived in an era of data-driven algorithms, and traditional algorithmics was now completely complemented by a new form of algorithms. None of that is present in the ACM curriculum, right? They're still fighting some 50-year-old battle about objects first and nonsense like that. So I think the problem is that the ACM curricula are not at all useful guidelines for designing modern curricula. They are very good guidelines for designing a 20-year-old curriculum. And then the kinds of things you're talking about are really left to individual departments. So, I certainly think about these things. I certainly talk about some of these things. Some of these HCI issues show up in my class. A major thing we're doing in my department that my colleague Kathy Fisler is spearheading is what we call the responsible. So this is a little broader than HCI and heuristics, but what we call the Responsible Computer Science Initiative. So the idea is, we in particular, Brown is an elite university, so our students go off to the kinds of companies that you all named over here earlier, right? Google and Apple and so on. And so they are going to be part of the key technologies we're going to use. And so it's especially important for our students to understand the perils of technology as well. So what we are doing is marrying the technical subjects with a responsibility component and understanding the social impacts. So for example, most of my introductory course assignments, there's a technical component, and then there's a reading component that somehow gives some commentary on it and puts it in a social setting and talks about the human-computer interaction aspects, but it also talks about the security aspects. It talks about the threats to human society aspects, and then they have to do some reflection writing. They have to do essay writing in an introductory computer science class. Right. And so all of our courses are now starting to do this, and we're doing this across the curriculum. Again, it's the spiral model. They see some amount of responsible computing early, then they see a little bit more, they see a little bit more. In fact, we have 6 of us faculty have a project where we're trying to teach adversarial thinking, which is an idea from security. We're trying to teach adversarial thinking across the curriculum. So we do it all the way from introductory classes, intermediate classes, all the way to graduate seminars, seeing it in greater and greater depth. And I really recommend this sort of spiraling out, because all these topics are too complicated to do once, right? If you do it once, people don't remember it. If you do it once, you have to pick one level of sophistication. You can't go below it. You don't go below it because it seems too weak. You can't go above it because it seems too hard, right? But thinking about it as spirals, where whatever the subject is, whether it's adversarial thinking or heuristics or HCI issues or whatever, social threats, doing it in a spiral way really, really works well. And it's also a small footprint each time, right? You don't have to throw out the whole class. You can add a small component here, a small component here, a small component here, and you get reinforcement as well. That's a sort of long and somewhat complicated answer. Was that a reasonable answer to your question?
Was, thank you.
Thank you. Good. Other questions or comments? You're welcome to do them on Zoom as well, please. Oh, I think sounds like there's a person in the front who wants to ask something. Please go ahead. Yeah, please.
Hello, sir. I'm Satwik. I'm an independent educator. I would like to ask a question from the perspective of students. So please allow me to use computational learning instead of computational thinking. So India poses a big challenge, and there are lots of students and not very many good computational thinking teachers. So are there some good ways of computational learning without a teacher? And if yes, what are they and how good are they?
Yeah, that's a really great question. Look, so I'm from India. I understand the problem that you're talking about. In some ways, we have this problem everywhere, right? I mean, the US also has lots of schools and teachers. They all show up to work, but that doesn't mean that they're necessarily fantastic either, okay? Our approach in Bootstrap has been that we still respect teachers a lot. We are, the sort of the computer science attitude is everything is about disruption, right? And the most disruptive thing you can do is to like throw the teachers out of the room and replace them with computers. In fact, the problem is if you look at the research, it does not work out that way at all, okay? Most of the research studies that people have done, people have been building tutors for a long time. And there's the sort of, this famous Bloom 2 Sigma paper. And these tutors don't get anywhere remotely close, even after a ton of work. Right? So it's not clear that there's a good substitute to having a teacher, but it's not clear that the teacher has to be an expert, right? So our model in Bootstrap is we want an adult in the room. We don't want to just put kids in front of a computer all day. Adult in the room. So the person in the room may not be a subject matter expert, but they need to be like somebody who can sort of keep the kids sort of on track, right? And if you assume that, we design our curriculum to be extremely fault tolerant, right? So for example, the reason we use these curated data sets and we use data sets that have a very specific format is because if we leave it to the students to pick whatever they want, they will rapidly ask questions the teacher has no idea how to answer. Right? In Bootstrap Algebra, for example, we say you're going to design a video game. And you're like, oh, I'm going to design a video game. I'm going to make Doom. I'm going to make World of Warcraft. No, you can't do that. And the reason we don't want to let them do that is because they'll go off and do all sorts of random things rather than actually doing the thing we want them to learn. We want them to learn math. We want them to learn algebra. And instead they'll be like, going off and designing avatars and clothes and stuff, nonsense like that, right? So what we say is, look, how much does a game cost? A video game like World of Warcraft costs, tens of millions of dollars. Okay, does anyone have $10 million in the room? No, nobody has $10 million in the room. Good, okay, we've confirmed that. We have like, I don't know, so, $2 or some 25 paise or something like that. Okay, so with the money we have, we're gonna have to design a more modest game, okay? So what we're gonna do is we're gonna do a game where there's gonna be, in fact, here, I can actually show you a video of one of the games, okay? So here is sort of the motivating example we give them, right? So I'm going to play this for you. Okay, and this is called Ninja Cat. So there's a cat that's dressed up as a ninja warrior, and there's a dog, and the cat is trying to evade the dog. The cat's also trying to get the ruby, right? And there's a score at the top, and every time they get something, they get something. And then if the dog eats them, then the cat dies, and you end of game, and everyone feels very sad. Okay, so the point of this game is there is a target. They're trying to get the rubies. There's a danger. There's a player, which is the ninja cat, and then there's a danger, which is the dog. Okay, and you're trying to avoid the danger while you're trying to get to the good stuff, right? That's the entire game. Now, it turns out that is enough of a game to get students completely motivated. So here is, let me see if I can get this slide up over here, right? So here is what we find when we give students just that many variables. Do they feel like they made a real game? So you're looking for blue and red, okay?
No,
blue is strong.
The screen is blank for us. We don't get
okay.
There is a lag. Now yes.
Now you can see it. Thank you. So
no.
you're looking for blue.
No,
you're looking for blue and red.
It went away. We saw a circle, but it went away now.
Now anything?
Not yet.
Not yet. Okay. So the bottom line is the numbers look very much like the data science.
Now we see it. Yeah.
Thank you, Venkatesh. Thank you for helping me out here. So you're looking for the blues and the reds, right? Blue is strong agree and red is agree. Okay. Do they feel like they made a real game? Well, obviously it's not a real game, right? It's nothing like Minecraft or something like that. But they still feel like they made a game. They agree. Some of them even strongly agree, right? Do they feel like their game is different? In fact, everybody's writing the same game. Mathematically, they're isomorphic because they have only these 3-4 parameters they can write, right? But most of them feel like their game is different because of the small amount of customization, right? Are you proud of the game you made? That's in some sense the most important thing. Most of them are extremely proud of the game they made, right? A small number are like hardcore gamers are like, what is this crap? But most of them are actually extremely proud of what they did. They want to show off their accomplishment. And when you look at the themes of the games they design, right? Some of them design environmentally themed games. So one of my favorite examples there is a student who designed a game where they wanted to, the player is an astronaut, the danger is asteroids, and the target is space junk. They had read about space junk and they heard that there were people who were polluting space and they felt badly about it. And so they designed a game to express their feelings about it, where the astronaut goes with a fishing net and tries to grab space junk, right? It's bizarre, it's ludicrous, it's hilarious, it's wonderful, it's heartwarming, right? Some of them make humorous games. Some of them tell true stories about things that happen in their lives. Some of them talk about friendship. So like one student was like, my brother is really into Batman, so I made a Batman themed game just to make my brother feel good, right? So they're telling deep stories. You don't have to be in Scratch to do this. You don't have to give people unfettered access to the whole world, because if you do that, you will not be able to control the learning outcomes. We have very tight control over the learning outcomes, right? And in computer science, we've kind of made a fetish out of creativity, and I think it's complete nonsense. We don't actually understand very much about creativity. We just throw this word around without really understanding it, right? What we want is instead, so I'm getting back, so this is all part of answering your question. We narrowly restrict what needs to be done so that the students can't go off in random ways. That's the thing we train the teacher for, and that's what our teacher notes and teacher materials are about. We basically tell the teacher, this is what you need to know, and we have constrained the problem enough that even if you're not an expert in the subject, you can still teach this responsibly and your learning objectives will be met. And that's the real question you need to be asking, right? Can you find a curriculum that constrains things enough so that a non-expert teacher can still do things while there's still plenty of opportunity for the experts to go ahead? Okay, that's our approach. We don't believe in putting students in front of a computer all day. We instead believe in having the teacher, but giving them all the resources that they need to be able to teach well, even if they are of low skill and low training, because if they do it several times, they become way better at it themselves, right? We have faith in teachers. We believe deeply in teachers. We love teachers. This is not true of a lot of disruptive computer science people. We think very highly of teachers. We believe that if they're given support, they're given resources and practice, they will become very good themselves. We just need to help them get off the ground, and all of our materials are geared towards that. Okay. So I don't know if that answers your question. I don't know if that was the kind of answer you were looking for. I suspect you were maybe looking for me to say, go to foo.org.
I don't build foo.org, and I don't believe in foo.org, and I will tell you the research does not support foo.org. And I guess maybe I should I make a controversial statement? Yeah, let me make a controversial statement. Companies that advertise on the Indian cricket team, their logos are on the Indian cricket team vests, probably are selling you a bill of goods. Okay. So I think there are lots of very serious questions we can be asking about various, Code Junior and blah, 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 and all these other different companies that are very popular in Indian ed tech. I think there are lots of serious questions we need to ask about them. They do not evaluate their work. They do not tell you whether their work is good or not. They just make a lot of money. They make middle-class parents feel very bad about themselves and like force them to spend a bunch of money to send their kids to all these online classes. There is very little evidence that I have seen that these classes are any good and that they actually have good learning outcomes. Right. So what they will do is, of course, they'll give you anecdotes. They have 1 million students. And then what they'll instead tell you is like the 2 students who built a game and started a company. That doesn't tell you any, those 2 students, maybe you could have given a broomstick and they might have started a company too. We don't have any evidence that these are any good. So was it Akshay? I think your name was Akshay. I'm sorry, or was that wrong? But I hope that answers, I'm sorry, whoever asked the question, I hope that answers your question. And if not, you're welcome to ask a follow-up.
Thanks, Sriram. There are a couple of comments in chat. One.
Good. Let me take a look. Neil, hello. You mentioned domain knowledge and civic responsibility and went on to say you don't need to find. Yeah, that's a great question, Neil. We do need people who are at least somewhat like humanly engaged. But the great thing about integrated curricula is that that expertise is actually sitting outside computer science. So when we go and work with a civics teacher or a history teacher or a geography teacher, in the US, these are all lumped into a subject called social studies. But if you work with those teachers, they have that expertise in spades, right? A civics teacher doesn't understand a lot about like functions, but a civics teacher understands a lot about civics, right? So what we do is we give those teachers and those subjects enough training to be able to do this curriculum, but then they have the domain expertise to engage with the students and ask them these kinds of questions, or at least we hope they do, or at least we hope that we are inspiring them to do that. I hope that answers your question, Neil. Sylvia, that is a fantastic question. Thank you so much for asking. Have you looked at some of the work, including children with disabilities, especially with visual impairment? And
sorry, you may want to read the question for the benefit of.
I will. Thank you. So Sylvia Veerraghavan has asked, have you looked at some of your work in working with children with disabilities, especially visual impairment? What I'm essentially asking about is inclusiveness. We care very deeply about this. In fact, even if we didn't care, we kind of don't have a choice because we work in American public schools primarily, and American public schools have all kinds of legal requirements that they have to be open to all students, and students with disabilities have to be treated fairly. That's in the law. There's an American Disabilities Act. So it's legally a requirement, but also for us morally a requirement. So in fact, we have put a ton of effort into making our things visually accessible to visual impairment. And this is very critical because if you use Scratch, for example, Scratch is basically unusable by blind programmers, right? Any kind of block editing environment that requires people to drag and drop and put things in a particular place is inaccessible to people who are blind. It's also very difficult to do if you have any kind of motor impairment, right? Because you have to do very precise fine-grained movements. That's very, very hard to do. So on the one hand, we've actually built a block programming environment for visually impaired people. We actually collaborate with a blind programmer and we've published some research on it, so help other people also build this. But we also are IDEs visually impaired. We do a lot of work. In fact, Vince Cerf, who's one of the inventors of the internet, Vince Cerf is a big supporter of us because he's big into supporting this. And Vince Cerf actually wrote an ACM blog post just about Bootstrap's work on visual impairment support. So it's a very big deal for us. It's a legal requirement in the US, but even if it's not, it's a moral requirement. And I would actually ask people who use things like Scratch to think hard about this, because how would you support a student who's blind? How do you give them a good experience? One of our most remarkable experiences actually is we went and taught a mini course for a group of blind students in Alabama. And we did the Bootstrap algebra curriculum, which actually starts with visual output. And you're thinking like, that sounds completely nonsensical, but we've actually instrumented our IDE to be completely usable through voice technology. And so the students actually get verbal descriptions, careful verbal descriptions of the visual output. And there's actually it's part of our research paper talks about how we do that. And so for the students, it was the most exciting thing because they said, look, normally we get taught a different computer science curriculum. Our friends get to do all this cool stuff, and we get like the visually impaired version, which is far less fun and far less exciting. And it was exciting for them to get the same curriculum and to get that feeling of being able to create output and get it through their screen reader. And it was tremendously empowering for them. So this is something we actually take very seriously. It's a research effort, it's a development effort. And I have papers on this on my website. You're welcome to reach out, and I'm happy to share with you the software and the web. And again, all the software is public online for free. Everything is free. All of these websites completely free. So people are welcome to use them, and we encourage you to. And Sylvia, thank you for asking the question as well. It's a super important point.
Thank you, Sriram. Let's take one more question from the room and then wrap up.
Yeah, sorry, we may be running over time here. I apologize.
No problem. I mean, it's great you're engaging with it. Yeah, somebody from the room. Last question.
There's somebody there. Hello, please go ahead.
Yeah, this is Pallavi. Thank you very much for that statement. We have fetishized creativity. I mean, that just speaks to me like nothing else. But right in the beginning, you said you will touch upon this in the Q&A section about research-driven skepticism for CT. Could you elaborate? I'm really curious for that.
Absolutely. I actually have a whole talk on this, and maybe I should share out the talk video. So here's the thing, okay? If you go back to Jeanette Wing's claims, the idea here is that if you understand computation, you will be able to apply it in all sorts of places socially. Okay, and she gives all these examples, right? How do you put things into a backpack? Well, that's a bin packing problem. Which queue do you select in a supermarket? Well, that's a queue. That's a queuing problem, etc. Okay, the fundamental problem with all of these claims is that they depend on a person being able to recognize that same situation outside of context. Right. So if I'm in a computer science class and I'm told, here's a queuing theory problem, I'm like, queuing theory, that's fine. When I'm standing in the supermarket, do I recognize that the problem of choosing between the different lines in the supermarket is the same problem I learned when I was studying how to allocate jobs on a server? This in education, not computing education, in education research is called the transfer problem. Transfer is, do you recognize something in one context and be able to apply it in another context? In some sense, that is the essence of education, right? Like you have truly understood something when you can apply it in a different context. Transfer is one of the hardest things in all of education. The first paper on transfer was written by Thorndike back in like 1902 or something like that. People have been trying transfer for decades now, over a century, with very limited success. We now have some understanding of what it takes to achieve transfer. You have to actually show like parallel elements. And even then you can transfer to one domain. That doesn't mean you can transfer to another domain. And so in Bootstrap's case, we actually use the research on transfer. So in the Bootstrap algebra material, for example, we have very, very, very explicit steps to show the transfer between domains so that students who learn the programming understand why it helps math, and who see the math understand how it connects to programming. But you have to do it at an intimate level, right? And if you don't do it at an intimate level, it does not happen. The problem is the kind of person who becomes a computer science professor. I mean, I know Jeanette personally, the kind of a person like Jeanette or myself or, Venkatesh or Neil or people like that, right? We are people who sort of instinctively transfer, right? So we're the kind of people, Neil, is that a talk from EPFL? That's the talk. So yes. That's the one that maybe, yeah, thank you. That's the URL. And maybe if you can share it around to people in the room later on, that would be great. So we are instinctively transfer oriented people. I mean, I go to supermarkets, I use radix sort to reduce the time I spend in a supermarket. So we look at this, say like, of course, everything transfers. Do we not see it? But in fact, we also have all kinds of blind spots. I have done studies in my computer science classes. In upper level classes, do students recognize the halting problem when they see it in a programming languages class? They do not. And if you think about the way we teach things like the halting problem, it's unsurprising they don't. Let L be the language of an automaton. Well, what the hell's an automaton? What's a language? We don't see those. So even very well-trained computer scientists in an elite university do not form transfer easily. All the claims in Jeanette Wing's paper are based on a deep, deep lack of understanding of a fundamental central problem in all of education. And if you don't solve that problem, which we will not be able to solve because that's not how human brains work, without very deep attention, none of those things are going to happen. So Jeanette Wing sold a bill of goods by talking about computational thinking. It does not transfer, and without transfer, all these claims don't mean anything. Does that answer your question? I hope that sheds some light.
Okay, one last question from the room.
Of course.
Thank you, Sriram. It was wonderful hearing the word integration. And for us in India, the national education policy talks about integration. However, I would like to share with you, most of our schools are in the space of knowing and understanding. We have not gone beyond that. So it's only knowledge and understanding. So we have not synthesized, we have not analyzed. So transfer is going to be very difficult for us. However, many of our schools are doing the playway method. And in the playway method, in the kindergarten, many schools are doing transfer without knowing that it is transfer. However, I would like to ask you one question, that if we start integration in our schools right from kindergarten up, how often do you think we need to have these sessions? Is it to be done as a project? That is one. And the other is, we have a design of the classroom, which is basically very individual oriented. Just like the hall where we are sitting just now. It's a lecture hall. So the entire design of the space where our Indian kids are learning needs to be changed. So that is the second question. So if we want to bring about integration into our schools, is it going to be a group work or is it going to be an individual work? And if you can throw some light on that, I'm sure our teachers and educators are going to be really happy to hear about it, because we are struggling with total literacy. And then suddenly we hear about these new words with the NEP has spoken about, that is integration. And whether to provide knowledge or whether to do transfer is something which we are really working hard on. So please,
no, this is a fantastic pair of questions. You know, I actually find it very amusing, right? Like there's something interesting that happens in the schooling process, which is you start off with having one teacher throughout the day, right? And so there's no division of subjects. You don't have to, sorry? Sorry, I don't know if somebody was objecting to that, but it's certainly the case.
We are not able to hear you.
Oh. Testing.
I can hear you.
Yeah, the Zoom audience can hear you fine. I think.
Zoom audio. Okay, so it's not the computer. So
now we can.
Testing.
Yeah, go ahead.
Yeah. Check. Yes, I see people waving, so I'll assume that means good, right? Wave if you can hear me in the room. Okay, good, fantastic, thank you. Okay, so, and again, if something happens, if you can't hear me, just wave again, so I'll know that I've stopped being audible. So I think something interesting happens in this whole entire schooling process, which is you start off with just one teacher for the whole day, right? So you don't have this division into subjects. So it's sort of almost whatever process you use doesn't really matter, because it's the same person. They know about the things that they talked about earlier in the day, the things they're going to talk about later in the day. The interconnections are very automatic. Right? And then somewhere in every country, it depends on some age level, but at some age level, we start splitting things up into different subjects. And when you start splitting things up into different subjects, now all of a sudden, all these communication boundaries have been introduced, right? So our goal with integration is to say, look, in some ways, the computing teachers should talk to the teachers in other disciplines, or what we actually do in the US is we directly train teachers in the discipline. We directly train math teachers, we directly train social studies teachers, we directly train stats teachers. We don't even worry whether there's a computer science teacher around, and because in many cases there isn't one, and it doesn't matter whether there is one or not, right? So you are absolutely right that a lot of schools, and it's not like the American school system is that much better than the Indian school system, right? It's a similar sort of problem. It's very sort of factual knowledge, very basic knowledge and understanding kinds of things. But I think it does require teachers to be willing to look at the world in a slightly new way, right? One of the things that happens with these notice and wonder techniques that I talked about in math education that we are now applying in computing and in data science is the teacher has to be willing to let the students talk freely, right? And that's a big leap, right? If you're used to being the disciplinarian in the room, now you're suddenly letting people just talk. Like, what's that all about, right? But if you don't let that happen, your students aren't going to learn, right? So how to overcome that is not a problem that I know an easy solution to. I think that's more of a conversation, but I think forums like this are really valuable because I imagine there are some people in the room that are completely comfortable letting students talk to each other and having the class get a little bit out of control. And then there are teachers here who feel like that's a terrible thing. And I think you should use a venue like this to have the former group of teachers bring the latter group of teachers along, form mentoring partnerships, right? A teacher who's nervous about letting students talk in the classroom should partner with a teacher who's comfortable with it and refer to them and say, hey, this is what happened. How do you control this? This is what I want to do. How do you do that, right? Mentor each other and enable each other, form these partnerships where you let people start to explore these kinds of ideas of letting students talk. I mean, look, I went to school in India, right? I went to school in Bangalore. I went to a place called St. Joseph's, and my teachers were absolute disciplinarians. My school was very proud of being discipline oriented, and discipline oriented means you shut up and sit quietly and do not ask any questions. And my most memorable teacher was the teacher who basically like, screw it. It's okay if students talk to each other. What's the worst thing that's going to happen? They'll actually communicate and they'll like enjoy class, right? And that was the most, and that was the teacher who taught me stenography, right? It was the most boring subject, and yet it was the most memorable because the teacher was basically like, it's okay. I'll give these people some respect and let them, be as individuals, right? So you can do this at a venue like this, is you can bring teachers along, and the ones of you who are further along can bring the rest of you along, form mentoring partnerships, talk to each other every 3 months, talk again next year. There's this great Japanese education tradition of what's called lesson study, where they develop curriculum materials. You can do something similar to lesson study, but not for curriculum materials, but for teaching approaches, right? Getting people to become more relaxed and become a little more flexible. That's one part of it. Okay, so that's one aspect of it. The other aspect, you asked a very, very profound question about the physical layout, right? Like, do you have these individual desks? I mean, that's true in the US as well, right? Now, sometimes in India, you have these benches, right? So at least people are sitting next to each other without the partitions. But teachers, again, have to be willing to let students lean across and talk to somebody on the other side, right? Like, again, our attitude is one of like, they might be cheating. That's not cheating. That's called collaborating. It's perfectly okay. Let them collaborate. Let them talk to one another. Talk to them. Let them talk in pairs, triples, no singles. In my class, rule is no singles. Triples are fine. Pairs are fine. No singletons, right? You have to talk to each other. Make it a culture of talking to each other. You'll go a little bit slower, but your students will learn that much more. And again, there are people in the room who are comfortable with that. You have figured out how to overcome the physical barriers of the space that you work in, okay? Help the others. Venues like this, frankly, it's far more valuable if you ask me. And you're not asking me, so it doesn't matter what I think, but I'll just say this anyway. In some sense, like all these little, like, here's the cool new thing I did with Scratch is actually infinitely less valuable than talking about changing your research methods and making your fellow teachers feel comfortable with opening up and relaxing a little bit. That will have a much greater impact on computing education and education in general. And that's what I feel you should be doing, and using these opportunities of getting together virtually or physically to make the most of that. Does that make sense as an answer? I'm sorry, it's a little preachy. I didn't mean to get too preachy there. I apologize that I did get preachy, but hopefully that answers, that helps answer your question a little bit.
Thank you, Sriram. I think with that note.
Yeah, we really need to stop. I'm sorry, I've gone way over time and I apologize for that, but you are such a wonderful audience. Thank you so much. Thank you.
Thank you very much. And I'm sure many in the audience would like to keep in touch with you and continue the collaboration. And I'm sure
please do. Yeah, Sylvia, you're welcome to write to me and show you pointer to material. Anybody else who wants to write, and I really hope I'll get to see some of you next time I'm in India. So in Bangalore or someplace else.
We hope to see you in India again. Yeah.
Thank you so much. Bye-bye, everyone. Thanks so much for coming.
With that, I think it brings the curtain on today's program in CTiS. So we will see you all tomorrow, I guess. Any word from the organizers?
So they just want to say a big thank you. I think your talk has a record of receiving the maximum number of claps in the whole day. Yeah, thanks a lot. See you.
Thank you so much. Thank you. You're all wonderful. Thanks. See you all in person sometime. Bye-bye.
Bye.
Morning, 9 a.m. back for more teacher talks. Yeah. Sonia's promised to give us a very good dinner. So come for dinner, sleep early, get up and come back here by 9.